Now let's understand how Java is write once, run anywhere. So this is a very famous interview question. What is the difference between JVM and JRE and JDK? So now enough of theory. We have checked a lot of theory till now. Now it's time for the implementation. Now the main part to remember here in this is you don't download this one because it says free 30-day trial. This is the ultimate edition, which is a paid version. Okay, so we don't want to pay. Amazing, right? So this is your first Java program. So basically this is the bytecode. The compiler has converted your human readable Java code into something as the bytecode. Let me show you like how the bytecode looks like. It's not a human readable code. So let me open that in Notepad. So see here, it's like a weird kind of thing which is difficult to understand, right? So this is the bytecode. So awesome, we have now also executed this code from the command line. So Java is a case sensitive language. Let me show you an example. Here you can see we have written the class keyword in using small alphabets, right? So let's make it camel case. So now if you see here, we are getting an error and it is not able to identify any other things as well because class with C capital is not defined anywhere. Now your file name should be same as your class name. So this is the exactly same thing. This was maths, this is Java. So good learning here. If you do integer divided by integer, it will simply give you integer value. It won't include any precision after the decimal. But if any of the variables like a or b is double, then the final output will also be a double. So that's the power of double because it has more precision, so it is given more priority as compared to integer. So if one integer variable and one double variable, we will give the final output as a double. So what's the difference between a plus plus and plus plus a? This is a very famous interview question. So let's try to understand this. Now when we say equal to, this may create a huge confusion, like why not single equal to and why we are using double time equal to. So the important part to understand here is that when we write if else, only one of those will get executed. Either the code in if will be executed or the code in else will be executed. So the first case is satisfied by if and the last case, which is the otherwise, is satisfied by else. What about the other conditions? How can you execute that? You can do that using else if. Okay, we have combined else and if, it becomes else if. Now the good part is there can be multiple else if. So if the condition 1 is false, then it won't go directly to the else, it would go sequentially. Okay, the naming is very similar to the English language. Like you apply brake in your vehicle, like your car, when you're driving a car, you apply the brake, it stops. So similarly here, when you apply the brake, it stops. Now it's a good tricky situation to understand what brake will do. Will it make us outside both of the loops, or will it make us out of this nested loop, or will it make us out of this major loop? Like here we did not create any constructor, right? We did not create a method name which is same as the class name, right? We did not do it. So we said that the constructor will be called automatically when you create an object. So we created an object here. So which constructor will get called here? Try to understand the 4 pillars of object oriented programming. These are really important, widely used, and there are a lot of interview questions that are asked on these 4 topics. Now one major question will come into your mind. If we can get the value and update the value of this variable, then why make it private? Because we can access it from the outside environment using the getter and setter. So what's the use of making it private and updating the value and getting the value through getter or setter? Which means C is trying to extend more than one class. It can be 2, 3, 4, 5 or any count, right? If that is the case, that is not allowed in Java. You cannot extend more than one class at one time. Okay, now let's see something new. Okay, so we have created an object. We have used the class name animal. Okay, this one, which is the parent class, and then we have defined the object name. Say we have said A. Okay, and then we have done new. Instead of new animal, we are doing new dog. Now this is something new, right? Generally we do the class name, object name equal to new constructor of that class, which matches, right? If we are talking about the class animal, then the constructor would also be like animal. If we are talking about the dog class, then the constructor name is also related to dog. But here we have done something unusual. Here we have written animal object name equal to new dog. How come this is not giving any compile time error? Because this is something called as runtime polymorphism. Now when you do object name dot sound, now the main part comes, which method should get called, the sound of parent class or the sound of child class. Now technically you can achieve abstraction in Java using two ways. First is using the abstract classes and the second is using the interfaces. Now this is a very important topic even for the interviews, and it says animal is abstract, cannot be instantiated, which means you cannot create object of an abstract class, right? So that's why this is not allowed. So let me remove this. Why it is not allowed? So we saw in abstract class you cannot create object of the abstract class, but you can extend the abstract class, and then the class which extends the abstract class needs to provide implementation of the abstract methods, right? And then you can create object of that child class, right? That was allowed. So one question may come into your mind, like if there is so much similarity, why we have two different things like abstract class and interface? Why not use simply one of the concept? So there are two major points in this that you need to remember, because this is a very famous interview question as well, when to use abstract class versus when to use interface. But when you mark a variable as static, that will be shared across all the objects of that class, because this is now specific to the class, it is not specific to the object. But when we talk about C, right, because it is marked as static, it will not be part of the object memory. Okay, variable C will be shared by both the objects. So O1 and O2 both are sharing this variable C. C is not part of the object memory. Okay. Now the question comes, can a class be static? Then what is the difference between inner class and static inner class? But what if I add a final keyword to it? If you add a final keyword to it, you cannot reassign value to that variable. Now what about if I write final keyword to a method? Here you can see this is a function and I have written final keyword with it. What's the difference? How about final keyword with a class? Is it allowed or not? One more important thing here, string class is final. So you cannot extend string class. We have defined string in two ways. This is the first way using string literals, and this is the second way using the new keyword. What is the difference here? Now this is a very famous interview question, and it's very important to understand what's the difference between creating the string using literal and the new keyword. So we said like equal to will check the reference, right? But how do we match the values? Say for example both of these str and str2 have the same value. How can I check the value? Okay, in the code you can see first way is using the literals, second way is using the new keyword. Both have the same value. Let's try to print and check if str equal to str2 or not. So this is a very famous interview question, equals method versus equal to, and what is the difference when you create the string via literal way and with the new keyword. And with this we get one more understanding related to string, which is strings are immutable. Immutable means you cannot change the value of string. Now you would say, how is it immutable? I have done string str equal to hello, I can change the value str equal to no, right? So this doesn't give any error. So what's the problem? How is string immutable? I can change the value. Immutable means you cannot change the value, but I can change the value here. So first question is, what is an array? But if we talk about the index, so index here also start with 0. So the first element will have index 0, not 1. 0. Okay, remember this. So 2D array can also be called as a matrix. So here you remember, if you go to this element, how do you reach it? Using the index, you will say array name and in the brackets you will put 3. But how will you reach to a particular element? Say for example here, you will reach using combination of these indexes. The important part of set is that it will have unique elements. But then you have HashSet, LinkedHashSet, TreeHashSet. What is the difference? I know throw and throws are quite similar and these can confuse you a lot, but now there might be a confusion in your mind, like why write something in the finally? right? Because this is also running after the try catch. Now you will say like, okay, finally will run for sure if there is exception in try or not, right? But this line outside the try catch finally block is also running, right? In case there is exception that is handled by catch, finally will run, that's fine, but this block is also running. In case there is no exception, finally will run, but this case is also running. Then what is the use of finally? You can simply put the things outside the try catch directly like this, right? This is outside the try catch finally block and this is running fine. So what is the difference between keeping something inside finally or outside the try catch block? Now let's talk about throw keyword. Now throw basically means that you will manually throw an exception. But why will you manually throw an exception? So next, let's see some of the best practices related to exception handling. So let's understand what is multi-threading in Java. So let's see what is the difference between the process and the thread. Okay, now let's discuss how can we create threads in Java. Now you may ask, like in the first way also we implemented this method run, and in the second way also we implemented this method run. So how is this possible and where does this method run exist? Because we saw that start method is part of the thread class, but how about the run method? Where does it exist? So in both of the ways you are basically implementing the runnable. In the second way you are directly implementing the runnable. In first way basically you are extending the thread class which implements the runnable interface, right? Now which one should we prefer, like the first one where we extend the thread class or the second one where we implement the runnable? Next, let's discuss about the life cycle of the thread. Let's go to the code and I'll show you a wonderful example where you will see if multiple threads are sharing some data and they are trying to modify it, you will see the problem happening and then we'll see how to fix it, right? So for first thread we will increment the counter by 1000 times and for the second time we'll increment for 1000 times. So the final value of count should come as 2000, right? 1000 due to first thread, another 1000 for another thread, so total count should be 2000. Now let's print what is the value coming as. Here you can see it is saying 1738. What? It is not giving us 2000. But why? This video can help you crack your dream company offer. And the other thing is the content is completely free and I'm putting a lot of energy and efforts on this. Please make sure to subscribe to the channel so that I get more motivation to create more of this kind of content for you. Okay, so when we talk about computer science, for doing anything you would require a programming language. Like for example, you have to solve a DSA question in Lead Code or Geeks for Geeks. Then in order to write your logic, you would need a programming language. Similarly, in your job related work, if you want to develop something, you need to write code, and for that you would require a programming language. So Java is a very famous programming language and it is used in a lot of market projects. Like a lot of companies which hire people, they use Java programming language to write their code. Now many a times we do a mistake. Say for example, I have to solve a lot of DSA related problems, right? And for that I need a programming language. So what we think in our mind is that first I will learn the programming language in complete detail, and once I know the programming language completely, after that I'll switch to the work. It can be your DSA problems or your development work or anything like that. But you know why this is a bad kind of plan? Because you never complete that programming language completely, and that's why you stay stuck in that stage, right? So that's why in this video we are going to discuss Java crash course, which means within few hours, we will try to cover all the important topics which are related to Java programming language. So in this way, you'll get an idea of Java programming language. You will know the syntax, you will know the basic things which are required to write your code, and you will have the brief important knowledge of all the components or topics which are important in Java programming language. And after watching this complete video, you will have the confidence to work on the actual things like the DSA problems or any development related work. Because as you practice, like for example DSA question, you'll get to know few of the important things which are required for DSA problem solving, and that's how you learn and grow, right? So make sure you watch this video till the end, because I am going to cover a lot of topics related to Java programming language from very basic level to the advanced level. We are not going to have a very detailed discussion for every topic, but I'll make sure that I cover all the important topics in it so you get some clarity about Java programming language. Alright, so let's start with the very basic kind of things. Let's start with what is Java. So as you know, we are starting from very beginner level. If you know some of the things related to Java programming language, you can use the timelines or the chapters which are mentioned in this video and you can move to the next topic accordingly. Okay, so let's start with what is Java. So Java is a high level object oriented, platform independent and secure programming language. Now what does this mean, object oriented programming and platform independent? I'll cover both of these things later in this video. So small history, it was developed by James Gosling. And if we talk about today, Java is owned and maintained by Oracle. Although we are going to cover object oriented and platform independent meaning in detail later in this video, but in short, if I have to tell, object oriented means that the Java programming language revolves around objects and classes. Now what is object and class? We'll cover that, don't worry about it. Similarly, talking in short about platform independent, so one of the very important feature of Java is write once, run anywhere, which means it converts the code into a byte code which can run on any device. So you have to write the code only once and it is compatible with a lot of various kind of devices. How that happens, we will discuss about it later. So one question that may come into your mind is like, there are a lot of programming languages like C, C++, Python and many more. So why should we learn Java? Now the answer of this question is that Java is basically used in a lot of various kind of domains. It is used for building the mobile applications, especially if you talk about native Android application development. Earlier, Java was the main language for native Android application development. Recently, Google has recommended Kotlin instead of Java, but you can still write code in Java and you can make your Android application through it. So Java programming language is used for application development. Java is also used for desktop and web applications. So we said it is used in the front end because I said it is used in Android application development, also sometimes in the websites. At the same time, it is also used in the backend development. So a lot of companies are using Java programming language in their backend development. So Java is getting used for both front end as well as backend development. There are a lot of many other places where Java programming language is getting used. Now apart from these, the major point is that a lot of companies have their code written in Java programming language and they hire a lot of people for Java development. So if you know Java programming language, there is high probability you can crack offer of a company. Hence Java is a very famous programming language and we should learn it. So earlier I told you that Java is platform independent. Now let's try to understand this, how Java is platform independent. Now let's understand how Java is write once, run anywhere. So basically before Java, the other programming languages like C or C++, they used to compile directly to the machine code specific to the operating system and CPU architecture. So for example, if you are working on a Windows device, okay, so C would compile the code specific to your operating system, say for example .exe kind of file, okay, but the same code if you have to run it on the Linux or Mac, so it will have to recompile it specific to these devices. So which means that whatever code that you write, it had to be rewritten or recompiled again and again based on the device. Now Java programming language came with a revolution which changed everything. So now what Java did was, say for example, this is your code which was written in Java programming language. It brought a concept of something called as the bytecode. So let me write here bytecode. Okay. So what is a bytecode? Bytecode is basically something which is generated when you compile your code. It converts your human readable code to something called as bytecode, which is independent of the operating system. So bytecode you can imagine as something universal set of instructions which can be understood everywhere in every platform. So this bytecode was independent of any operating system. So apart from bytecode, Java also brought one more concept which was JVM, which is Java Virtual Machine. So any device which would be compatible with the Java programming language will contain this JVM. As I told you earlier, so Java can be run even on mobile, even on desktop. Okay, so whichever device is compatible with Java programming language will contain its own JVM. Okay, so this mobile device will have JVM, this desktop will also have the JVM. Now these JVMs will be different to each other because now it is present in a device, it would be specific to the device. So the JVM of mobile would be different from the JVM from the desktop, and which makes sense because each of the machine has its own JVM, so it's not a problem. But the good part is bytecode is universal kind of set of instructions which can be understood by every JVM. So irrespective of the platform, although the mobile platform has a different JVM, the desktop has a different JVM, but both of these JVMs have the capability to understand the bytecode. So the same bytecode can run on different devices, different platforms, different operating systems. How? Using the JVM, because JVM can understand this universal kind of instructions which is built in Java. Again, I'll give you the summary. This is your code written in Java programming language. When you compile this code, bytecode will be generated. Bytecode is not human readable code. It converts basically your human readable code that you have written into the bytecode. And the special thing of bytecode is that it is platform independent. So any platform, any operating system which contains JVM. Now JVM would be present in any of the device which is compatible to Java programming language. So any device that supports Java will have its own JVM. Now the JVM of mobile will be different of JVM of desktop, but that's not a problem because every device has its own JVM by default in itself. So you don't need to provide it. It is already present in the device. So mobile phone already has this JVM. Desktop machine also already has this JVM, which is specific to the operating system. But the brilliant part is that each of the JVM has the capability to understand the bytecode. So you have written your code only once and you have compiled also your code only once, and a universal kind of bytecode is generated from your code which can be understood by the JVM which is present in any of the device. So your code which you have written will also run in the mobile phones, even in the desktops and any other device which is compatible with Java. So as I said, the bytecode is generated at the compile time. When you compile the code, bytecode will be generated. But this step of JVM, it comes into picture when you run the code. So there are two steps. First you compile the code, then you run the code. I'll show you the complete demo, how things work. So don't worry about it. But just remember, when you compile the code, bytecode is generated. When you run the code, JVM comes into picture. You will run into particular device. So the JVM present in that device at runtime basically, that will understand this bytecode and run that into that particular device. Now you may ask, like, we have different JVMs. How are they able to understand the same bytecode? So basically each of the device has a different JVM depending on the operating system and what is the architecture of that device, everything. So yes, the JVM will be different for different devices, but all the JVMs follow the same Java specifications which are set by Oracle. So this makes sure that the bytecode which is generated only once, it behaves the same way in all of the devices irrespective of their operating system. So basically you can clearly see here we have compiled the code only once, and that has created a universal kind of bytecode which is independent of the platform, which can run on any of the device type which supports Java programming language, and that is possible via JVM. So bytecode and JVM, this combination makes Java as a platform independent programming language, and the feature or the term it is named as write once, run anywhere, because you are writing your code only once. You are not writing specific to a platform or operating system. You are just writing your code once, and then using the bytecode and the JVM, it will run in the same way in all of the devices which support Java programming language. Okay. Now let's talk about JVM versus JRE versus JDK. So this is a very famous interview question. What is the difference between JVM and JRE and JDK? So JVM we have already discussed, right? Here we talked about bytecode which is run by JVM, which is present in each of the device. So JVM is something which is present in each of the device. It helps running the bytecode. So using JVM only, we are able to run the bytecode on a particular device because the bytecode is universal, but JVM is specific to the device and it helps running that bytecode specific to this device. So basically JVM converts the bytecode into the machine code which your device or machine can understand and run on that device. JVM also handles memory management and garbage collection. So the basic understanding is the bytecode is universal, JVM is specific to the machine, and hence JVM converts the bytecode into the machine code which would be specific to the machine. So JVM runs basically the machine specific instructions, and due to that the universal bytecode is able to run on a specific platform as well. So after JVM, let's talk about JRE. JRE stands for Java Runtime Environment. So JRE basically provides you the environment on which the code can run. So if I show it here, say this is JRE, which is the Java Runtime Environment. It contains JVM inside it. Okay, so JVM is the part of JRE. Now apart from JVM, JRE also contains some of the core libraries. So as JRE stands for Java Runtime Environment, it basically provides an environment which is used by the end user who just need to run the Java applications and not develop them. Okay, so this is just an environment through which you can run the Java program. Now after JRE, let's talk about JDK. So JDK stands for Java Development Kit. So basically JDK is a toolkit for developing and running the Java programs. Now we saw here JVM, then we saw here JRE. Let me draw here the JDK. Okay, so let me write it down here. JDK. So this is your JDK. Now the important thing to remember is, as I said, that the JDK is a toolkit through which you can develop and run the Java programs. So it contains JRE inside it. Okay, so JRE is part of the JDK, and we have already discussed JVM is part of JRE. So here comes the JVM as well. So you can see the JDK contains JRE and JRE contains the JVM. Now it may seem to you like, how would I remember it, right? So I have created a trick to remember this. Okay, so let me write it down. So all three of these start with J because we have the JDK, and then we have the JRE, and then the JVM. Okay, so all three of these basically start with J. So everywhere you can see the same starting JJJ. So the trick to remember is that you have to write the things in the ascending sorted order. Okay, so you know JJJ is common, right? So we have written all three of these same as here. So we go to the next character. One we have the V, then we have the R, and then we have the D. So if we write A to Z, like all the alphabets, you know D comes first and then comes R, right? And then lastly comes V, right? So because we had these three only, so first would be JD. So JDK is the first one, right? Then comes R, so JRE, right? And the third one JVM. So it's simple. JRE contains JVM and JDK contains JRE. Okay, so JDK has both of these because JDK contains JRE and JRE contains further JVM. So this way you will remember. You can simply say, okay, this is the JDK. It will contain the JRE, which will further contain the JVM. So this way, just keeping these in sorted ascending order is a trick to remember, right? Other way around, if you know the actual definition, like for example, I told you this is a runtime environment which is used for running the Java programs, okay? Whereas JDK is a toolkit which is for both development as well as running. So the running part comes also in the JDK apart from development part, right? So apart from the JRE, as we said, like JDK contains the tools for the development as well. So that's why JDK also has development tools like compiler and the launcher. Okay, so the compiler is also part of the JDK because first you compile and then you run, but development part is also present in JDK, so compiler would also be part of the JDK. So basically it's something like this, like I have written all three of these in the ascending sorted order for the trick. So JVM, basically it is present inside the device, it is specific to the platform or the device, and it is used to run the bytecode specific to the machine, right? Now JRE contains JVM as well as some of the core libraries, because JRE provides you the complete runtime environment through which you can run the Java code. And on top we have the JDK, which is a toolkit through which you can develop as well as run your Java code. So for running we already have the JRE, hence JRE is part of the JDK. But apart from the runtime environment, we also need stuff for development. So JDK also contains the development tools like the compiler. So Java C is the command for, I'll show you these commands, but basically compiler is also part of the JDK, right? So you should know about this. In case you are not able to remember, simple trick, sorted ascending order, okay? D comes before R and R comes before V, okay? So through that you can remember. So now enough of theory, we have checked a lot of theory till now it's time for the implementation. So first we need to do the setup, right? What do we need? First is the JDK. Like just we discussed, JDK is required for both developing the program as well as running the code, right? So we would need to download the JDK. So for that you simply open Google and write down download JDK. Okay, when you do this you will see a link from Oracle. As I told you, Oracle now owns and maintains Java. So through the Oracle official website, you can download the JDK. You can simply go here and then basically you can download the JDK depending on your operating system, right? Now here you see Linux, Mac OS, Windows. If you're using, say for example, Windows, click on Windows and then download the JDK from here. If you're using Mac, you can select Mac and then download it from here. Okay, so once you download the JDK, there is one more thing that we need to download, that is IntelliJ. Now what is that? Basically we have to now write the code, right? And you can write the code even in Notepad or Word document or whatever you think so, but it will make things crazy and difficult for you. Why? Because you won't be able to see any compile time errors, and Notepad or Word, all these text editors, they don't provide you suggestions. So what we generally use for programming or coding is a code editor. Now so there are so many code editors which are present in the market, but for Java development IntelliJ is the best. Okay, so we will download this, and once you start using it you will feel the difference. Okay, it will make your programming or coding way faster. So let's download it. How to download? You open the browser, you write download IntelliJ. Okay, so you enter that and the first link is from JetBrains and it says download IntelliJ IDEA. Okay, you click on that. Now the main part to remember here in this is you don't download this one because it says free 30-day trial. This is the ultimate edition, which is a paid version. Okay, so we don't want to pay. My videos are free, right? I am teaching you the complete crash course free of cost. And do you think we will pay for writing the code? No, no, come on, no, right? So what you need to do is scroll down and you will see IntelliJ IDEA community edition. Okay, so here you can also see it says for Java and Kotlin. So basically IntelliJ, it supports multiple languages, so you can write code in various different types of languages in it, but we will focus on Java, right? So this is free. Okay, so you simply download this depending on your OS. Like I'm using Windows, so it is showing me Windows. You click on download and it will download for you, right? So make sure that you download this community edition, which is free of cost content, free of cost way where you can code, right? Really good, right? So make sure you subscribe to my channel if you haven't done it yet. Do it now. All right, let's open now IntelliJ and I'll show you how to write a Java program. So we are going to write our first Java program. Really excited. Now basically using IntelliJ, you can run any program in Java. So you can practice coding in Java programming. But just in case you're not able to do the setup, say you do not have a proper laptop or you forgot your laptop somewhere and you want to practice Java programming language and you cannot install all these JDK and this software in someone else's laptop or any other scenario, what you can do is like you can also run the Java programs or code on an online compiler, right? So what you need to do is like simply go to Google and write like Java online compiler. Okay, and it will give you a bunch of online Java compilers. Say I simply pick the first one and let me show you. All right, let's make it dark mode, right? You can pick any compiler, there is no need to pick any specific one. Here if you see, it has this class main, we have this static void main, same as like what we had here, right? So you can write all your code on the online compiler as well. Basic funda is like you want to test things, right? You want to understand the logic. So what you can simply do is like try to run this. Let's write here hello world, right? And let's try to run this. Click on run button and you see it shows you the output. So just in case you are unable to do the setup on your laptop or you do not have the laptop, you can also try running your code on the Java online compiler, right? That is free of cost and you will be able to execute your program. So in IntelliJ, you need to click on new project and then inside the new project you need to focus on this part, Java. As I told you, it supports multiple languages like Kotlin is there and much more, but we need to focus on Java. So click on Java and give a name of your projects. So we can write first program in Java. All right, so let's click on create and here you can see it has generated some of the code for us. This is the main file. Don't focus too much on it because you'll get the complete idea as we move forward in this video. But for now what I'll do is like simply remove everything which was written here. Let me increase the size so that it is completely visible to you. Okay, so we are inside this file and what I'm writing here is system.out.println and inside this I'm writing hello world. Okay, I'll explain to you everything inside this, but for now don't worry, just basically write this line as it is that I've written and then you simply click here the run button. So when you click on the run, it will open a kind of terminal for you. You can see the terminal here and it shows you the output. What is the output? This is the output, hello world. Okay, so it has printed the thing that we have written here. Let's change it. Okay, my name is Mohit Chabda. Okay, let's try to rerun. I have clicked on run button and you can see now here the new output. It says my name is Mohit Chabda. So now it doesn't say hello world. So it means our code is working, right? So I'm making changes here and you can see the changes actually here. Amazing, right? So this is your first Java program. We are going to write amazing code later in this video, but this is the starting part. We have written our first Java code. Congratulations. Now for me this class was already created, but just in case it's not created for you when you created a new project, what you can do is like in src simply right click and then click on new and then a Java class. Here you can give the name of the Java class. For example, here this is main. You can give any name that you want to do. The naming convention I'll tell you later, but for now say for example you can simply pick main, right? And then when you enter it, it will create a new class for you, and then inside that you can write this line of code and then click on run. It will give you the same output. All right, let me give you a brief of what this program is doing, what each of these mean. So first thing written is public. Public is, you can imagine it as a domain which says whether the thing is public or private, right? Public means it is more accessible, whereas if you say private, it is not accessible from outside. Okay, you will understand more when we go detail in this video later on, but for now you can simply imagine public means more accessible from other places, right? Then we have this class. So this is a keyword, okay? And as I told you in the beginning, Java is object oriented programming language, which means everything revolves around objects and the classes. So class is a basic building block of Java. Every program that you write, it will contain at least one class. So as I said earlier, it's like everything revolves around objects and classes. So you will need at least one class in your program. So this is a keyword, you will write same to same. And then this main here is the class name, okay? We created a class, like you simply right click here, new Java class, and whatever name you give, okay, main here is the name of this class. If you create a new class, say for example second class, okay, say for example Mohit, okay, and you press enter, so what it will do is like create a new class, and here you can see it has written public class. These are same because these are the keywords. So class is a keyword which tells you are creating a new class, but this thing, it is the name of the class. So here you could see in main the class name was main. Here you can see the name of the class is Mohit. So this can vary, but class keyword, it remains same. Okay, now going forward, this curly bracket, it indicates that you are starting your class. So inside this you will write your code which will be part of the class. So class name is main. So of this class main, this is kind of starting logic, that this bracket indicates that we are starting the code which will be part of this main class, right? Now inside this you can see this line. What is this? Again, public is same as I told you earlier. So public here means that it is accessible from anywhere. After that we have this static. Static you can ignore for now. It basically means that you don't need object of this class to run this method, but I mean for now just ignore it. Like when we go in more details in this video later on, you'll get to know more about static. So this is not always required. Okay, after this we have this void. So before coming to void, let me tell you, this is a method or function which will define some basic logic, particular logic. Okay, say for example you have your house, right? Okay, inside that you have many things to do. You have to, say for example, clean the shelf, clean the floor, okay, and clean the utensils, right? So like this you can have a lot of things while you're thinking about cleaning stuff, right, inside your home. So just imagine this home, this is your class, and inside your class you will define the methods or the functions which will perform some particular task. So for cleaning the shelf you will write some code, okay, which would be specific to this. Then cleaning of the floor, you will have a separate method or function for this. Cleaning of the utensils, you will write a separate function. So function you can imagine as a small piece of code inside the class which will help to do some particular thing, right? So here this is the method. So basically this method may take some input and may return some output. Okay, so output, it needs to define what kind of output it is giving. So if it is not giving any output, then we write void, which means it is not returning anything. Okay, I know this might be going like above your head, everything which we are talking about, but don't worry, I'm just giving you a brief summary for now, and later in this video you'll get more idea. Just go with me for now. Okay, this main, again here it is the method name. You can have many methods inside a class, and each of a method will have a name. Like for example, class had the name, similarly the method will also have a name. So main is the name of the method. Now what is this? These are basically arguments, or you can say the input of the method. I told you the method may take input and may return the output. So here this is the input, okay, and then this bracket again, it tells you that we are starting the method. So after this, whatever code we write, that will be part of the method. So this code is part of this method, okay. So then we wrote this line, okay. So system is basically an inbuilt class, okay, which is already present, and it is provided by java.lang package. You can see here java.lang, it shows you this is a class system, right? Then out is basically static object. You can see here static, but because we have not discussed static too much, don't worry about it. Simply think system is a class, and then println is a method. Like this is a method. Similarly, system class in Java has this method println. You can see here public void println. This provides you kind of like the syntax of this method, right? You can see the benefit of IntelliJ here. So simply you put a cursor and it shows details about that instantly. So this thing is not available if you do or write the code in the notepad or any other text editor, right? So that's why we are coding in IntelliJ. Okay, so system is a class which is already built by Java package. Println is the method which is provided to print something, okay. So here we have provided it the thing which needs to be printed. So when we run, it basically prints this thing as an output. Now let's do one more thing, okay. What I'll do is like write system dot out dot print. Now you can see here, instead of println, I have written print, and inside this let me write hi, okay, and let me run this code for you. So you can see here it has written hi, my name is Mohit Chabra, all together, although I gave that in the separate lines, but it gave the output in the same line, right? Now let's try one more thing. Let me copy this and paste this after this. Now you have this statement, this one and this one. Let's see what is the output. Now if you see the output, it has not given a new line after hi. It has simply printed the next thing directly with it, but after this it has given a new line. So what's happening? This is happening because of the method name. Basically, when you use the print method, it simply prints whatever you give it. So you mentioned hi, so it has written hi. But when you do the print ln, it prints whatever you give it, but after that it also gives a new line, because ln stands here for the new line here. So whenever you are using print ln method, it will print the text, and after that it will also provide a new line, okay. So in case here also, if you use the print ln method, now if you run again, the output is that what we wanted, right? Hi from this one, and then it gave the new line because of print ln method, and then the next one here, this gets printed, you can see here, and it also gives a new line because we have used print ln. And then the third hi we have written, so it has printed hi. It will not give a new line after it, okay. So you got the difference between print and print ln method, correct? Now one more thing in the syntax is that after every line, you can see here I have mentioned a semicolon. So this is mandatory. Whenever you write a statement in Java program, you need to add a semicolon. In case I remove the semicolon, you can see there is some problem. In red you can see, right? It is showing red color here, also a red bulb here. So when you click here, it tells you like insert semicolon. Isn't that amazing? That's the use of IntelliJ. You simply click here and it removes your error, right? So just in case if you don't put a semicolon and if you try to run, what will happen? It will fail. Why it failed? Because before running, compilation happens. There is a Java compiler which compiles your code, and in case there are any issues or errors, it will simply fail the build, for example here. Okay, it generally also provides you the suggestion. Here you can see it is saying you that the semicolon is required. You simply put the semicolon and the errors are gone. Now if you run it again, it will compile it again, and here you can see it has given you the output. Now we ran this program using this IntelliJ, but in case you want to know more how the things actually work, what we can do is like use the command line to run the commands and see how things work. So first let me see the location of this project. So you can simply see it is present in the C. Okay, so let me open that place. So here you can see I've opened the place of my first program in Java, right? Here you can see we have this src, inside that we have this main file, right? So if I right click here and show it to you in the properties, you can see this is .java file, right? This is the code that you have written, which is human readable as well. What I need to do is like show you when I told you like when you compile it creates a bytecode. So what I'll do is like open the command prompt here. So I'll click on open in terminal, and then we have the path till here already. What I'll do is write java c. Okay, what does this mean? Java C is basically used for compilation. Okay, and then I'll give the name of the class. So after that write .java, because the name of file is main.java. So java C is the command for doing the compile operation. So this is your file main.java. So I've written java C main.java. Let's press enter and let's see what happens. Okay, so it has completed, and you can see here now there is a new file which is main.class. So basically this is the bytecode. The compiler has converted your human readable Java code into something as the bytecode. Let me show you like how the bytecode looks like. It's not a human readable code. So let me open that in Notepad. So see here, it's like a weird kind of thing which is difficult to understand, right? So this is the byte code, which is based on universal set of instructions which all of the JVMs can understand, right? So let's go back to the main thing. This was the bytecode which is created. Now what we want to do is run this byte. So here you can also see the name is kept the same. The class name was main, and here for bytecode also it is same, main.class. So for running the code, you simply write java and then main. Okay, so this will run this bytecode. Let me press enter. Great, now you can see it has given the same output which was given here. Hi, my name is Mohit Chabda. Hi. And here also you can see hi, my name is Mohit Chabda. Hi. Correct? So awesome. We have now also executed this code from the command line. So java C is the command for doing the compilation, and you can see it created the bytecode. The theory part that we discussed, we also saw the implementation. Now it has created this bytecode, and then when you use the Java, it is basically for running that bytecode. The output is same as when you run it from IntelliJ, right? So you can try this like using the command line also, you'll get more clarity. You can open this bytecode file and you'll see when you open this main class, this is human readable, right? This is the code, whereas if you open the bytecode, you can't read it properly, right? So all these things you can try and you'll get more clarity and idea about that. So basically you can see here there are two steps. First is the compilation step. When you run java C, it compiles the code. How does that happen? Because we have downloaded the JDK, which is the toolkit for both development as well as running the code. So the compiler is part of the development part which is present in the JDK, right? So it compiles the code, it checks for any errors or issues. In case there is any error or issue, it will give the build failure and it won't allow you to run the code. But here, because everything was fine, right? So after running this, you can clearly see it created the bytecode which was part of the compilation step. And then the next step is the execution. So when you write java and then the file name, basically that will do the execution of this bytecode, and then you can clearly see the output here. So as you remember, we discussed earlier, Bytecode is not the machine code. It is not also specific to any machine. It is a universal set of instructions which are mentioned by Oracle or Java. So any device which supports Java will contain a JVM, and every JVM is able to understand this universal set of instructions which are part of the bytecode, right? So you can try out various things like add some error to it. For example, remove this semicolon or remove some bracket, and then try to run the same command that we ran, this one java c main.java or whatever is the file name of your class. Okay, and you will see you'll get an error, right? So it will not allow you to run the code. So compiler basically checks for all the things in your file whether everything is correct or not. So to give you the brief, basically every program must have at least one class. Here you can see the main is the name of this class. Inside the class you can have multiple methods. So methods you can understand as something which will perform a particular task, and then there are statements. Now as we said, the method will perform some particular task, but how will you perform a task? By writing some set of statements. So each of these is a statement, and every statement ends with a semicolon. Now let's discuss about few more points. So Java is a case sensitive language. So it will treat class written in small, in camel case, and in capital. All of these will be treated differently. Let me show you an example. Here you can see we have written the class keyword in using small alphabets, right? So let's make it camel case. So now if you see here, we are getting an error and it is not able to identify any other things as well, because class with C capital is not defined anywhere. So Java is case sensitive language, so you need to write the code according to it. Now your file name should be same as your class name. So here you can see the name of class is main and the file name is also main.java. Similarly for this class as well, you can see the name of class is Mohit and the file name is also mohit.java. So for example, if I write here main class, so you can see we are getting compile time errors, right? So here if you click, you can clearly see it says main class is public, should be declared in a file named as main class.java. So whenever your class is public, right, the file name should match with the class name. So you have two options here: either make the class name as main or rename the file name to main class. Okay, so here if I remove class from here, you can see it is working fine now. So you need to remember the file name should be same as the class name. Now coming to these brackets, you can see we have used this opening brackets for both class and the method. Similarly, we have used the closing brackets as well. So these represent a block. So this is kind of the starting point and this is the ending point. So whatever code or statements is written inside it will be part of that. It can be part of the method, it can be part of the class. So these brackets form a block which is used for classes, methods, loops, conditions. Don't worry about the loops conditions part, we will cover that later in this video. You will get the idea then. Also another point that you can clearly see is the indentation. So this method is part of this class, so it is not started from the same spacing. We have given like 4 lines of space here, and then the code inside this method is also given 4 lines of space. So this is called indentation. This makes your code more readable. It's quite clear that these 3 lines are part of this and this is part of this. So this way, using these 4 spaces, which is called indentation, the code is more readable. So for this, you don't need to press space 4 times. You simply can press the tab and it will add 4 spaces automatically. Okay, now after this, let's talk about comments. Here you can see I wrote something but which made no sense. Like I wrote like class, but there was no error. Whereas if I write the same thing here, you'll see there is an issue. Now it is giving the compile time error, but here I did not get any issue. Why? The reason is this part. So basically this is called comment, which is used for adding some documentation. Like you want to add some details about the method or the class or any statement, so that if other person is trying to read your code, or if you check your code after a long while, you are able to understand the logic by the comment. you can see comment, you can write anything. So it can say I have written this because, and you can give the explanation, right? So this can be your human readable like English that you can add here, so that next time you open your code, you by reading this you get the idea, okay, why did I add this code and all those things. But if you remove this, then you will get an error. So for comment you have to add this. Similarly here we are getting the compile time. What I need to do is simply add 2 lines here, and it is no longer giving me any issue. So here you can see we have added comment at the top as well, right? So by using this way you can add a comment which will really help in your documentation for you as well as for the other people who are working with you in a team. Now let's imagine you have to write a really big kind of comment which can cross like 5, 6, 7 lines, but there is one more way to do that. So this double line is used for the single line comment, if you have to give a single line comment. But there is also one way to give multi-line comments. How you do that? Using this. You simply press this and at the end you write this. Okay, so a slash with a star is acting as the starting point of multi comment, and star with the slash is acting as the ending part of that comment. So in this you can write whatever you want to write. Okay, and you don't need to add this double slash in every line because we have used this as a starting part and this as an ending part. So this is a multi-line comment. You can write whatever you want to write here to give the documentation, like whatever logic you wrote you can add, like why I added this or what does this mean or whatever you want to write, so that it is helpful for you and other people to understand. So double slash is used for the single line comment, and this slash with a star is used for the multi-line comment. But make sure to end this multi-line comment as well. If you don't put it here, so what will happen is that all of these things, the code that you wrote will also be treated as comment because you have not ended the multi-line comment. So make sure you end the multi-line comment as well. You see the colors have also changed, like the comments have different color and the normal statements have different color. So this way the IntelliJ is really helpful, right? All right, so we talked about the single line comment and the multi-line comments. All right, so coming back to the methods. Okay, this is a function or a method, as I told you earlier. A class can have multiple methods, so I can create one more method here, public void. As I told you, it means that we are not returning anything from this method. Okay, what should I name it? Let's name it method only. Okay, and I'm not passing any input to it, and after that I'll add this starting bracket and then you have this ending bracket. Inside this let's write something like this. Instead of hi, let me write hello. Okay, so this is another method. You can see no usage here because we have not called this method from anywhere. Don't worry about that, we will cover that when we discuss about methods later in this video. But the main point I was showing it to you was there can be many methods in a class, but every Java application must have this method main. Okay, so this is the method which is called first. So this is the method which is called whenever your application starts. Automatically this method is called. That's why when you ran this program, automatically the things which were present inside this were automatically printed, because whenever you run your application, this is the first method which gets called. This method won't get called like this. Like for example, if I run this program again, this hello will not be printed. You can see here there is no hello inside it because we have not called this method. Although we did not call this main method as well, but it is automatically called when your application runs. So every Java application must have the main method. Now I told you how to print the statement or how to give the output to the terminal, right? But how about the input? Like how can we take input from the end user? For example, when I ran the program, it just displayed me the output. But what if I need to provide the input to this program? Then how can we do that? So for that, let's write another program. Just copy these statements for now directly and try to run it. I'll explain you what all these mean. So basically scanner class is used for getting the input. Okay, now you can see here it is giving some issue, right? So if you go around here, it is asking that you need to import this class because it is present somewhere else. Okay, so let's click on import class and you can see it has imported this class. Now what does import mean? So for that you need to understand one more concept, which is package. Okay, like here you can see our main class is part of first programming in Java. Inside that src, and this scanner class is present somewhere else, where it's present inside java.util. So in case we have to pick some of the class, public class, from somewhere else, then we need to import that part. Okay, so let me show you one more example that will give you more clarity. So inside src, let's create a new package. I told you package, right? So you can see here package. So you click here, say for example I'm writing second. Okay, so inside second, let's create a Java class. Let's name it as my class. Okay, I'm just giving you some random names. Later we will see how to give good names to the class and methods, but for now just I'm adding a new class in this second package. Okay, let's create this, and here you can see it has included one line package. You can say the location of the class, like where this class is present. So this class is present in a new package which is second, right? These classes main, these were directly present inside the src, whereas my class that I've created, it is present inside a new package in the src. So that's why you need to mention that. Similarly here, when we talk about the scanner, it is part of java.util package, which means it is present inside java.util. So how can we see that? Just like click on control on your keyboard and then click from the mouse. So what it will do is like it will take you to that class. So that's the use of IntelliJ. So you can see this is the implementation of scanner class, which is by default provided by the Java package. Now how can we see the package? You go up. Okay, at the top you can see here it says package java.util. So this class scanner is present inside java.util package. So basically you can understand package as a folder inside which you can keep multiple classes. So it is used for grouping the related classes inside one folder, you can say. For example, we have created this folder, but in technical terms you call it as package, and inside that you have classes. So we have not given some useful naming here, but for example I can say like you are creating an API, right? So in that you might have various logics, one related to database related operations like create, delete, update, read. So you can create a separate package for that part. Then you may have your business logic related package, and similarly you may have your model classes, which are just the classes which are giving you the structure of the API and the response. So you can create multiple packages, so that will improve your readability. Why that is required? Say for example you have a big project which has say like 200 classes. So now just imagine if all the files are present in directly in src, it's not like completely readable. How will you try to understand which class is doing what? Whereas if you create packages, it gives you more clarity, like inside this all the classes are related, this kind of functionality, right? So that way it is quite helpful. So you can see here it was part of the java.util package, and this package was not present in our program. So what you do for that is use the import statement. Import, like even in English terms you can understand, you are simply importing something from some other place, right? So you have mentioned which class do you want, like java.util.scanner. In case there were multiple files that you wanted, or you wanted all the files, you can simply also do like star here. So inside java.util all the files will get imported and you can use those. But here because we wanted a particular file, so we are doing like java.util.scanner. Even in the scanner class you can see it has imported a lot of things, right? So here you can see a particular file as well, and the star as well, like in java.text package it took everything from there. right? So this is the funda. The first thing that you add at the top is the package. If it is part of some particular package, like for example we created my class in the second, so we have mentioned package second, right? Which means this class, my class, is present inside second package. Okay, and if you want to use some of the class which is part of some different package, or you can simply imagine which is part of some different place, right? It is not part of your module, you can say. So you can simply import that, okay, using the import statement. So first you will have the package, and this is optional because you can see in the main class we did not mention package, but for my class we have mentioned that, right? So at the top, if the package information is required, it comes at the top. After that you have your import statements. Now this is also optional. In case you want to use some of the class from other place which is not part of your package, then you have to use the import statement, otherwise it is not required. And after that you have your class definition, right? So again, let's discuss what's the use of package. So one of the use cases, like if you have a large project where you have a lot of files, right? So in that case it makes it more modular, it makes it more readable, so it makes easier to maintain the large project. Similarly, package also helps to make your code modular, like you have different packages out there. Like I explained you an example of API. One would be related to database, other would be the business logic, other would be the models, and similarly many other things. So it makes the code modular. And another use case of using package is that it avoids name conflicts. Okay, so you can have the same class name in different package. Like very simple, if I tell you inside src you have this class Mohit, okay, but you cannot have another class inside src directly with name Mohit. Let's try to do that. New Java class, and let's write Mohit, okay, and let's see what it says. It says cannot create class because that already exists, which makes sense because you have that class here. How can you create a new class with the same name, right? What I'm now going to do is, like, inside second I am creating a new class with the same name Mohit, and it will allow you to do that. Let's do it, and you can see it, right? So using the package, it avoids the naming related conflicts, right? But how did this work? Because it is part of separate package. So whenever you want this class from outside, you will say import second dot Mohit class, right? Whereas if you have to use this class, you will simply directly use it because it's part of this, like, first program in Java, in that you have directly inside the src, whereas this class has different package, right? So in this way it also avoids name conflicts, right? So this was about the package. Now after this, let's also discuss about the naming conventions, because we have talked a lot about the class and the method, but we should also talk about the naming conventions. So let's discuss that, okay? So here is the Java naming standards which we need to follow, okay? First, if we talk about the class, for class, every word, the starting letter will be in capital. For example, if you had like student, so you will write S capital and then all other letters as small. So here you can see I've written like student, right, where only the starting character is like in capital, rest all of these are in lowercase, right? But what if we have multiple words? So here you can see we have like student details, in that S is capital and D is capital, right? So every word in the class, the first letter of that word, you will make it uppercase. One more example is car engine. So you can see C and E, both of these are in capital, rest everything is in small case. You can also see that in all the classes that we have created, first is the main, so you can see only M is capital, rest everything is small. Then we created Mohit, M is capital, everything small. My class, so now there are two words, M is capital and C is also capital. So this is the naming convention that you need to follow for class. Now talking about the method, so method name always starts with the small case. So in class it was always starting with the uppercase, whereas in method it always starts with the lower case. So if you had the method, say the name was method only, for the method you kept the name method, right? So M is lowercase here, right? But if you have multiple words, then the word apart from the first word, for that we will keep the first letter as capital. Like for example, you can see here, calculate sum. C is small but S is in capital. Okay, similarly, get name, you can see name is a new word that we are adding, so N is capital but G is not capital. So the method name will always start with a lowercase, right? And one more thing is, like, how do we find out that this is a method? First is this kind of naming convention, and then these two brackets. Method will always come with this kind of brackets. You can see here, like in the main class we had this main method, although it contained the input, but that input was inside these brackets, right? And similarly, I created a new method without any input that also had this. So whenever you are creating a method, you need to add these opening and closing brackets. So if I remove it, it will give you the compile time error. So method will always contain this. Now variable and constant we have not discussed yet, so you can ignore it for now, but like you can also remember simple thing. Variable is same as the method name, like total marks, you can see user age, it is same, the convention is same as the method, just that in variable you won't have these brackets. So using this bracket you will identify whether it's a method or a variable. Okay, but you can ignore it for now. When we come to variables, we'll discuss more about it. Now about package, it is always in lowercase. So you can see here everything is lowercase. If you want to add multiple things, you can create multiple different packages, so that will be separated by a dot. So you can see here com.school.management, so it is always in lowercase. So you can remember very basic kind of stuff. Class, the starting letter will be uppercase. Method, the starting letter will be small case. Okay, package is always small case. So in this way you will be able to identify. For package, I can show you one example. We went for this scanner class, right? You can see here everything is in lowercase, right? So this was about the naming convention of the class, method and the package. So here we mentioned variable. So next let's talk about variable and data types only. Like what are variables and the data types? So variable is basically a place where you can store some value. When I say place, you can say it as like named memory location, because we are going to name this variable, because that is how we will be able to save some value inside it and fetch that value from it. So let me explain it to you in a very easy way. Okay, in our schools, in maths class, we used to do like let x be 10, right? We used to do all that stuff, find out the area, find out the sum, find out the parameters, x is this, y is this, like what will be this, you remember all that stuff, right? So if we talk about the technical terms, this x is the variable. How? Because it is storing some value. But how will I write this part in Java? Very much similar. I'll write it first, then I'll explain it to you what does that mean. Okay, so I'm writing the same thing in Java, like how you will write code for that. So this is the exactly same thing. This was maths, this is Java. Quite simple, right? Now let me explain it to you. X is the name of the variable. Okay, so we have defined a name, like this is named memory location, so the name of this variable is X. Okay, and then equal to means you are doing the assignment, which means you are storing some value in this X. So this is X, right? Because we have given the name of this memory, right? So this is X, and when we do the assignment equal to 10, so 10 is stored inside X. So X is the name of the variable which stores value 10. And of course, because this is a statement, I told you every statement will end with the semicolon. So we need to write this semicolon. But apart from all this, you can see I have added int in front of it. Why this is required? This is basically the data type. In Java, when you are defining a variable, you need to tell the system what type of variable is this. Now because we are storing integer value in it, 10 is an integer, right? So we have mentioned the data type as int, which means integer, which means X will contain integer values. So for that I have mentioned int. So let me write it down in the IntelliJ so that you get more clarity about it. Okay, So now here I'm going to write the same thing, int, which represents like we are storing integer value in the variable, and then give the variable name. We said like x, and then we will do the assignment, which is using the equal, and then we are using like 10, which is the value, and after that a semicolon, which tells that we have ended this statement, right? So let's try to print this system dot out dot println, and let's print x. Okay, so here you see I have not used these double quotes, right? So actually the double quotes we use for the string, like for text. For example, the hello is a text, right? So we simply do that. But here I'm trying to print a variable. X is the name of the variable, so I can directly print that. I don't need to basically add the double quotes here. I'll show you what will happen if I add the double quotes, but before that let's try to run and see if the logic of variable is working. All right, you can see it has printed 10. So now you can see it simply says 10, which doesn't look good, right? If I have to add some text to it, I have to add this kind of thing, and inside this I'll say the value of x is, and then we can say plus x. Okay, so here you can see x I did not put inside these because we are printing the variable, whereas this is just the text. Okay, so let me show you what will be the output. So it says value of x is 10, right? So it has printed the value of that variable. Now you may think in your mind is like we have used the plus. In maths, like we used to do 3 plus 2 equal to 5, right? That is same even in Java, but that works when you are working on, say for example, integers. So if I had two integers 3 and 2, if I do 3 plus 2, that will give you 5 only. But here this is a text. Okay, so that it doesn't work like that for text. For text it simply appends the value. So it says value of x is, and then after that plus means append this part. So it has simply appended it. You can see 10, whatever was later, it just appended it with the string. Don't worry too much, as like you practice, you'll just keep on writing, you'll get used to of all such things. Okay, but what will happen if I add x inside this only? You can see I've written x inside this. It simply prints it as a text, right? But I don't want to print it as a text. I want to get the value of this variable, right? So that's why I have kept it outside these. Now basically you can see here in this statement we have declared the variable as well as we have initialized the variable. But what does that mean? Let me explain it to you with a separate variable creation. Okay, I am creating a new variable which will be named as y. So but instead of doing the initialization and the declaration in one go, I'll do it step by step. So first I'll do int y. Okay, and I have added the semicolon here. So this is end of the statement. What we have done here is we have told there is a variable with name y, and we have told it will be of type integer, just like x which was of type integer. Y will also be of type integer, right? But we haven't assigned any value to y yet, whereas you saw here we just assigned the value to x. So here we did the declaration and initialization in one go. So this step is basically declaration. Okay, we have simply declared a variable here, but we have not assigned any value. So next step, if I do y equal to 20 and then the semicolon which tells end of the statement. So here I am putting some value inside that variable y. Okay, so this part is called as initialization. We have initialized or assigned the value to the variable. So now y contains value 20. So that step is called initialization. So there are two steps: declaration, initialization. Whereas this one is the combined step. We have done the declaration plus initialization in one go. So it's totally up to you. You can do both of the things in one go, in one line as well, or you can do the declaration and initialization separately as well. So it's totally up to you, because sometimes you don't have the value to initialize like what should be the value, and later you get the value so you can assign it. So you can do declaration and initialization separately as well. Alright, one more important part of variables is that, like as I told you, this basically provides you the naming memory location, right, where you can assign some value. Okay, say for example we did int x equal to 10, but what if later I want to change this value? Say I want to do x now having the value as 20. Can I do that? Yes, you can do that. That's why it's called variable, which means the value can vary. You can change the value anytime you want to change, but it can contain only one value. Okay, and it will contain only integer type value. So if you do after that x equal to 20, it will replace the value from 10 to 20. So you can assign the values as many times as you want, because this is a variable. Okay, so let me show that you in the code. Here you saw that we printed the value of x. Now after that, let me do x equal to 30, right, and then the semicolon, end of the statement. Now it will print the value of x as 30 and not 10, because the value got replaced, and here you can see the value of x is 30, right? So you can update the value in the variable as many times as you want. But can I add like a decimal value to it or a text value to it? No, you can't. I'll show you. Say you are doing like 30.5. So it won't work because you have mentioned here integer, and integer means like the numbers like 1 2 3 4. It won't contain the decimal values. Okay, here you can clearly see it is saying the required type is int, which means you should give it integer, but the provided value is double. What does that mean? I'll come to that, but double simply means the decimal values. If you want to assign, you will have to make it double. So you can clearly see we need to define the data type with the variable in Java. Okay, so let me remove this. And similar is the way for text. You can't do x equal to hello. You can't do that. Why? Because again the same thing, x is integer, but we are providing a text to it which is of type string. Okay, so we can't do this. So you need to make sure whatever the data type you have assigned to x, you are assigning value according to it only, otherwise you'll get the compile time error and you won't be able to run the code. But these are all the cases that you can try out on your code, and through that you'll get more understanding and learning how things work. Now let's talk about the variable naming rules. So the valid names, of course it can start with a letter, like for example x we wrote, y we wrote. You can also write Mohit or anything, so text is fine. So starting with the letter, it's totally fine. But apart from that, the variable name can also start with a dollar sign or an underscore. Okay, let me show you an example for the same. Like we can create a new variable int. Of course you can write Mohit equal to 10, right? So this is fine, this works. There is no compile time error for this. You can simply run this. It is simply saying it is never used, but there is no issue. You can simply make a variable with the text. I mean starting of the variable is with the letter. That's totally fine. Now apart from that, we also said like starting with a dollar or underscore is also fine. So let's rename this variable. I'll add a dollar. So you can see this is also fine. Okay, and let's see with the underscore, this is also fine. So your variable can start with the letter, underscore, dollar, and the naming convention is same as the method name as we already discussed. So the starting will be always lowercase, and the next word can have the starting as the uppercase. Okay, now after this, another thing is that the variable cannot start with a number. Let me show you. So underscore is fine, but if you write 8 Mohit, it will give you compile error. You can see clearly it has become red. So the variable cannot start with a digit or number. Apart from that, there is one more rule that the variable name cannot be a Java keyword. Now what does this mean? Let me show you. As you know, class for example is a keyword, public is a keyword, void is a keyword, static is a keyword. So your variable name cannot be this. So if, let me show you, if I write here class, it will say that it's not valid, you cannot use this. Okay, similarly if I use public, okay, so this will also give you issue. So you cannot use the Java keywords as the variable, right? But not to make anything complicated, keep it simple. Most of the time you will keep it starting with the letter. Just make sure that you are making it small case like this, Mohit. So this is fine. Of course, as you code, try to keep the name of the variable as per its use case. Like for example, if variable is doing some particular task, the name should also depict that it is used for this particular thing, right? So all that things that you can keep in mind. So let's discuss one more thing about the scoping. Okay, say for example, you have initialized and declared this variable x inside this method. So what does this mean is that this is part of this method. You cannot use x directly outside. Okay, so if I try to use outside this method or inside this method, like x equal to 40, it will give you error because it cannot identify what is x. Why? Because x was part of this method. So inside the scope you can use x, but outside you cannot use. So this is called scoping, or you can say it is the local variable inside this, right? So that is the thing. And one more thing is, like when you are assigning the value as a next step, right? If it is already declared and you are assigning the value, you don't need to define the data type again. Here you told the data type as int, that is x will contain the integer value. But if you are reassigning the value, you don't mention int again, because if you do that, it will try to allocate another memory to a variable with name x, but that won't work because there is already one variable with name x. So let me show you. If I do int x, so it will say no, it's an error because it is already defined in the scope, right? X is already present here. How can you provide the same value? It is same as when I told you, like in src, if there is a class Mohit, I cannot create another class with name Mohit, right? So similarly is this case. So if you need to reassign, simply don't mention the data type and this is totally fine. It will replace the old value with the new value. Now here I told you, like we define the data type, and here it was like the integer value, so we mentioned int. So what all can be the data types of the variable? So it can be of two types. First is like the primitive data types. Okay, these are the basic types which are already predefined by Java and you can use it directly. I'll show you what all comes inside the primitive data types. And the other type is non-primitive data types, which are user defined. So don't worry about the non-primitive types for now. Let me start with the primitive data types and show you what all are present in the primitive data types. So these are the primitive data types. Okay, first one, as we already saw, it is int, which will contain the integer value. So every data type is also assigned the size. So for example, int is of 4 bytes. So whenever you define an integer that is data type int, it will consume or take or occupy 4 bytes of space. An example can be int a equal to 50,000, right? So this will be used for integer types. But if you don't assign a value, like you simply declared the variable, the default value to integer is 0, but it varies on Java version. Some of the new Java versions, it might not allow you using a variable without assigning it some value, but in older versions the default value was always for integer as 0. Okay, now after that, let's talk about float. What is float? You know, int can only contain integer values, right? But if you want to use decimal values, so you will use a float for that. For example, float f equal to 5.5 f, so you have assigned a decimal value here. So this is also 4 bytes. Okay, and the default value is 0 0.0. Now when I say 4 byte, it also represents a range, because 4 bytes means 32 bits. Okay, and the range of integer is this one. Like this seem like as a huge number, right, from negative to positive, but sometimes in your code you would require even more higher value. So in that case, if you want integer type but more range, then you can use a long, because long will also contain the integer values, but the size of long is 8 bytes. So the range of long will also increase by a lot. Similarly, if float containing the decimal values is not sufficient for you, you want larger decimal values, you can use double for it, because double is of 8 bytes and hence the range expands. So after integer and double values, let's talk about one more primitive data type, which is Boolean. Okay, so Boolean is just 1 bit in size, because it can either contain true or false. It has only two combinations. So the default value of Boolean is false. One example can be boolean flag equal to true. Why 1 bit? Because 2 power 1 equal to 2 combinations. So it needs only 2 combination, either true or false. So here you see int was 4 bytes, but boolean is just 1 bit. If we talk about bits, integer is 32 bits, whereas boolean is just 1 bit, right? So based on the requirement, the size is also varying, you can see, because for boolean you don't need that much size. It can only contain true or false, that kind of stuff. So next is char. This is for character. Okay, so for example, you have like a b c d, like lowercase or uppercase. One character you can store it in char. So an example can be char c equal to, you can see here we have assigned a value of a character to this c. Now default value is something like this. You may wonder what is this. So basically character is stored in terms of ASCII value. Okay, so each of these character like a b c d, and even for the capital one, they have the ASCII values, and in that way it is stored in the character. Don't worry much about the ASCII value, that you will get an idea when you are trying to solve some problem related to strings or the characters in DSA. You'll get more idea on that part, but simply you can remember like each of the character has an ASCII value. You can simply search on Google and you can get something like this as a ASCII value. So you can see all the characters have assigned value to them, and not just these alphabets. Even for the special characters and for the digits, you will have the ASCII value. Okay, so you can check that. So after char, we also have other types which are not that highly used. One is the byte, another is short, which are of size 1 bytes and 2 bytes. So these are for the small integer values, but generally they are not used that much, so we can ignore those for now. The important ones are int, long, float, double, char, and the boolean. So these were the primitive data types. So let me take you to the code and we'll see one example of this. So here you can see in the method I have written all various types of the data types. We have byte, and then we have int. You can see it has an integer value. Long has something, a very long value. It also contains the integer, but the range increases, so it can contain the bigger integer value. Float is containing the decimal values. Double is also containing the decimal value, but the range can increase in it. Here character contains only one character, and the boolean can be like true or false. We have printed all of these are all variables, and we have declared and initialized in one go for each of these, but we can also do the declaration in step 1 and initialization in step 2. We can also do that, but here we have done both of the steps in one go. So let me run this and you will see the output. Okay, so you can see the output. It has printed all of the values here correctly. So this was about the primitive variables. Of course you can perform a lot more tasks in it, like for example, if I remove all of this and if I do int x equal to 10, int y equal to 20. Okay, and then I can do system dot out dot println sum of x and y is, and after that I can basically do x plus y, right? So here you can see I've written like sum of x and y is x plus y. So this is mathematical operation, you can say. Normally like in maths you do a plus b, so we are doing here simply x plus y. So let's see what it returns. Okay, let's try to run this. All right, you can see here it has printed 30. Like why I use bracket here, because here also we were using plus, so I don't want this to confuse with the mathematical operation that we need to perform. Basically here are two integers, so when you do x plus y on that, it will simply perform the maths operation. If you don't want to do like this way, you can also do something like int z, that we have created a new variable, but it will store the value of the sum. So z equal to x plus y, right? So instead of this you can simply print z, right? So again if you print it, it will give you the same output as 30. So all these things you can basically try, and it will give you more clarity how things are working. Okay, all right, now let's talk about non-primitive data types. These are kind of bit complex data types. A few example of these can be string, arrays, classes, interfaces. Now all this may sound quite weird and complex to you, but don't worry, we will cover each of these in detail later in this video. So for now you can ignore it. You can focus more on the primitive data types for now, okay? Just try to practice primitive data types like using the int, long, double, char, boolean, and you'll get more clarity. We'll discuss more about the non-primitive data types as we go through this video, right? Now let's discuss one more topic, which is typecasting. Like we have discussed a lot of primitive data type like int, double, char, boolean. So the typecasting actually means that you are converting between the types. Now how does this work? Let me show you that in the code. Here let me create integer variable, so int x equal to 10. Okay, now say I want to typecast or convert this integer variable into double variable. So I'll create a new double variable. So I'll write double y, and then I want to assign it the value of x. So what I'll do is typecast it. Like how do you typecast it? First you provide the brackets, okay, and inside it you provide the data type. Because I want to convert it into double, so I'll write double here, and then I'll write x. So what I'm doing here basically is I'm converting x to double. Okay, so this is a way of typecasting. So you are typecasting the integer to this type. Now let's try to print this. So I'll write system dot out dot println, and then I'll print y here. Okay, so let's try to run this and let's see what is the answer. So you can clearly see answer is 10.0. so it has converted integer to double, right? By default it has given like 10.0 because double contains decimal values, so it has converted int to double here, right? And you can see the way how to do the typecasting. I have simply created a new variable here, the type which I require, and then assigning the value like from which I need to convert. But before that I write this, like you have the bracket and you provide the data type to which we need to convert. Here we were converting to integer to double, right? So this was the value integer, and before that we write inside the brackets the data type we want to convert. So we wanted conversion in double, so we have mentioned double here. Now let's see one more case. Say you want to convert double to integer, right? So let me create one more variable. Let's write a, and its value is 15.5, right? Now because a is a double variable, it can contain decimal, so I have given a decimal value here. You can make it more like precise. You can add something like 15.59, right? So this is the variable containing the decimal value. Now I want to typecast it or convert it into the integer. So what I'll do is like create new variable int b. Okay, now I want to assign it the value of double, right? But before that I'll write the same logic of typecasting. So what I'll do is like equal to, I'll write int, because we are converting this time into int, right? So you always write here to which you want to convert. I wanted to convert double value to int, so I am writing here inside bracket int because we want to typecast in integer. I'll write here a. So what is this statement doing? It is basically typecasting double to integer, and then we are storing that value in an integer variable, right? So let's try to print it. System dot out dot println you can write, and then I'll print b inside it. Okay, let's see what is the answer. Okay, you can clearly see here first it returns 10.0 because we have printed y, which is double, which we typecasted from the integer, and then it returns 15. Why 15? Because the double value was 15.59, but when we typecasted it into the integer cannot take the decimals, right? So that's why it has given the value 15, because it will ignore the decimal part. So this is how you basically typecast it. Now you may ask like why the color is different. Here you can see it's a lively color, whereas this looks like grayish color. Why is that? When you hover the cursor around it, you will see that this is redundant. Why is this redundant? Because there is a concept named as widening and narrowing. So basically when you are converting integer to double, you are basically doing widening, so you are widening the scope. So in that case you don't need to mention the data type here particularly. Whereas when you are doing narrowing, which means like from double you are coming narrow down to the integer, you are coming one level down. How come we are coming one level down? Because double can contain a decimal value, so it can give you more precision. Here you can see it had 15.59, whereas integer would have only 15. So there is data loss actually, because you have lost this end of precision 0.59, you have lost that value, right? So you're coming one level down. In that case you need to define the data type to which you are doing the typecasting. But I feel this is kind of like a confusing thing. How will you always remember which is the widening part and which is the narrowing part? So my suggestion is always provide the data type inside the brackets. Even in case it is redundant, you don't need to worry, because you can see there is no compile time error, right? It worked perfectly fine. So that's why my recommendation is, whenever you are doing typecasting, simply use this approach. Okay, simply provide the data type inside the brackets and that works. So this was like typecasting, where you are converting from one data type to another data type. So till now in variables we have learned that we need to define the data type before giving the name of the variable. In Java you cannot have any typeless kind of variable. You need to define the data type of each and every variable. Like for example, x is of type int, which represent integer. Y is of type double, which represents it can contain the decimal values as well. So you need to define the type. But these are variables, which means that you can assign the value to it multiple times. Like for example, you can do x equal to 20, x equal to 30. Like this you can assign the value to x multiple times, because it is a variable. Of course it can contain only one value at a time. So if you are doing assignment multiple times, x will contain the value of 30 finally. It won't contain 10 or 20, because those are already replaced. But what if you want something to which you cannot assign the values multiple times? So for that we use the keyword final. So for example, if I create a new variable int k equal to 25, right? Now this is a variable to which you can assign the values multiple times. Like I can do k equal to 35, and then I can do k equal to 100. So you can assign value to k multiple times, because this is a variable. Now if I add final keyword before it, now k is not a variable, it is acting as a constant, which means you can assign value to k only once. You can see here it is giving compile time error, because it say cannot assign a value to final variable k. So if you want to assign value multiple times, you have to remove this final keyword, then the k will become variable and you can assign the value to variable multiple times. But if you want that k can be assigned value only once, then basically you can use this final keyword, and you have to remove the logic where you are reassigning the value to k, because it cannot be reassigned again. Alright, so this was about variables and typecasting. What I want from you is that you can play around with all these like data types, various that we discussed, like int, double, char, boolean, all such things. You can try out few of the things while doing coding. You will have fun and you will understand a lot of things via that. Now let's talk about operators in Java. So basically an operator is a symbol which performs an operation on one or more variables. So for example, in your school days math, you might have done like x equal to 10 and y equal to 20, and now we have to find the sum of both of these. So we will do simply x plus y, which will give you the answer as 30, right? So here this plus sign is acting as a operator. It is performing sum of two variables or numbers here. So apart from this plus sign, you also know we had the minus sign for subtraction, we had the multiply sign through which we could multiply two numbers, and then we also had the division sign, which you represented by this or by this. Now similar to this, Java also provides you a lot of operators through which you can perform an operation on one or more variables. So now let's see few of the operations which are available in Java. So here in this image you can see several categories of Java operators. First one that we talk about is the arithmetic operators, which you can easily remember from your early school days. You used to do sum, subtraction, multiplication, division, and finding remainder. So all of these operators which are represented by plus for addition, this minus for subtraction, this star symbol for multiplication, this slash symbol for division, and this percentage symbol for finding out the remainder. So all of these come into arithmetic operators. Now let me take you to IntelliJ, where we will write some code for this basic arithmetic operators. Alright, you can see here in the main method I have introduced two variables of type integer. First is a, which has value 10, and other variable is b, which has value 3. Here we wrote both of these variable in single line, but you can also write them in different lines. So instead of this, what you can also do is do something like this. So here we are declaring and initializing variable in one go, but because there were two variables, so we did it in different lines, so we took two lines. But you can also do it in one line if you want to. But just in case putting everything in one line is creating confusion for you, you can create all the variables in a separate line. That's totally fine. Okay, so we have two variables here, a and b. The value of a is 10, the value of b is 3. So now we are going to use arithmetic operators. First we are using plus sign, which represents addition, so we are doing 10 plus 3, which becomes 13. Okay, then we are using the minus symbol, which is for subtraction, so we are doing 10 minus 3, which is equal to 7. Then we are using the multiply operator, so 10 multiply 3, which gives you 30. Then we are going to perform division using this slash symbol, so 10 divided by 3. Now this is a bit tricky, because in actual maths you will say it will return 3.33333, but because both a and b are integer here, so the end result will also be an integer, so it won't be 3.333. instead of that it will simply return 3, because we are doing integer divided by integer, that will also be an integer, and integer does not contain decimal precision values, so it will simply show you 3. And finally we are using this percentage symbol, which is used in Java for finding the remainder. It is also called modulus operator. So using this you will find the remainder. So if you divide 10 by 3, what is the remainder? So you know 3 into 3 is equal to 9. 10 minus 9 equal to 1. So 1 is the remainder, so it should give you 1 as an answer. So let me run this and see if we are getting the same output as expected. Alright, you can see here it's giving the same output, 13, 7, 33, 1. So basically we perform these operations on integer here. What you can also do is like try out various combinations. You can make one variable as double, other as integer, or you can make both double, and all such things you can try. One thing that I want to tell you is like, now because in this case you are doing double divided by integer, so it will give you double value, so it will give you 3.33. similarly in other places as well you will get some more precision, so it can give you like 30.0. let's try to run and see what is the output. Okay, you can clearly see first it is giving you 13.0 instead of 13, because as I told you we are using one of the variable as double now, so it will give you more precision now. So you can clearly see it is giving 13.3 for addition, 7.0 for subtraction, 30.0 for this multiplication, and then here you can see instead of 3 now we have 3.33333. I mean there are a lot of decimal places values here, but you can also restrict it to like maximum 2 decimal places, and all such thing we can provide. Then finally if you see here, the modulus gives you 1.0, so due to precision as we added the double, so it is adding 0.0 to it. So good learning here, if you do integer divided by integer, it will simply give you integer value, it won't include any precision after the decimal. But if any of the variables like a or b is double, then the final output will also be a double. So that's the power of double, because it has more precision, so it is given more priority as compared to integer. So if one integer variable and one double variable, we will give the final output as a double. Okay, so after the arithmetic operators, we have unary operators. In this, the most famous ones are plus plus, minus minus, and the not operator. So if we talk about the plus plus, say there is a variable a which has the value assigned as like 10. Okay, now if you do a plus plus, this means that we want to do a equal to a plus 1. Okay, so a plus plus represents same as this thing that I have just written. So the output of a plus plus will be, it will increment one value to a and then save it in a itself. So the answer of a plus plus will be 11. Okay, similar to plus plus, we have a minus minus operator which acts similar to what we just discussed. It will decrease one value from the current variable and then store it in that variable. And then if we talk about this logical not operator, what it does, it like it reverses the value. Say for example, whatever condition you made, if you apply not of it, it is like reverse that. So if the condition was giving true, not of that will give you false, and if the condition was giving you false, not of that will give you true. So let me take you to the IntelliJ, where we will try to write the simple logic or code for this, from where you will get more clarity, right? So let's go to the IntelliJ. Okay, so here you can see I have written a very small code in very easy way so that you can understand. I have created two variables here. First variable is a, which has the value of 5. Similarly, there is one more variable b which has the value of 5. Now here you can see I've used this operator plus plus, which is actual to writing as a equal to a plus 1. So this statement and this statement is completely same. You can see I have put this statement after two slashes, so this is a comment. So compiler doesn't treat this thing as a code, right? So I can write anything. I can also write my name, Mohit, this is the description, right? So this is a comment part that we discussed earlier. Okay, but basically a plus plus is equivalent to writing this line of code, a equal to a plus 1. Okay, and then we try to print it out. We are printing a. What will be the value of a? It will be 5 plus 1, that is 6, whereas the value of b would be still 5. Now after this we are using the minus minus operator, and we are doing that on b. Okay, so this is equivalent to writing b equal to b minus 1. Okay, so both of these statement, this and this, these are completely same. So next we are trying to print it out. The value of a is already 6 because we incremented it earlier. Now the value of b this time will become 4 because we have performed the decrement operator on the b. Now apart from this plus plus and minus minus, I have also used the logical not operator. So I have taken one more variable which is of data type boolean. Name of the variable is flag, so I have set the value as true to it. But then while printing, I have used the logical not operator alongside this variable, so it should print false because logical not performs the reverse operation. Okay, so let's try to run and see if we are correct or not. Okay, so the first time you can clearly see the value of a is 6 because we have already performed this increment operator, and the value of b is 5 because till now we have not performed anything on b till this point, right? After that we have performed b minus minus, so the decrement operator on the b, and then when you print the values it will say value of a equal to 6 and value of b equal to 4. Why 4? Because we use this decrement operator which is equivalent to decreasing the value by 1 and then storing it back in b. And for the flag part, you can see it has returned false. So we had set the value of true, but then we use the logical not operator, so it will reverse the value from true to false. Now here you can see we used a plus plus b minus minus, but we could also have used something like plus plus a and here minus minus b. So is this allowed, using the plus plus operator or minus minus operator before the variable? Is this allowed or not? The answer is yes, it is completely allowed. So what's the difference between a plus plus and plus plus a? This is a very famous interview question. So let's try to understand this. Alright, let's discuss a plus plus versus plus plus a. You can see here both have the same operator, which is the plus plus operator, which we discussed as the unary operator. But what is the difference of using it after the variable or before the variable? So as I told you earlier, a plus plus is equivalent to a equal to a plus 1, right? So this a plus plus is called as post increment. Now what does that mean? It means that it will return the value of a first and then perform the increment operation. Okay, so if you are using directly a plus plus in a statement, so what it will do is like return the value of a first and then perform the increment operation. Whereas if we talk about plus plus a, this is called as pre-increment. So if you directly use plus plus a in a place, it will increment the value first before using it. So before returning the value of a, it will do the increment first. I know you would say this doesn't make any sense. So let me take you to the IntelliJ, show you the output from where you will understand more about it. So let's do the coding now. Okay, so I have written a very small piece of code here. Try to understand this and guess the answer of this code. So I have taken two variables of type integer. Both have value 5 in them. One variable is a, other variable is b. Okay, then I have used the system.out.println statement, which is used to print, right? So in one I have used like a plus plus, so I have used the plus plus operator after the variable, whereas in other case I have written like plus plus b. So I have used the plus plus operator before the variable. So what will be the output? Guess the output. Okay, let me run this and then I'll explain you the logic. Here you go. The answer is 5 for this one and the answer is 6 for this one. So you can see both have different answers, although I used the plus plus operator and the variable had the same value. Why we are getting the different output here? The reason is using plus plus operator after the variable or before the variable. When you use it after the variable, it is called post increment, which means here in this statement you want the value of a. So when you do a plus plus, it will return the current value of a, and after that it will perform the increment operation. Because a plus plus, as I already told you, is multiple step, it is same as a equal to a plus 1, right? So if you are doing a plus plus and you need to return the value, it will simply return the current value of a, which was 5, and after that it will perform this increment operation and save it into a. But till that point we have already written the value, which was 5. So the answer of this statement is 5. Whereas when we talk about this statement, we are using the plus plus operator before the variable, so it is acting as like pre-increment. So here we need to return the value, so first it will perform the increment and then return that value. So if the value was 5, it will perform the increment, it will become 6 and then return it. So the answer of this is 6. Now I'll show you one more thing here. If I create a new variable c equal to 5 and I'll do c plus plus, and then if I do system.out.println c, now guess what will be the output of this? Will it be 5 or will it be 6? Let's see. Let's try to run this and you'll get the answer. Okay, the value of c is 6, not 5. Now you may ask, we use the c plus plus operator here, which is same as a plus plus, right? This is a post increment operation. So why does it return 6 here instead of 5? The reason is we performed c plus plus operation as a different statement here. So yes, this is equivalent to c equal to c plus 1, but after this complete statement ends, the new value of c is already assigned to it. And then when you go to the next statement where we are printing the value of c, it will print 6. But if you perform this operation in this statement, then you will get 5. Let me show you. Just comment it down and use c plus plus here. Now the output will be 5 here. Okay, let me show it to you. Here you can clearly see the new output is 565. So this returns 5 now, because we have performed the operation of c plus plus in this statement where we want to return the value of c. So when you want the value of c, so it needs to return, and the way it will return is return the value of c first and then perform the increment operation. So that's why this returns 5, whereas if you remove the comment here and simply put C here, this returns 6 because C++ is a different statement now, and it gets time to basically perform the increment operation and save it back to the C. Okay, so this is a very famous interview question, so that's why I thought I'll cover it with you. How to remember? I think it's very easy to remember. In one case you are doing C++, so you are giving priority to the current value of C, whereas other case you are doing plus C, so you are giving more priority to the increment operation, so hence it will give you the updated or incremented value. So this kind of trick you can use, but you need to remember this is applicable only when you are using this inside a statement which is trying to get the value, whereas if you perform here as a separate kind of thing, here you do either C++ or plus C, it doesn't matter because it's a single statement and we are not picking the value of C from here. We are simply updating C variable using C++ or plus C. That is totally fine. Similar to this, a minus minus and minus minus a behave the same way. What I want from you is to write this kind of logic for minus minus operator as well. Try to do minus minus after the variable and before the variable. You will see the same behavior that we talked about for plus plus. Okay, so try it out and you will get more clarity in the logics. Alright, so after a plus plus versus plus a, let's go back and see the next operator, which is relational operators. It contains equal to, not of equal to, greater than, smaller than, greater than equal to, smaller than equal to. You might have already guessed it, these are used for comparing the values. Now when we say equal to, this may create a huge confusion, like why not single equal to and why we are using double time equal to. The reason is one time equal to is used for assignment, like we did x equal to 10, so we are assigning the value of 10 into the x, whereas equal to is used for comparisons. If you want to compare values of two variables, then you will use equal to operator. Now let's see this in our code example so that you get more clarity. Okay, this is a small piece of code that we have written. There are two variables. First is x, which has value of 10, then other variable is y, which has value of 20. So what I've done is like use the print statement. In first I've checked like x equal to y. Now I told you single equal to is used for assignment. Like for example, you can see here x equal to 10, y equal to 20. But when we talk about double equal to operator, that is for comparison, so it is comparing x with y. Now this will return true or false. If the value of x is same as y, it will return true, otherwise false. But here you can clearly see x is 10, y is 20, so both of these are not equal, hence it will return false. Next operator I've used here is smaller than. X smaller than y, x is 10, y is 20, so this is correct, so it will return true. There are multiple other operators similar to this. There is greater than, then there is smaller than equal to, then there is greater than equal to. So last two operators that I talked about, greater than equal to and smaller than equal to, they also include the equality part. If two values are equal, then greater than equal to or smaller than equal to will also return true. And apart from that, we also have that not kind of operator. So let me also show you. System.out.println x is not equal to y. So we have used this not operator, which is telling that x is not equal to y. So here x is 10, y equal to 20, so this will also return true. Now let's try to run it and see if we are thinking correct or not. Here you can clearly see the first one, x equal to y, returns false because these are not same. Then x is smaller than y is true because x is 10, y is 20. And then the third one, x is not equal to y, this is also true because these have different values. So in this way you can basically use the relational operators which will be used to compare the values. Okay, so next let's talk about the logical operators. So example of logical operator is and, which basically represents and. Okay, so you might have seen the and operator in electronics. So if you do 0 and 1, it returns 0. If you do 1 and 0, it returns 0. If you do 0 and 0, it returns 0. If you do 1 and 1, it returns 1. Okay, so this is the same AND operator. Similarly, we also have the OR operator, which we studied in maybe electronics. So 0 or 1 is 1. 1 or 0 is also 1. 0 or 0 is 0, and finally 1 or 1 is 1. So like this we can use the logical operators in Java. So now let's see an example of logical operators in the code. Okay, you can see here I've written a very small piece of code. Two variables, both of type integer, a equal to 5, b equal to 10. Now here you can see first we have used the relational operator and then we have used the logical operator. So first condition, a is greater than 2. A is 5, which is greater than 2, so this will return true. And then we have applied our AND operator, and after that we have this condition, b is greater than 5. B is actually 10, which is greater than 5, so true and true. So which is 1 and 1, it returns true. Okay, so answer should be true. Let's see the next case. A is greater than 10. Now A is 5. Is 5 greater than 10? No. So this will return false. Then we have used this OR operator. The next condition is B is greater than 5. B is 10. So 10 is greater than 5. So this is true. So false or true, it will return true because we are using the OR operator here. If in case of OR we had the AND operator here, it would have returned false because false and true returns false, whereas false or true returns true. Okay, so the last one, we are using this NOT operator and we have applied this NOT on A is greater than B. A is 5, B is 10. So A is actually smaller than B. So this will return false, right? But we have applied the NOT operator. So it will reverse it and it will return true. Alright. So let's try to run and see whether our logic is correct or not. Okay. You can see here all three returns true, which was our prediction as well. So this is how you can use the logical operators, and you can clearly see using the logical operators you can apply many conditions. All right, with this let's move to the next operator, which is assignment operator. Now apart from equal to, which is the assignment operator, there are many other assignment operators as well, but those are not that famous or that widely used, so we can skip those for now. As you keep on coding, you'll get to know more of the operators and you'll pick the operators which you feel are more frequently used, right? So assignment operator, we have seen many examples like int x equal to 10. So you are simply assigning the values, that is assignment operator. Next we have bitwise operators, like for example XOR, NOT, left shift, right shift. So for now let's not go in detail into bitwise operator because these are also very rarely used. Yeah, you may use the XOR operator when you solve some of the DSA problems related to bitwise related questions, but apart from that I don't see much of usage there. So for now we can skip it. Of course you can come back and revisit it and explore more once you have the basic understanding of all the things that we cover in this video. Next we have the ternary operator, which we will discuss later in this video. And then there is also instance of operator, which basically checks the object type, but we will also cover this later in this video because it's too early to discuss about it right now, as we need to discuss few more concepts before it. Now one more thing, when we are talking about the arithmetic operators, there can be a case where we are using multiple operators in one statement, like we can do 2 plus 3 multiply by 5, this kind of thing, right? So we will simply use the board mass concept that we used to use in the mathematics. Similar way we will use it here in the Java operators. So brackets are given the maximum priority. After that you have the division, then multiplication, then addition, then subtraction, right? So let me write here board mass. So the same concept that we used to apply in maths, we will apply the same thing in Java as well in case you have multiple operators in a single statement. So this was about the basics of operators. What I want from you is to practice various cases in code using this so that you get more clarity and you get more confident using the Java operators. Now let's talk about conditional statements in Java. Now what does this mean? Let's take a real life example. While going outside, you say if it's raining, then take umbrella with you, right? So here you are adding a condition. If this happens, do this, otherwise do that. So in day-to-day life also, you do things based on some conditions. Similarly, in Java, we have these conditional statements using which we can put conditions in our code, and based on whichever condition is met, that particular code will run. Now there are a few ways for conditional statement in Java, but we will start with the first one, which is if. This will be the syntax of if condition. First of all, you will use the if keyword, then there will be a starting bracket, and before the closing bracket, we will put the condition. Don't worry about the condition for now. I'll show you an example for that later, but just try to understand if this condition is true, then whatever code that we are writing in these brackets, this is the opening bracket and this is the closing bracket. So whatever code is present inside this, that code will be executed, and just in case this condition is false, then this code will not run. So this is very similar to your real life example. If raining, then take umbrella. Now let me show you an example of if statement in the code through which we will learn more. Okay, so this is the code that you can see. First of all, I have created a variable. The name of the variable is age and its data type is int, which means it will contain integer value. So here it is containing value 20. Now after that, I have used this conditional statement. You can see, first of all, we have written this keyword if, and then there is this opening bracket, there is closing bracket, and between opening and closing bracket we have put a condition. Here we have put condition as age is greater or equal to 18. What is age? It's a variable that we have defined, right? So if the value of this variable is greater or equal to 18, then we want this logic to be executed. So here the value of age was 20, which is actually greater than 18. Hence this condition, age is greater or equal to 18, this is true. Now here you can clearly see we have used the operators here. We discussed about the operators and now we are using it, right? So because this is true, the code inside these bracket will run. So it should print this statement. Let's run it and see if it's actually working in the same way or not. Alright, you can clearly see here it has printed you are an adult. So our logic is working perfectly fine. So this was an example of if statement. Now because this condition was true, the code was executed. If I change the value of age to 10, now this condition will become false because 10 is smaller than 18. Now in this case, if I rerun the code, this should not get printed because this condition is now false, and this code will be executed only when the condition is true, but here it is false now. So let's try to rerun it and see what's the output. Alright, you can clearly see it has not printed now you are an adult. So our logic is working perfectly fine. Now let's see more things related to if. Okay, in real life example, you generally say if this is the case, do this, otherwise do that, right? So you generally also add otherwise, like if this is not happening, then do that, right? Like for example, in this case, if it is raining, take umbrella, otherwise no need to take umbrella, right? So in similar way, we would want something in Java for that otherwise part. So in Java, like we have the if, we also have the else. Okay, so else would act as the otherwise case, as I told in the real life example. If it's raining, take umbrella, otherwise no need to take umbrella. So this is the syntax of if else. First of all, you can see we have written the keyword if, then there is opening bracket, there is closing bracket, and in between that we have mentioned the condition. Then there is this opening bracket, which means if the condition is true, this code will be executed if the condition is true. Then there is the closing bracket of if. Now in previous example, we just checked if statement. So in addition to that, now we are introducing else case. Like what if we want to do something if that condition was false, right? Which means the otherwise case, like if it is raining, do this. But else will define otherwise case, like this condition was false, then what to do? If you want to define that, then else is the case. So you can write the code here, and which will be executed if this condition is false, then it comes to the else case. Now let's see an example in Java code so that you will get more clarity. Okay, so in this method, you can see I have introduced a variable. Name of the variable is age. It is of data type int, which means it will contain the integer value. So it is containing 16 as the value currently. We have used if condition here. Inside that we have mentioned the condition if age is greater or equal to 18, then do this, else do this. In the last example, we did not include else part. So when the condition was false, nothing got printed, right? So there was no action that we defined on that part. But just in case we want to define some action or something when the condition is false, then we need to define else case. So here you can see age is 16 and our condition is age should be greater equal to 18. Now 16 is smaller than 18, so this condition becomes false, which means this code will not be executed. But the good part is now we have defined the else case, which will be executed if this condition was false. And we know that this condition is now false, so this code will be executed. So this code should print you cannot vote yet. Let's try to run and see if it's working fine. Alright, you can clearly see it says you cannot vote yet, which means it's going inside the else part. Now the code inside if and else, there can be multiple lines of code. It's not the case that you have to add only one line of code. You can have multiple lines of code. For example, I can print something else here as well. Like I can write here, we are in else case. Apart from this, you can add anything else as well, but you can clearly see this got printed as well. So in this block, you can add as much code that you want to add. Okay, now if I change the value of age from 16 to 26, this condition will become true and this code should get executed. Now else part won't get executed, this part would get executed. And let me show you by running this. You can clearly see now I have changed the age to 26 and it says you can vote, right? So the important part to understand here is that when we write if else, only one of those will get executed. Either the code in if will be executed or the code in else will be executed. You can clearly see there will be no case where both of these will get executed. So if the condition is true, the code inside if block will get executed. If the condition is false, the code in else part gets executed, right? So you can create your own conditions and based on that you can play with it and you'll get more clarity how the things work. All right, let's move back and see what else can be done in if else. Okay, so when we are talking about real life scenarios, you generally have multiple conditions. There can be a scenario of if and else, but there can be also a case where you have multiple conditions, like if mangoes are present, make mango shake. If banana is present, make banana shake. If chiku is present, make chiku shake. Otherwise, give me plain milk, right? So here you can see we have multiple conditions. I said mango, banana, chiku. If nothing is present, otherwise you can simply give me the plain milk, right? So how can we do something like this in Java programming? We can do that using these keywords. First, we know we have the if, then we also know the else, right? So the first case is satisfied by if and the last case, which is the otherwise, is satisfied by else. What about the other conditions? How can you execute that? You can do that using else if. Okay, we have combined else and if, it becomes else if. Now the good part is there can be multiple else if, because you can have multiple conditions, so there can be multiple else if statements as well. Let me show you the syntax through which you will get more clarity. Okay, so this is the syntax of if, else if and else. We have already talked about if, right? And we have also talked about else. Now let's talk about else if. So basically, if the condition 1 is correct, then only the block 1 will get executed and nothing from this will get executed. Okay, but just in case the condition 1 is false, earlier we directly moved to else part, but now before else we also have else if, where we are defining more statements, because in else case there is no condition. It is just like the default or the case you say otherwise do this. If nothing is satisfied, do this. Like if there is no mango, no banana, no chiku, then give me plain milk. Okay, which is the kind of the default case, because we are saying milk is already present, we are just checking for the fruits. If no fruit is available, just give me the plain milk, right? So that is the else case where there is no condition. You can say the worst case or the default case, whatever you can say. So if the condition 1 is false, then it won't go directly to the else, it would go sequentially. Okay, so it will now check this else if part. It will check for the condition 2. If the condition 2 is true, then this code will get executed and nothing else will get executed. So comparing it with our real life example, the first condition is acting as like mango. If mango is present, give me mango shake. But just in case mangoes are not present, it will go to this case where condition 2 is acting as like banana. Else if bananas are present, give me banana shake. So then this code will get executed and nothing else. But just in case even bananas are not present, then the third case will run, which is else if condition 3, which is like chiku, which means if mangoes are not present and bananas are not present, but if chikus are present, give me chiku shake. Okay, so this code will get executed. But in case all three of these conditions are failing, you will reach to else case. And in else we don't have any condition, so it's kind of the default case. So the default code will run, which is give me the plain milk. So here you can see again only one code block will run, either this one or this one or this one or this one. Once one code block is executed, this complete conditional flow is done. It won't go to any other condition. It will go sequentially to the other condition only if the condition above are false. So if condition 1 is false, it will go to condition 2. If condition 2 is also false, then it will go to condition 3. So when we are reaching to condition 3, it automatically means both condition 1 and condition 2 are false. And if it is going to else case, it means that all the conditions above, that is condition 1, condition 2, condition 3, all of those are false. Now another thing to remember is that all of these else if and else, these are optional, because in the beginning I gave you an example of if statement. We did not use else, we did not use else if. So these are optional. This basically provides you opportunity that if you want to write additional code based on the situation or condition, you can write that in else if and else part, but these are not like mandatory kind of things. So now let's go to IntelliJ and let's see one of the example through which you will get more clarity. Okay, so you can clearly see I've written some code in which we have used if, else. All three of these we have used, and you can clearly see we have used multiple else if. So as I already told you, all this part of else if else, this is optional, because in the beginning we saw an example of just using if without else if, without else, and then we also saw an example of if and else, and now we are using if, else if and else. So these things are optional. Okay, so in this example what I've done is like created a variable named as marks. It is of data type int and the value present is 85. Okay, so the first condition that I've applied, if marks are greater or equal to 90, then print grade is A plus. Okay, then we have written else if marks is greater or equal to 80, then do this. Similarly we have applied one more condition of 70, and then there is the else, which is the default case. If nothing is satisfied, go to the else case. Okay, now let's understand the flow with this example. So the value of marks is 85. First it will check this condition, which is part of if 85 greater equal to 90. Now this condition is false because 85 is smaller than 90. So this code will not get executed. Now I told you this will go in the sequential order. Next it will go to this condition. So it will now check 85 is greater equal to 80, which is true, right? Because 85 is greater than 80. So what will happen is this code will get executed. It should print grade A. Now once this code part is complete, because it has already executed this and there is no more code inside this, nothing else will get executed in this. Only this part will get executed, and it won't go to the next condition because this was true. This part will be executed and it will come out of this conditional flow. Okay, so let me run this and you'll get more clarity. Here you can clearly see it says grade A. Now let me change this to 75. Now what will happen? First it will check this condition, 75 greater equal to 90, which is false, so this won't get executed. Then it will go here, it will check 75 greater equal to 80, which is again false, so this won't get executed. Then it will come here. Why here? Because it is going sequentially. It checks 75 greater equal to 70, which is true, right? So this code will get executed. It should print grade B, and after that no more code will get executed in this conditional flow. It will get out of this. So let's see what gets printed. Clearly you can see it prints grade B, which is according to what we thought, right? Now let's again change this value to 65, and now let's see what happens. Okay, again it will first check in this statement 65 is greater or equal to 90, which is false, so this won't get executed. Then it will come here, it will check 65 greater or equal to 80, again false, this won't get executed. Then it will come here, it will check 65 is greater or equal to 70, again false, so this won't get executed. Now the else part does not have any condition, so this is kind of the default case, so everything is false till now. So it will come here and this code will get executed, so it will print grade C. So let me run this code and you'll see the answer. Clearly you can see it says grade C. Alright, so you can clearly see only one of these will get executed. Right now, one more thing in the syntax, you can write else if or else in the same line as the ending bracket, and you can also put that in the next line. This is also fine. Okay, if you want to write it separately, that's also fine, you can do, this is also valid. If there is only one code line inside the if block, you can remove these brackets as well. So if I do something like this, but it will give you error if you have multiple lines of code. So if I am writing system.out.println hello, so this is problem now because it can't understand this is an ambiguity. It works without brackets only if there is only one line of code in the block, but if there are multiple lines of code, then you need to define these brackets. Okay, so let me add that bracket and it should work fine now. But of course, I mean, as you are new to this language, you don't need to create any confusion. Just add these brackets because you don't need to think for that part. Simply add brackets and you can write one or many lines of code. It's totally fine. And if you want to keep things like separately, like else if in a separate line, that is also fine. For example, here also I can put that in next line, and else also I can put in next line. So whatever makes you feel more comfortable and easy to write code and read code, make it that way. It's totally fine, there is no issue in that part. So as I told you, else if else are optional, but one thing that you need to understand is that you cannot use else if or else without if. Okay, you can use if without else if and else, but you cannot use else if or else without if, which makes sense, right? Like you will say, if it's raining outside, take umbrella, otherwise don't take umbrella. But you won't say otherwise don't take umbrella. But what otherwise? What's the condition to which you are adding the otherwise, right? So if I show you an example of that, if I remove all this, so if you simply put else, this will give you error because there is no if statement. Okay, see, you can clearly see it says else without if. So even in the case if you put else if true, right, so even this will give you error because it says like without if you cannot use this. So if I simply add if here, if marks is greater than 90, now it is not giving any error, right? So you cannot use else if or else without if, but you can use if individually. Like if doesn't need else if or else as a mandatory kind of thing. You can use if individually as well, but you cannot use else if else without it. Now one more thing is that you can have nested ifs, so you can have multiple if statements. So what I mean by that is, like inside if you can also have one more if, so if and if, so you can clearly see there is nested kind of ifs. So you can do that kind of thing, that is allowed. So this is called nested if, because you have one if statement inside another if. So let me show you one example through which you will get more clarity in through the code. Okay, you can clearly see here we have two variables, one is of data type int and another of data type boolean. So we have used the if condition here, if age is greater equal to 18, and inside that we have used another if statement, right? So this is an example of nested if, right? So let's see with this example, we have applied the condition age is greater equal to 18, so the value of age was 25, so 25 greater equal to 18, which is true. So the code flow goes inside this, it won't go inside this because this statement was true. It would go here only if this statement was false, but it is true, so we will go inside this. Now it checks if hash id, now hash id is true, so this becomes true, so we'll go inside this. We won't go inside this because this statement was true. If this was false, we would have gone there, but because this was true, we'll go inside this. So it should print you can enter the club. Now let me run this and see if our logic is correct or not. Okay, you can clearly see here it has printed you can enter the club. And why that happened? Because this statement was true, so we entered this part, and then this was also true, so we entered this, so it executed this code, right? Okay, so this was about if else. But one thing that you might have noticed here is that when we are using if else, then only one code block will get executed based on whichever condition was true. But what if we want multiple cases to be executed? So for that we use switch. Okay, so I'll show you the syntax of switch through which you'll get more clarity, and then I'll show you an example of it. Alright, so this is the syntax of switch. First of all, you write the switch keyword, then there is a bracket, then there is closing bracket as well. Inside the opening and closing bracket we have the variable. Okay, now you can see the starting bracket of switch, and now you define various values, and you define that using the keyword case. So case value 1, it's code. Now this break statement is optional and we have not covered break yet, so you can ignore this for now. Okay, after that again you have the case keyword, and then you put the value 2, and then it has the code. Like this you can define multiple cases. And finally you have the default keyword, which means if nothing matches, so you'll go to the default case. I know it might sound confusing, so let me show you an example in the IntelliJ so that you get more clarity. Okay, so here is the code. You can see a variable day which is of data type int, and the value is 3. So we have used the switch conditional statement here. So we write the keyword switch, then there is this starting bracket, ending bracket containing the variable, so it contains the variable day which has the value 3. Now this is the starting bracket in which we will write the code for switch. So first is case 1. So as there are like 7 days in the week, 1 is representing Monday, so we are writing case 1, which means we will print system.out.println Monday. Ignore break for now. Then case 2, Tuesday. Case 3, Wednesday. And then we may also write more cases like case 4 Thursday, case 5 Friday, case 6 Saturday, case 7 Sunday. But here we have simply written default, which means if none of these are matched, then you go to the default case which says other day, right? So in this case what will happen is, like, because the value was 3, it will first go here, it will match 1 with 3, they don't match, so it won't go inside this. It will go to the next case which is 2, it will match 2 with 3, it doesn't match, so it doesn't go here. It will go to the next case which is 3, now 3 matches with 3, hence this will get printed. So it should print Wednesday. Let me basically run it for you and you'll get an idea. Here you can clearly see it prints Wednesday, so our logic is working fine. Now you will ask, here also we are going to some specific case, right? It's not going to multiple cases. How is it different than if else? So if I remove this break statement from here, let me just comment it out instead of removing it. So when I comment it out, we know that this won't get executed, so this is similar to now like we removed it. So you can also clearly see the color has also changed, so the compiler will ignore this. So when we comment this out, again the flow will be like, it will check first case 1, which is like 1 with 3, it doesn't match, it goes to the next one. 2 with 3, it doesn't match, it goes to 3, it matches, right? 3 matches with 3, so it will print Wednesday. But after that it won't stop, it will go to the next case and it will also print other day because it has received a true condition, and after that it won't stop, it will just print everything else after it. So in this case it will print Wednesday and other day. Let me show it to you, like what is the output. Clearly you can see it says Wednesday other day, so it printed both of these. So now if I replace the value of day to 1, and currently we have this break, so let me comment out break here, which is optional, you can remove that. So let's see what will be the output. Let me run that and see what's the output here. Okay, you can clearly see it says like Monday, Tuesday, Wednesday, other day. So it printed everything. Now what's happening? Let's understand. So basically it will check with case 1 first. So 1 matches 1, so this is true, right? So this code block will run, so it will print Monday. But now there is no break statement. Break is something which will get you out of this. As I told you, in case of if else, only one code will get executed, but in case of switch you have that power that you can run multiple cases. So what happens in switch is that whenever you get your true condition, so all the cases after that, so all the cases which are coming after that or below that, you can say, all of those will get executed. In case you want to stop that flow, you will use the break statement. But because now I have commented out break, so what will happen is, like, because it got a true statement here, this will run, this will run, this will run, this will run. So anything which comes after the true statement, it will run. Okay, and that's why you can see it has printed Monday, Tuesday, Wednesday, other day, right? So it has printed everything. But just in case here, if I put the break, okay, so the output now will be Monday, Tuesday, Wednesday. It will stop here because we have applied the break. The good part is the naming is very similar to the English language. Like, you apply brake in your vehicle, like your car, when you're driving a car, you apply the brake, it stops. So similarly here, when you apply the brake, it stops. Let me show you when we run this, what's the output. Clearly you can see it says Monday, it will run Monday because there is a match. Then it will also run Tuesday because there is no break. All the cases after the true statement will keep on running. So it prints Tuesday, then it prints Wednesday because there was no break. But after Wednesday there is a break, so the default case did not run. Okay, don't worry if you are not able to understand break for now, because that's a separate topic and we'll cover that in this video later on. But the important part to understand here is that when we talked about if else statements, I told you, like, only one of the code block will run. But the power of switch is that here multiple code blocks can run. You can clearly see the case of one was ran here, then two, then three also. Why? Because it got a true statement at one and there is no break statement. So all of the cases after that will run irrespective of the value. So you can clearly see 2 does not match with day, but because it got the true statement at case 1, after that it won't see any of the cases. It will just execute everything after it. But if you want to stop that, you can simply apply break to it. Now there is one more thing, like, this is the old kind of syntax of switch statement. Starting with Java 14 plus, you also have new syntax of switch, where you can avoid the use of break and make it quite similar to what we have, the if else if kind of. But I think we can ignore that for now. You should get the basic fundamentals of switch. This also works even for the latest Java. You can write this code, it works perfectly fine. So if you're able to understand this, it's good. Later on you can read more about what's the new things which are happening in Java 14 or Java 21, and you'll always have that thing, keep new things coming, and you can read more about it. That's fine, but this is like the old one, but this is kind of quite famous or original one also. You can go through it, try to make some changes in the code and try to learn it. You'll get more clarity, right? So we have talked about if and switch. So after this, let's talk about the ternary operator. Okay, so here it is. This is the third one in the conditional statements after we talked about if and switch. So this is kind of like, you can say, the shorthand form of if else. We talked about if else statement, right? For example, this is the case of if else. First we have applied if there is a condition age is greater equal to 18, then do this, else do that, right? So if you want to write it in a short way, you can use the ternary operator. Here you can clearly see what we have written is message equal to this condition is same as this one, right? And after that we have put a question mark here and then put this value, right? And after that we have put that colon here, which is acting as the else part, and then we have mentioned the code which was part of else part, right? Now this is fine if your if else was like bit simple kind of code, but once your if else is complicated, or you have if else all such kind of conditions, you won't be able to use ternary operator there. So it is not that highly used. But for simple statements, like if you have only if else, then you can use something like this. It is something like, you can see the code which was written in 4 lines, we have written it in 1 line, but it's not that widely used. Like if else, switch, these are like highly used. Okay, but for a ternary, if you want to understand, it's like you first give the condition and then you give the question mark, which means that if this condition is true, then do this, and then you have this colon which is representing else, which means if this condition was false, then do this. So this is acting as the else case, this is acting as the true case inside the if condition. Okay, if you're finding it a bit difficult, don't worry about it. We won't be using ternary operator too much. It's just like I told you, because we were talking about the conditional statements. But you should really practice if, and alongside it you have this else if and then the else. Okay, you should practice this, and apart from this you can also practice the switch statements. Okay, using which you will understand the conditional flow, how things work. Like you have to write code, if this is a thing, do this, else do this, all such kind of scenarios, you'll get more clarity, right? So this was about the conditional statements in Java. Now let's talk about loops in Java. What is a loop? In normal English term, you know that if a thing is repeating multiple times in the same way, we call it as a loop, right? In similar way, in Java, if you want some particular block of code to run again and again till some condition is met, we use loop for that. Let's try to understand this with an example. Say you have to print hello. Okay, so if you have to print it one time, you will simply write system.out.println hello. But say you have to write hello for 10 times, then let me take you to the code and then see. So I'll write system.out.println, I'll write hello, right? So if I write it once, if I run the program, it will print only once, right? You can see here hello. But now if I want to print hello 10 times, then I need to write this code 10 times, right? So let's say we are talking for the 5 times now. Okay, so I've written this statement 5 times, you can see, and now when I run it, it will print hello for 5 times. Correct? 1 2 3 4 5. But you can see this is a redundant piece of code. You are writing the same piece of code again and again, and this doesn't make much of sense. So here comes the usage of loops. What we want is this line of statement we want to repeat 5 times. So let me remove these 4 statements, and now I'll write an example of loop. Don't worry about the syntax because we are going to discuss all of that in detail, but I'm just going to show you an example. I'll write for int I equal to 1, I smaller equal to 5, I plus plus. This is the opening bracket and this is the closing bracket. Inside this, I'll put this code which we want to repeat. Okay, so this is basically the loop, and what it will do is like repeat this statement multiple times till some condition is met. So let me run this for you and you will see the output. Okay, you can clearly see it has printed hello for 5 times. So instead of writing system.out.println hello 5 times, we have written this only once and put it inside a loop. So before understanding the syntax of this, let's try to understand something more about the loops. Let's first talk about types of the loop. There are majorly 4 categories of loops in Java. First is for loop. Okay, we just wrote the code for loop here. Okay, so this is type of for loop. When is this used? When the number of iterations are known to you. For example, here you applied the condition I is smaller equal to 5, so you knew that you want to run it for 5 times because I started with 1 and we are incrementing I one by one. Okay, so this will run 5 times. So in case you already know the number of iterations, you can use for loop for that. Okay, the next category is while loop. Now all of this might sound weird to you for the first time, but don't worry, just be with me, try to understand this, and once you do bit practice of it, you will get more understanding, and with time you will do it quite easily. Okay, so in for loop we said like the number of iteration is known to us. So in case number of iterations are not known, we can use the while loop, which is more of condition based. So after while loop there is do while. Okay, so what is the difference? Basically while loop will execute till the condition is met. Okay, so it might be even possible that it doesn't even runs once because in the beginning only the condition was false. But in case of do while, it makes sure that the code block is run at least once even if the condition is false. So in case you want your code block to run at least once, you can use do while loop. And the last one is for each. So for each loop is used to iterate like arrays or the collections. I know too much of theory, like we talked about all 4 of these, but don't worry, now we are going to talk in detail about each of these, and we will also see the code snippet for these, from where you will get more clarity of it. Alright, let's first talk about for loop. Okay, so this is basically the syntax of for loop. Okay, so first of all you will write for keyword for, and then you have this opening bracket, there is closing bracket. Inside these brackets you can see there are three things present. So first part is initialization. This is to initialize any variable through which you can apply any conditions. The important part to understand is that this part of initialization runs only once, okay, which is the first time, because you want to initialize something at the first time. It won't run again and again when your loop runs. It runs only once at the beginning. Now we will also see an example of this. You can clearly see here we wrote like for, this is the initialization part. So we have initialized a variable I which is of type int, and we have assigned it the value of 1. So we have done the initialization, and this will run only once at the beginning of the loop. Okay, after that you can see there is a semicolon, so which means initialization is done. Now we move to the next part. What is the next part? The next part is the condition. Now this is very important, because based on this we decide how many times this code statement or code snippet will run. And the important part is, like we said, initialization will run only once at the beginning. Condition part will run every time the loop is running, because based on this only the loop is running. When this condition is true, loop will keep on running, and when this condition becomes false, the loop will stop. Hence this condition part will run every time. It is not like initialization which runs only once. Condition part will be checked every time, because based on this only our loop will run or stop. So example of condition is, you can clearly see we wrote like I is smaller equal to 5. Why did we write I is smaller equal to 5? Because we wanted to print hello 5 times. We initialized I with 1. So that's why we have written I is smaller equal to 5, because I will be 1, then 2, then 3, then 4, then 5. And even in case it is 5, we want to run the statement, because we want to print it for 5 times. And next time when it becomes 6, we want the loop to stop, right? So this is the condition part which runs every time. I'll explain it to you how things work, but for now let's see the syntax. Okay, again after condition you have this semicolon, and after that you have this increment or decrement. Now what is this? Basically you have initialized a variable and you have applied a condition to the variable. Then you also need to make changes in the variable, right? If we initialized I from 1 and we have applied the condition I is smaller equal to 5, which is of course the case from the beginning, because I was 1 and we wanted it to be smaller equal to 5. If we don't apply anything here in the third part, I will always remain smaller than 5, and this loop will keep on running and running and running and running. It would never stop, right? So we also need to modify this variable, and that would be done here. We would either generally increment it by 1 or decrement by 1, but you can do anything here. Like you can increase by 2, multiply by 2, multiply by 5, whatever. So this is like you want to make changes in the variable based on whatever conditions you have put, based on like how many times you want your loop to run. Okay, so you will see a lot of examples where we will simply do I plus plus. This is the operator that we discussed earlier, right? So it basically means like we are incrementing the value of variable I with 1, right? So it is same as I equal to I plus 1. So if we don't write this, I will always remain 1 and this condition will always remain true, and hence this loop will keep on running, and that is not a good thing, because if something keeps on running, it is consuming memory, right? You will get the stack overflow and your program will stop. You will get the exceptions, errors, and it won't work, right? So you want to put something which is relevant to your case here. Okay, so this also runs multiple times. I'll explain it to you how the things work with this example. Okay, you can clearly see we have this for keyword, then we have this opening bracket, then this is the initialization part. We have initialized variable I with value 1. It is of data type int, and then we have put the semicolon, so the initialization part is done here. After that we have this condition part where we have mentioned the condition, which means like how many times this loop should run, and then we have this semicolon, which means that the condition part is also done. And next we have the increment or decrement part. We have done I plus plus, which means we are increasing the value of I by 1 every time. And then starts this opening bracket, which means that we are writing the code snippet which we want to run multiple times. And then we have the closing bracket of this code snippet, right? So how things will work: first initialization will happen, so it will do I equal to 1. Okay, so let me write here. The first thing that will happen is I equal to 1 will happen. Okay, and then it will check the condition. You can clearly see before running the code it is checking the condition. So it checks whether 1 is smaller equal to 5, which is true. 1 is smaller than 5, so this condition is true. Then it does not go here. Okay, it does not go here, it goes here. The code is executed. The increment decrement is not done at the beginning, it is done after you execute the code. Okay, so I was 1, this condition passed, it goes there. What happens with this? It prints this statement. So first hello is printed. Now after this what happens? It goes here. It doesn't go here, it goes here. So it will do I plus plus, which means I equal to I plus 1, which means I is now equal to 2. So I'm writing I equal to 2. Now I told you initialization part runs only once at the beginning, so this will not run again. Now after this it will again check the condition, because before running the code snippet it will always check for the condition. So it will check again 2 is smaller equal to 5, which is true because 2 is smaller than 5. So now what will happen? This code snippet will run. Again it will print hello. So hello is printed second time, right? Now what will happen? Again I plus plus will happen. So can you see the pattern here? The condition runs before the snippet, whereas the increment decrement happens after the code snippet, right? So we printed hello, now it goes there. So it will again do I equal to 3. Let me also write here 1 is smaller than 5. Okay, so you can clearly see first it does I equal to 1. It then checks this condition which says like 1 is smaller than 5. So it prints this. Okay, so let me write hello. So this is the flow. It does I equal to 1, then the condition I is smaller equal to 5, then it prints hello, and after that it does the increment, then I becomes 2. Again here it will check 2 is smaller than 5 and it will print hello. Okay, and after that this will run. So we have made I equal to 3. Now when I becomes 3, again the condition is run. So condition always runs before the code snippet because it decides whether the code snippet should run or not. So again it will check 3 is smaller than 5. I mean the condition is I is smaller equal to 5. So I'm just writing this is true, so this is also true, or you can also put equal to everywhere to avoid any confusion. Okay, so this will again print hello. So the third hello is printed. So let me write here hello. So you can clearly see 3 times hello has been printed. After this what will happen? This will run because the increment decrement part runs after the code snippet, right? So the code has been executed, so this will now run. So now it will make I equal to 4, right? Again it will check this condition because before executing the code the condition is checked. So it will check 4 is smaller equal to 5, and this is true, right? So it will execute the code and hence it will write hello, right? And once the code is executed, this increment decrement is run. So it will again make I equal to 5, right? So I equal to 5, before executing the code condition is run. It will again check 5 smaller equal to 5, and this is true, right? Now let me put this in the next line so that you can clearly see this. Okay, so you can clearly see I became 5 due to this. Then the condition part, 5 is smaller equal to 5, which is true because 5 is equal to 5. So what it will do? It will print this. So again it will print hello. So you can clearly see 1, 2, 3, 4, 5 hello. So the fifth hello is also printed. Now what will happen after the code has been executed? I plus plus will run. So what it will do? I will become 6. Now before executing the code, condition is run. So it will check 6 smaller equal to 5. Now this is false because 6 is actually greater than 5, but we are saying 6 is smaller equal to 5. So this is false. So when this becomes false, this will not run. The loop will stop here. Okay. So that's why there is no sixth hello and the complete loop will stop. So this is the complete flow. First of all, initialization, then checking for the condition. If condition says true, the code snippet runs. After code snippet runs, you do increment decrement, and then every time you will check the condition, run the code. If condition is true, then again increment decrement, then again condition. Based on true, go to the code flow, and then again increment decrement. So every time before you run the code snippet, you need to check the condition, and every time the code snippet is run, after that you will execute the increment decrement, and anytime the condition becomes false, you stop the loop. The execution of loop stops there. Okay. So this is the for loop. Now what I want from you is to write a very small code, something like this, or you can modify this. Like for example, you can change the conditions here and try to print. You will get an idea how things are working, and also on paper pen try to understand how things work. Okay. Initialization first, then every time the code snippet runs, before that the condition part is checked. Every time the code snippet runs, after that you do the increment or decrement. And this makes sense, right? Because if you don't do the increment decrement, then this may always return true and your loop would never stop. So once you execute the things, you would want to change your variable, right? So that's why after your code snippet runs, you do that increment decrement or whatever changes that you want to do in the variable, because based on that your condition will be checked again. Now in real life you may not write hello 5 times, right? But you may write like 1, 2, 3, 4, 5. So we can change this example. Instead of hello, let me print I. So now what will happen is it will print 1, 2, 3, 4, 5. Clearly you can see here 1, 2, 3, 4, 5, right? So it makes more sense now. So like this, there are many applications of using loop. So try to practice this and you will get more clarity. All right, after the for loop, let's discuss the next one, which is while loop. So first of all, instead of for, now you will use the keyword while. Then we will have the opening bracket, the closing bracket. Now inside this, you don't have three things like the for loop. In for loop, you had the initialization, condition, increment, decrement part. So while loop doesn't have all those things. While loop will just focus on the main thing, which is the condition. So while loop has the condition, because as I told you earlier, for while loop you don't know how many times you want to run the loop. Your loop will keep on running till this condition is true, and once this condition becomes false, your loop will stop. Okay. And then the opening bracket, inside which you will write the code snippet which you want to repeat again and again till the condition is true, and then you have this closing bracket of the code snippet. Now you may think, like in the for loop we had the initialization, condition, increment, decrement, but in the while loop we just have the condition. So where will we write the logic of initialization and increment, decrement? We will see that. Okay, I'll show you with an example, and you will get more clarity with it. All right, so this is the example. Here you can see this is the while loop. First of all, you write the while keyword, then the opening bracket, closing bracket. Inside those brackets you have the condition based on which your code snippet will run again and again, right? So here we have put the condition as I is smaller equal to 5, and then this is the opening bracket inside which you will write the code snippet. This is the closing bracket of the code snippet. Inside that we have written the code. Okay, now the question that we had, where this is the condition which is fine, which is similar to what we wrote in the for loop, but where is the initialization and the modification of the variable part? So you can clearly see The initialization we will do outside of the loop, that is not required to be the part of the loop, that can be done before the loop. And similarly, when we talk about modification in the variable, we can do that inside the code snippet, that does not need to be part of the loop syntax, right? So here you can clearly see this is the initialization which we normally do, like we have defined initialized many variables earlier, right? So we have initialized a variable. In the while loop, we have simply provided the condition that this variable should be smaller or equal to 5, or it can be any other condition based on your requirement. Here I've just put like I is smaller or equal to 5. So this is the only condition which the while loop will check. Inside this, we have written the code snippet what we want to do, right? So we are printing the number. But the important part is, because the while loop does not contain the increment decrement part or the part where you will modify the variable, so you need to make sure that you don't forget to write that logic inside the code snippet body. Because if you miss this part, then I will always remain 1, and this condition I is smaller equal to 5 will always remain true, and this will keep on running and running and running, and it will result in stack overflow, exceptions, errors, and your code won't work properly. Okay, so you need to make sure that modifying your variable is part of your code snippet. So how does this work? I'll tell you. Before that, let me run this for you and you can see what is the output. So clearly you can see it says number 1, number 2, number 3, number 4, number 5. So it has run this for 5 times. So how does this all work? So basically what will happen is, in the beginning we have initialized I equal to 1. That is fine. So when the while loop starts, it always checks for the condition. It will check 1 is smaller equal to 5, which is correct, right? So when this condition is correct, this is true, this code snippet will run. So it will print this. So it will say number 1. So this gets printed, right? And after that, inside the code block, we have written I plus plus. So I will become 2 now. Now again, once this code snippet ends, the while loop will simply check for the condition whether it's true or false. Okay. So it will check now 2 is smaller equal to 5, which is again true, right? So because this is true, this code snippet will run. So this will run and it will print number 2. And after that, it will increment I by 1. So now I becomes 3, right? So once this code snippet is over, again while loop will simply check for the condition. It will check whether 3 is smaller equal to 5, which is again true. So because this is true, this code snippet will run again. So it will print this part, number 3, because the value of I is 3 now, right? After that, we are doing I plus plus. So I will become 4 now, and the code snippet ends here. So while will simply again check for this condition. It will check whether 4 is smaller equal to 5, which is again true, right? Because 4 is smaller than 5. So this is true. So this code snippet will run, it will print this, and hence this gets printed number 4, and it will basically increment I by 1. So I will become 5 now, right? And the code snippet ends here. So again while will check this condition. So it will do that check 5 is smaller equal to 5, which is again true because 5 is equal to 5. So because we applied smaller equal to check, so due to equality check, this is again true. And because this is true, again this code snippet will run. So this will run this. So this number 5 will get printed, right? And then it will increment I by 1. So I will become 6 now. And again it will check this condition. It will check now, because the I is 6, it will check 6 is smaller equal to 5, which is false because 6 is greater than 5, right? So now because this returned false, this loop will stop here. It will not execute this code snippet. You come out of the loop directly. So as soon as you get a false in the condition, the loop stops, you get out of it. Okay, so that's why you can clearly see it printed only till here, right? So this is the flow. So while loop is, you can say, more simpler as compared to the for loop, because you are just checking for the condition. but you need to make sure that you are modifying the variable by yourself in the code snippet, because if you forget doing this, it will keep on printing 1 2 3 4 5 6 7 8 9 10. It will keep on going and you will get exceptions, errors, stack overflow, right? So if you don't write this condition, it will stuck in the infinite loop, right? Okay, so this was about the while loop, right? Now let's see the third category, which is the do while loop. So the main part of do while loop is that even if the condition is false, it makes sure that the code block runs at least once. Now what does this mean? Let me show you. Say for example, I was 10 here. Okay, so first of all, before running this code, while loop would check 10 is smaller equal to 5, which is false, so this code will never get run. If I show you the output of this, you'll see nothing gets printed. You can clearly see it doesn't print anything, right? So this part is the default kind of things. It just tells about the JDK and the code has finished, so it has just printed that, but there is no output based on our code, right? So this did not get printed. So you can clearly see in this case our code, which was part of the loop, was not executed even once. So here comes the do while loop. So if you want your code snippet to run at least once, irrespective of the condition is true or false, then you can use do while loop. Here is the syntax. I'll show you an example where you will get more clarity, but here is the syntax. Similar to what we did in the while loop, you have this while keyword, then you have this opening bracket, closing bracket, you put the condition, but the code part now comes in the do block. So first of all, you write do, and then you have the opening bracket, closing bracket. Inside this you have the code block which you want to repeat or which you want to run at least once, and then maybe repeat based on the condition, right? And after that you write this while condition and then the semicolon. Now let's see an example so that you get more clarity. Here you saw that this while loop did not print anything, right? Because I was 10, but in our condition we wrote while I is smaller equal to 5. Now let's modify this using the do while, and let me cut this part. Let me put it here and add a semicolon, right? And let me write here do. So this is a syntax of do while loop. You can clearly see we have just modified it a bit. The while part we have put down there and we have written do here. So it is same as the syntax that I was showing you here, right? We have just mentioned the conditions here. So let's see what will be the output here. With the while loop, we knew that it did not print anything because I was equal to 10 and the condition was I is smaller equal to 5. So it would be saying like 10 is smaller equal to 5, which is wrong because 10 is greater than 5, right? So that's why the code didn't execute, but let's see what happens now. Let me run this. Okay, all right, you can clearly see it prints number 10. What happens here? Okay, so first of all, what it will do is, like, as it is a do while loop, so it will execute this code snippet without even checking the condition. Okay, so it will simply run this. So it will say number and I, the value of I was 10, so that's why it said number 10. Okay, after this it will do I plus plus, which means it will make I equal to 11 now. Now after this, what will happen is it will go here. It will check whether I is smaller equal to 5. So it will check 11 is smaller equal to 5, which is not correct. So this condition is false, and that's why this code block is not executed again, right? Because this condition became false, and in order to run it again and again, we want that this condition is true. Now let me change this to 1. Okay, now let's see what is the output. All right, you can see it is same as what we did in while loop, right? Because the flow is, first of all, I was 1, so without checking the condition it will run this code block. So it will print number 1 and then it will do I plus plus, so I becomes 2. Now it will check for the condition. It will check whether 2 is smaller equal to 5, which is true, and that's why this code will run again. So it will say number 2, right? And then it will increment the value of I by 1, so I becomes 3, and again it will check for the condition. Then it will check 3 is smaller equal to 5, which is true. That's why this code runs again. So it will print number 3 and it will make I++, due to which I becomes 4. And again it will check for this condition where it will check 4 is smaller or equal to 5, which is true. And that's why it goes inside here again and it prints number 4 and then I++, so I becomes 5 now. And again it will check for the condition 5 is smaller or equal to 5, which is true. So this will run again. So it will print number 5 and now I++, so I becomes 6 and it will again check for this condition 6 is smaller or equal to 5, which is wrong, right? So it returns false. So your loop ends here, right? It's very similar to while loop that we discussed earlier. Just the only thing, the first time it will run the code snippet without even checking the condition. So that's the speciality of do while loop. You want it to execute your code at least once. So that's why first time it won't check for the condition. Okay, and after that it's same as it is as the while loop, right? So again, if I make it like 20 here, the output will be number 20. That's it, because it will execute it for the one time for sure. You can clearly see it prints 20, then it becomes 21, then it goes inside this condition 21 is smaller or equal to 5. No, that's false. So that's why it will stop after that. Okay, so that's a do while loop for you. Okay, so we have talked about for loop, while loop, do while loop, and the next category after the do while is the for each loop, which is actually used for iterating through arrays and the collections. I know that we have not discussed about arrays and collection, so we can ignore this for now. This is just a syntax and example of it, but we'll cover this later when we cover about the arrays and the collections part. But the important part is I want you to practice the for loop and the while loop, because these are most widely used. So you will see a lot of cases, examples even in the real life market projects where for loop, while loop are getting used, and you will use these also in your DSA related questions. So make sure you practice for both of these. You should know the syntax of these and you should know how these are executed. You should practice it. You can also take copy and pen and try to understand how things are working. When you write down various cases, you'll get more clarity, and I want that you do this because it is very highly used, the for loop and the while loop. Okay, so this was about the basics of loop in Java. So the basic summary: loops are used when you want some code snippet to repeat again and again until the condition is met, right? So instead of writing hello for 10 times, you'll just apply a loop in one line and then you'll write the code which you want to repeat, right? So it simplifies your process and you'll be able to write a lot more cleaner and good code using the loops, because you are not writing the same code again and again, right? Till now we have discussed about loops. Now let's talk about nested loops. Now what does nested loop mean? It means loop inside a loop. Okay, so inside one loop there is another loop. Let me show you an example through which you will get more clarity. Okay, so here is an example. Here you can see this is the first loop. We have used for loop here, and inside this I have written one more loop. So there is a loop inside a loop, which means nested loop. So there are a lot of applications of nested loop as well, which we will see later in this video. But talking about the output of this, let me run it for you so you can see the answer. Okay, so you can clearly see this has printed this as the output. Now how did it actually work? So it will start from here, initialize I with 1, then it will check for the condition I is smaller or equal to 3, which is true because 1 is smaller than 3. Then it will go inside this loop where it will initialize j equal to 1, and it will check whether j is smaller or equal to 3, which is true because 1 is smaller than 3. So it will simply print ij. So I was 1, j was 1. So hence it prints 1 1. Now after this it will not go here, it will go here because the inner loop will run first, right? So it will increment the value of j. So j will become 2 now, and again it will check whether j is smaller or equal to 3. Now 2 is smaller than 3, so condition is true. Again it prints this statement. So I was still 1, j is now 2, so it prints 1 2. Okay, then again it increments the value of j. J now becomes 3. It again checks like j is smaller or equal to 3, where 3 is equal to 3, so this is true, hence it prints this I is again 1, j is 3, so it prints 1 3. Okay, after this it again increments j, so j now becomes 4. It checks like 4 is smaller equal to 3, that is false, hence this loop will stop here. Once we are out of this loop, this statement will run. It will simply print a new line. So after this we have the new line, and now after this it will go here. It will increment the value of I. Now I will become 2 because I was 1. Now it becomes 2 and it again checks for this condition. 2 is smaller equal to 3, that is true. Then it goes again in this, and j will again initialize for 1, and then the complete loop will run again. So we will have 2 1, 2 2, 2 3. After that we'll come out of this loop and again a new line is printed. Then it will come here again. I will become 3. It will check whether 3 is smaller equal to 3, which is true. Hence again this loop runs. So 3 1, 3 2, 3 3, and after this we print a new line, and then again it will increment I. So I will become 4 and this condition will become false. So we come out of this loop. Okay, so this is how this output came, and this is an example of nested loop. So loop inside a loop, and we can have multiple nested loops. So we can also have loop 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 loop, so you can have multiple nested loops. Now that we have learned about loops, let's solve a problem. Okay, so you have to calculate the sum of numbers from 1 to 5 using the loops. So what you need to do is like 1 plus 2 plus 3 plus 4 plus 5, but you have to do this using the loop. Why? Because in an interview you might be asked to calculate the sum of n numbers. I said 5 here, but they can give you n as an input. So you can't do 1 plus 2 plus 3 plus 4 plus, because you don't know till where n will go, right? So in this example, we will solve how to calculate the sum from 1 to 5 using the loops. Okay, so first I'll create a variable sum and initialize it with 0. So I'll use the for loop here. For int I equal to 1, I smaller equal to 5, I plus plus. What I'll do is like sum equal to sum plus I. So in the beginning sum was 0. After first iteration it will become 0 plus 1. So it will become 1. Second time it will become 1 plus 2. Okay. And similarly it will find the sum till 5. Okay. And finally what I'll do is system.out.println sum. So I'll simply print the sum. Let's see what the output is. So the output is 15, and let's also calculate what the actual sum should be. It should be 1 plus 2 plus 3 plus 4 plus 5, which is equal to 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15. So answer is actually 15, which matches this, right? So in this way you can write any logic. All right, now let's next move to break, continue and return. Now when we talked about the loops, right, we understood that when the condition becomes false you come out of the loop. But what if I want to come out of a loop at a particular condition? Like this condition is fine, but when I am executing my code or logic, if some condition appears, I want to come out of a loop. Say for example you are given two conditions. First, you have to calculate the sum of numbers till 5. The second condition is whenever you reach at number 3 you have to stop. So we have this condition already applied that we need to calculate till 5, and we may not know the entry or the starting point. So we don't know whether we will start before 3 or after 3, but we know that if we reach to 3 we need to stop at there. So we can apply a condition in our code, something like if I equal to 3, then I need to stop this loop. So for that what I can use is a break. The good part is the meaning is quite similar to the English language. Whenever you are driving a car, when you apply brake, your car stops, right? In a similar way, when you run break, you will come out of the loop. So in this case, what will happen is you will start with I equal to 1. It will simply check for this condition. 1 is smaller than 5. So this is true. It goes inside. It will check if I is equal to 3, which is not, because I is equal to 1. So this part will not run. We will do sum equal to sum plus I. So sum in beginning was 0. So 0 plus 1, so sum becomes 1. After this I will become 2. It will again check if I is smaller equal to 5, which is true. It will again check this condition, which is false, because I is 2 and 2 is not equal to 3. So we will do sum equal to sum plus I. So sum was 1, so 1 plus 2, so sum becomes 3. After this I increments again, so I becomes 3. It will again check for this condition, which is true. Now it will again check for this one. Now this is also true, because 3 is equal to 3, so it will break. So this will not run, and after this it will not go to the increment, decrement or the loop conditions. Break will simply make you out of the loop, so you directly come here. Okay, so let's see the output. Clearly you can see it says 3, because sum became 1 plus 2, which is 3, and when the I became 3, we simply applied the break statement, and which made us out of the loop. So whenever you apply the break statement, whenever the break statement runs, you come out of the loop. So when you want to take early exit from the loop, then you can apply break. Why did I say early exit? Because the complete exit will happen when this condition becomes false. But you can see currently this condition was true, because I was 3, which is smaller equal to 5. But in the code part we use the break statement, and whenever break statement runs, it gives you early exit, right? So basically break will give you early exit. Okay, so whenever you want to come out of the loop early, so you can use break, right? After break, let's see one more fundamental, which is continue. Now continue is used if you want to skip a particular thing. Let's go back to the example and we'll see with the code. Okay, so I'll remove the break here. Now just imagine you have to calculate the sum of numbers from 1 to 5. Okay, but you don't want to include 3 in it. You want to do 1 plus 2 plus 4 plus 5. So you want to skip a particular thing, right? In this case I want to skip 3, but I don't want to come out of the loop. I want the loop to keep on running, but just for the particular case I don't want the execution inside the loop, right? So for that I'll use continue. So what will happen is the loop will start with I equal to 1. It will check for this condition, which is true. It will check for this condition, which is false, because I is 1. It will simply do sum equal to sum plus I, so sum will become 1, right? After that we'll do I plus plus, so I will become 2, and then it will check whether I is smaller equal to 5, which is true. Again it checks for this condition, which is false, because I is 2. Then again it will do sum equal to sum plus I, so sum will become 1 plus 2, that is 3, right? Next it goes there, I will become 3 now. It will again check for the condition, which is true, so we go inside the code. It will again check for this condition, and this time this condition is true, and we have written continue here. What continue means is that you skip this particular iteration. Okay, so for this part we will not execute the code, we will simply go here. Okay, so we did not do sum equal to sum plus 3, we skipped that for this particular iteration, and then I plus plus will happen, so I will become 4, and again it will check for the condition, which is true. This condition will be checked, this is false now, because I is 4 and it is not equal to 3. So this will again happen, sum equal to sum plus I, which means sum equal to 3 plus 4, which means 7. Now again I plus plus will happen, so I will become 5. It will check for this condition, which is true. It will check for this condition, which is false, and hence again sum equal to sum plus I, so sum becomes 7 plus 5, that is 12, right? And after that we do I plus plus, which makes I as 6. So this condition is false now, so we come out of the loop. So it should print 12. Let's see what does it print. Clearly you can see the output is 12. Why 12? Because it did 1 plus 2 plus 4 plus 5. It skipped 3 in that part, because for I equal to 3 we have applied continue. So basically continue is used to skip an iteration. With continue we are not stopping the loop. We stopped the loop using the break statement. With continue, we just skipped the particular iteration and the loop kept on running, right? So here for continue, I'll say skip an iteration, okay? But the loop keeps on running. That's the main part. The loop stopped with the break statement, okay? So this is a difference between break and continue. When the break statement runs, you are out of the loop. When the continue runs, that particular iteration is just skipped, but the loop keeps on running. Now before going to return, let me go back to break again. Now the break statement is not just limited to the loops. You remember we used break in the switch as well, and we said like we will come to it later. Now it's the time we'll discuss about that case as well. So here you can see this is an example of switch. We have used a variable day which is of type integer and its value is 2. And corresponding to this we have defined the cases. Case 1 is representing Monday, case 2 is representing Tuesday, and default is representing any other day. So in this example, because the value is 2, it will first check for the case 1. It does not match because 1 is not equal to 2, right? So it goes here to the case 2. It matches, 2 is equal to 2, so it prints Tuesday. But as I told you, in case of switch, if there is a match, it prints everything which comes after it. So it will print Tuesday, and after that it will also print other day. Let me show you the output. Clearly you can see it prints Tuesday, other day. So whenever we get a match, it prints that, and after that it will also execute anything which comes after it. So this is also gets executed. But say we want to stop this, we just want to print the thing which matches the case, then we can use break. So I'll apply break here and also here. So what break will do is like it will stop it there. Now when you get a match here at 2, it will print Tuesday and it will stop the execution of switch. Okay, so other day won't get printed. Let me show it to you. Here you can clearly see the answer is Tuesday only. It doesn't print other day. So this is the power of break. Now let's see an example of break in the nested loop. So here you can see we have the nested loop, first loop, and inside that we have the second loop, and you can see inside the nested loop we have used the break statement. Now it's a good tricky situation to understand what break will do. Will it make us outside both of the loops, or will it make us out of this nested loop, or will it make us out of this major loop, right? So the answer is whenever the break statement runs, it basically makes you out of the most inner loop or the nested loop. So because this break is part of this loop, it will make you out of this loop, not this one, okay? Because break is part of this nested loop, right? So it will make you out of this one only. So let me tell you the execution. We'll start with I equal to 1. We'll check this condition which is true, right? So then it will go in the nested loop. So it will initialize j with 1. It will check for this condition which is true. So it goes here. This is false because I and j both are 1 1, and this condition is false. So this logic doesn't run. So it will simply print ij which is 1 1. Okay, so let me write it here. It will print 1 1. Okay, and because it's a print ln, so next line. So after this, because we are in the nested loop, now j plus plus will happen. So it will make j to 2, and this condition will be checked, and this is true because 2 is smaller than 3. And then this condition runs here. This condition is true because now j is 2, but this condition is false because I is still 1. So this will still not run because we have used the AND operator here. So again we will print ij, which will be 1 2, and again j will become 3 with this. We'll check for this condition which is true. So we go inside this loop, and this will be checked. This is false now because I is 1 and j is 3. So it again prints this, and it will print 1 3, right? After this again j plus plus will happen, so j will become 4, but this condition now will become false. So this execution will stop. Now what will happen is we will go here to the outer loop. Now I will become 2 now because it started with 1 and we are doing I plus plus. So I becomes 2, and we will check this condition. This is still valid true, so we go inside this. So again j will start with 1. This condition is true. We will check for this part. This is false because I is 2 but j is 1. So this will not run. So this will run, and in this what it will print? It will print 2 1 because I is now 2, j is 1. Okay, after this j plus plus will happen. Now j will become 2. This condition is true. It goes here and this becomes true now because I is 2 and j is 2. When this happens, break is applied. So we come out of this loop. Okay, this loop we are out of because this break is part of this loop. So the innermost loop of which break is part of, we will get out of that particular loop. We are not out of the outer loop yet. We are just out of this nested loop. Okay, so 2 2 will not get printed because we have applied the break. So what will happen after that? I plus plus, because the outer loop is still running. So I will now become 3. This condition is true, and again it will run the nested loop for I equal to 3. So all the cases will run, and this condition will always be false now because I is 3. Okay, so it will simply print 3 1 3 2 3 3. So this should be the output. Let's run it and see what's the output. All right, you can clearly see it says 1 1 1 2 1 3 2 1 3 1 3 2 3 3, right? So it matches our output. And the major thing that you should remember from here is when you apply the break in the nested loop, it will make you out of the innermost or the most nested loop, or inside which the break was present. It will make you out of that particular loop only, not from the outer loops, right? So this was the usage of break in the nested loops. So similar is the case for continue. When you use the continue statement, it will happen to the innermost or the most nested loop, or the loop inside which the continue is present. Okay, so similar to break that we saw, same would be for the continue in the nested loops. You can try that on your code and you'll get more understanding based on that. Right now, after this, the next one is return. As the name says, when you use the return, it will make you out of the method. So to take an early exit from the method, you can simply use the return. There can be a condition, like for example, you are writing some logic in that you see like if this condition match, you get out of the method, you just end this method. Okay, so in such scenarios you will use the return. And return is also used when you want to return some value from the method. Like for example, if I create a new method here, it can be public int. When I am saying int, this is the return type. If there is no return type, then there is void. Okay, so I am giving the return type here int, and I'm just giving the name of the method as method. And what I'm going to do is like I'll do return 2, right? So it is returning some value. So using the return statement, you can return some value from the method, but we also need to define that in the method declaration that this method is going to return some value. Okay, and apart from that also, return can simply be also used to come out of the method. Say for example, this method doesn't return anything, so we will say void, and you will remove 2 here. So you can have any logic here, say for example system dot out dot println method, right? And I'll say if you can have a variable here int j equal to 0, I can say if j equal to 3, then return. Okay, in that case I am returning. Otherwise I can do some more work here. Okay, so in case j is equal to 3, then we will simply return of this out of this method, and this statement will not run. Okay, so if you want to get out of the method, exit the method, you can use the return. And return can also be used to return a value from the method, right? Don't worry about it, because return we are going to use a lot later in this video. So we will see many more examples for the return. So if I show you the difference between the three things that we just discussed, break, continue, return. Break will make the exit from the current loop or also from the switch statement. right? It is used in loops and switch. We saw the example of both of these, correct? So if you want to take an early exit, then you can use the break. Now after that we have the continue. It will just skip the current iteration. So we saw the example, we were going for I from 1 to 5. Okay, so you have 1 2 3 4 5. Just in the case of I equal to 3, we just wanted to skip the iteration, so we use continue for this. So it will just skip the current iteration, but the loop will not stop. Okay, also in English we say continue, so the loop will continue, just the current iteration will not work, but the loop will continue, right? And then we have the return statement. This exits from the current method. So if you want to take exit from the method or optionally return a value from the method, then you can use the return. So it is used in the methods, right? So break you will use in loops and switch statements. Continue you will use in loops. Return you will use in methods. So as you code more, you will get more clarity about using break, continue, return, because in many DSA problems you will use all these statements and you'll get more understanding of it. Okay, so can the break or continue be used outside the loops or switches? No, break is for loops and switch, continue is for loops only. So let's see some of the common questions. Can break be used outside a loop or switch? No, break can be used inside a loop or a switch. Can continue be used in a switch? No. Break can be used in a switch. We saw an example of it, but continue is not for switch. Continue can be used only inside the loops. Can return be used inside a loop? Yes, but it will exit the entire method, not just the loop, because we mentioned return is to exit out of the method. Okay, so wherever you use it, you'll come out of the method directly. What is the difference between break and return? Break will exit a loop, whereas return will exit the method. Now can loops be labeled? What does this mean? So as I told you, there can be nested loops, and if you use the break or continue statement, it will make you out of the nested loop or the innermost loop, right? But if you want to come out of the outer loop, then you can give the labels to the loops. So say for example, you can give the label as outer to the outer loop, and then you can use break space outer and then semicolon. That will make you out of the outer loop. You can try that, but it is not that important. This would be very rarely kind of used, so in case it creates a confusion, you can ignore that part also. Okay, so if you simply apply the break or continue, that will be applicable to the innermost. Okay, that is by default. All right, so this was about the loops, break, continue, return. Next we will talk about object oriented programming, which is the specialty of Java. Now let's discuss about object oriented programming in Java. Now of course the first question is, what is object oriented programming? It basically means that overall all the code revolves around objects in Java. You can imagine object as a unit that bundles variables and methods. For variables, the real life terminology can be said as like data or attributes, whereas for methods, the real life analogy can be behavior. So object is a unit that bundles variables and methods. So here are the real life examples. First we will talk about the object in real life terms, then the variables or you can say attributes, then the methods or the behaviors. So let's take an example of a car. So car is acting as an object. Now some of the attributes of car object can be its color, its brand, its speed. And some of the methods or the behaviors related to car can be start the car, stop the car, accelerate the car. Another real life example of object can be dog. So dog has attributes like name, breed, age, and some of the behaviors related to dog are bark, eat, sleep. Now Java allows us to create these objects using classes. We earlier saw an example of class, right? So in Java everything revolves around classes and the objects. We earlier saw examples of variables and methods, so these will be part of classes and objects. So now let's discuss more about class and object. Okay, so class is basically a blueprint or template for creating the objects, whereas object is an instance of a class. It is the actual thing built from the blueprint. So think class as a blueprint, whereas object is the actual thing built from the blueprint. Don't worry about the theory part. I'll show you an example through which you will get more clarity. Okay, so this is an example of class. We have already built a few classes in IntelliJ, right? So but here the main part is, so it contains the keyword class and then the name of the class, and then it contains two things, variables and the methods. Enough of theory, let's move to IntelliJ and let's see a practical example through which you'll get more clarity. Here we go. So first of all, you can see we have used the keyword class, so we are creating a new class, after which I have given the class name as car. Now this is the opening bracket, and inside this opening and closing bracket we will write some code which will contain like the variables or the attributes and the methods, which is the behavior of this class, right? So let's first talk about the variables or the fields or the attributes. You can see here we have created two variables here. We haven't initialized these variables yet, we have just declared. So first variable name is color and its data type is string. We haven't discussed string in detail yet, but string is something which will contain text. Like char data type contains only one character, whereas string can contain text, like something like this, the car is driving, right? Like this is complete text, you can write multiple characters in it. So string can contain one or more than one characters. Next variable is named as speed and its data type is int. It means that speed will contain integer value, right? So these are two variables which are part of class car. Then let's talk about the method or behavior. You can see we have written a method here. We have not defined anything like public, private here. So Java has a default type which is automatically used if you don't define. Don't worry about it, we will discuss about it later, but I thought I'll tell you because you might have confusion like why did not we use public here, right? So you can skip that as well, that's optional. After that we have written void, which means that this method will not return anything. After that we have written the method name, which is drive. And how do we know this is a method? Because of these, like after the name of the method we have these brackets, right? Inside these brackets you can also give some parameter which can be required in the method, but here in this method we have not provided any parameter because parameters are optional, right? Next, this is the opening bracket of this method. So the code of this method will go inside the opening and the closing bracket. So inside the method we have written code statement like we have printed the car is driving at, and then we have used the variable here, right? The speed is the variable name, so we have used the variable here, right? So this was the class. Basically class gives you the template or the blueprint. Like for example, you might have seen when they are trying to sell the flats in the society, which is yet to be built, right? The flats are not built yet, but they want to sell, the builders want to sell the flats of the society, so they create a blueprint or the template, like this is how the flat will look like, right? Like for a 3 BHK flat, there will be 3 rooms, there will be kitchen, there will be 3 washrooms, and here you will have your first room, here you will have second room, here you will have third room, this will be the kitchen, this will be the lobby area. All these things they tell you like via creating map, or they show you some structure like this is how the flat is going to look like, but it's not the actual flat, right? So in the similar way, this blueprint or template is acting as a class. So it basically tells you like it has some variables, methods similar to this, like it says like it will have 3 rooms, 3 washrooms, 1 kitchen, 1 lobby area. So this is acting as a class, it is just telling you, but it's not the actual end product that will get built later is your flat, which is actually the object, right? So let's see technically an example of object as well. Okay, so here now you see this is our main class, right? Inside this we have this method main, which I told you, which is a must thing for a Java application because this is the first thing that runs, right? It gets automatically run when you run the program, right? So if I click on run button, this main method will get run automatically. Okay, so inside this main method what we have done is like we have written car, which is the class name, and then I have given some name you can give any name here. So here you can see I have created an object. Okay, this is the way you create an object. How do you know that this is an object? Using the new keyword. Whenever you use the new keyword, it shows you are creating an object. Okay, so what is the way of doing this? First of all, you write the class name. The class name was car, so I wrote car here. Then you give your object name. You can give any object name. For example, I wrote here my car. You can give anything else. You can also write object, or you can write something like car object, or anything that you want to write, that will be the object name. Okay, after that you have the assignment operator. Then you write the new keyword. I'll tell you what this means, but for now let's go ahead. Then you write the class name again. So we wrote car here, now again we are writing car here, but after that we are giving two brackets here, right? So this is the way you basically create an object of the class. So as I told you earlier, object is basically the actual representation. Class is simply the blueprint. This is the actual thing. Okay, now see what we are going to do. We are doing object name, which we created, dot color. So this has all the attributes and the behaviors which were represented in the class, because this is acting as your actual car, or like the flat example I said. So this is the actual flat, so it will contain 3 rooms, right? So everything which was represented in the template or the blueprint will be actually present now. So you can use that. So you can write object name dot color, so you can directly use the variable or the attributes or the fields, and you can assign some value. You can clearly see we have done my car dot color equal to red. So we have assigned a value to the variable, and this is specific to this particular object that we have created. Because in a society, like, there can be like 50 flats out there. When you are setting a property, a behavior, you are setting it for your particular flat that you have created or which you bought, right? It's not like if you are setting it for your flat, it will automatically set for some other flat as well. No, it is happening for the flat you purchased or the object you created. So you are setting this value to color variable specific to your object. Okay, and then you are setting another variable which is speed, right? And you are setting the value as 120. So color of your car is red and the speed of your car is 120. Then further what you are doing is like you are calling method of your car. So you have said like my car dot drive. So this will call this method and it will execute it. So inside that we have printed something. So it will print the car is driving at, then it will use the variable, and for our object we have set the speed to 120. So it will say the car is driving at 120 kilometer per hour. Okay, so let me show you what is the actual output. You can clearly say it says the car is driving at 120 kilometer per hour. Why 120? Because we have set the variable's value for our object. Now coming back to this line, so basically when creating the object, first you write the class name, which is car here, then you tell your object name, then you do the assignment operator, then further this thing, basically by doing this using the new keyword, you are allocating the memory in the heap. What is heap? Don't worry about that for now. In short, you can remember heap is something where you assign the memory at runtime. Okay, so using the new keyword, you are allocating space or memory in the heap. Okay, so basically first you write new keyword, then the name of the class, and then this brackets. Inside this bracket also you can have some parameters, but the default one is this. Okay, those parameters are optional. So this is the way you create object of a class. Now this my car is the object name. This is a reference through which you can use your object. Like for example, you can see I have written further my car dot color. So through this object name you can use the object. You can use its attributes, its behavior, everything. You can call the methods using this object name. Now what does this actually mean? I told you new is a keyword to allocate the memory in runtime storage, which is heap, right? But what is this actually? We have written the class name and then we have given the brackets. Actually this concept is called as constructor. Okay, let me write here constructor. constructor. So this is actually constructor, which is used to initialize the object. We are creating object here, right? So this is to initialize your object. For example, you have set the values in your object, right? You have set the values of the variables, so you are doing the initialization here, but you can do the initialization in the constructor as well. When you don't pass anything in these brackets, that is the default kind of implementation where nothing is happening, it is just giving you these like variables, not defining any value of those. Okay, but there is also a way where you can initialize the value of the variables. I'll show you an example of that, but before that let's go to the theory part once more so that you get more clarity, right? So here we go. We saw this case, right, where we created an object. I wrote first of all the class name, then the object name, then assignment operator, then the new keyword, and then this part which is the constructor. So this is how you create an object. So here car, this one represents the class, which is the template or the blueprint. Then this new car, this part, this basically creates an object in the heap memory. I told you heap memory, right? Which is the runtime kind of memory, you can say. And my car, this one, is the reference variable in the stack that points to the object. So this is the object name, class name, object name, assignment, new, and then constructor. Okay, this is how you create an object. Now I told you this is the constructor. What is a constructor? Constructor is a special method. Why it says method? Because you can see we have these bracket after this. So whenever after the name there is something like this, we said that we can treat it as the method. But constructor is a special method, not like any other method. It is used to initialize the objects. We have created the object here, so the constructor is initializing the object. But we said that it's a special method. What's so special about it? It has few special properties. First, its name is same as the class. You know, here the class name was car. So the constructor name is also car. Or you can say the method name is also car, right? That's why we said it's a special method. Its name is same as the class name. Another important thing about this special method, which is constructor, is it has no return type, so it cannot return anything. And one more special thing about constructor is that it gets automatically called when an object is created. So we created the object here, right? So the constructor will get called. So whatever is present in this constructor, that will be called. Now you may ask, like, here we did not create any constructor, right? We did not create a method name which is same as the class name, right? We did not do it. So how will it get called? So the point is, Java has by default the default constructor. So even if you don't write the logic, it has its automatic default constructor. Okay, so that gets called, but you can also create the constructor. Let me show you how. Okay, let me create the constructor here. So let us write first of all public. Now we know for method we have to write the return type and then the method name, but constructor is a special method, right, which has no return type. So we won't write any return type, we'll simply write the method name. Now another point, constructor is a special method which has same name as a class. Okay, so although the method name start with like small character, but constructor, it has same name as class, so we'll write car. Okay, and then because after method name we have to write this, so we do this. Okay, and after this we have the opening bracket. Let me print something into it. System dot out dot println. This is the constructor. Okay, so this is the actual code. Now inside the car class we have this method, we have these properties, and this is the constructor. Let me write it down here, constructor. Okay, and from the main method we are creating the object, and we said that when we create an object, the constructor gets automatically called when the object is created. So let's see what happens when I run this code. Let's click on the run button. Let's see what happens. Okay, you can see here it has printed two things. First, this is the constructor, and after that the car is driving at 120 km per hour. See the magic here, right? Before printing this, it has printed this. But how come? We simply said car, my car equal to new car, then we set the properties value or the variables value, and then we called this method drive, and inside that method drive we have printed this statement. But how come this is getting called? This is getting called because we said the constructor is automatically called when an object is created. So the object was created at this point, right? We did like car, my car equal to new car. So at this point we have created an object, and that's why it will automatically call the constructor. So this is a constructor, so whatever logic you have written inside the constructor, that will be called. So we wrote this statement inside the constructor, and hence it is getting called here. You can see this is the constructor is getting printed. After this we have called the method drive, which has some logic, so this will get executed. So first it has printed whatever was present inside the constructor, and then whatever method we have called, that logic is getting executed, right? So this was the constructor. But now there is another point. Constructor can be of multiple types. Okay, so let's see and try to understand what are the types of constructor, right? So here we go, types of constructors. First type is the default type, which has no parameters. So this one which we have created, you can see it has no parameters inside these brackets. So this is acting as default constructor. Okay, so this is default constructor. You can clearly see default constructor means it has no parameters. So it has a wonderful property that it is added automatically if not defined. So in case you have not defined this, Java by default has the default constructor, but there is nothing inside that constructor. So when we created the object and when we did not write any logic for the default constructor by Java was executed, and there was nothing, so it did not print anything. But we can write the default constructor and give the implementation, which we did here, right? So if you don't write the default constructor, by default the Java's implementation of default constructor will get run. Okay, so same thing we mentioned here, added automatically if not defined by you. So this is an example. Say the class name was student, so we have created a default constructor here. The name of constructor will be same as the class name. So class name was student, so the constructor name is also student, and then it has no parameter inside it. So this is the type of default constructor. Next type of constructor is parameterized constructor. It means it takes arguments to initialize the values. So in the default constructor there was no parameter, but in the parameterized constructor there will be parameters. Okay, example, the class name was student, so the constructor name is also student, but now you can see it is taking parameters. Now what is the use of these parameters? You can basically initialize the value of the variables of that object through the constructor itself. For example, this was the class, you created object of this class, it had the variables like color and speed. You can see here you created the object, then you were initializing the variables of the object, right? Instead of doing this, you can do this directly from the parameterized constructor. Here this was the default constructor, but you can create the parameterized constructor and pass the values directly, through which the constructor can initialize the variables or the attributes. I'll show you an example, but let's go back to the theory first. Okay, so this is parameterized constructor, which is the second type. Now the third type of the constructor is copy constructor. It basically copies data from another object. An example is student. So you can see we have passed the reference of another object inside this. So this is example of copy constructor, where it will try to copy the data from another object. These two, default and parameterized, are highly used, so focus on these two constructor types. Okay, default we have already seen. If we don't give the implementation, by default the Java implementation will happen, which is like nothing inside it. Okay, but you can define the implementation in the default constructor, just like we did it here. You can write any code inside this. Okay, now after that, let's see an example of parameterized constructor. So here this was the default constructor. Now let's write parameterized constructor. So first we write public, then car, because the constructor name will be same as the class name, then this, but this is the parameterized constructor. So inside this we will give a parameter. Say for example, I am writing int speed parameter. Okay, so I'm passing the speed parameter inside this. Now it's not necessary that if there are two variables it must contain all of the variables. It can contain one, it can contain two, it can contain all. It totally depends. You can define multiple parameterized constructors. I'll show you. Okay, so inside this what I can do is, like, I can initialize the variables. So I can do speed equal to speed parameter. Okay, so we have initialized this variable with this parameter value which we are getting, right? So let me zoom it out a bit. So we said that the constructor will be called automatically when you create an object. So we created an object here. So which constructor will get called here? This is the default constructor, this is the parameterized constructor. Let's see. So we have run this here and you can see it has run the default constructor. Let me also try to print something inside the parameterized constructor so that you get more clarity. So I am printing, this is the parameterized constructor, and in the first one let's write this is the default constructor. Okay, so inside this you'll get this statement printed, and inside this one. So let's rerun and see. Right, you can see it says this is a default constructor. So clearly when you basically create an object, by default the default constructor gets called automatically, not the parameterized one. And that makes sense, right? Because you called here the default constructor, you did not pass any value inside it. What if I pass value inside it? Say I pass 140. So there is no compile error right now because I created this parameterized constructor, right, which is taking this parameter of type integer, right? So this is allowed. Now let's try to run this program. You can see now this is calling the parameterized constructor. This is not calling the default constructor now. Why? Because while creating the object I have called the parameterized constructor. I have passed a parameter. So this is getting called, this one, and this is not getting called because it does not contain any parameter and I have called with the parameter, right? But you can see it is still printing 120 as the value. I initialized it by 140, right? Because I passed it and I set the value of speed to 140, but it is still printing 120. Why? Because we are setting here 120 later on. So let me comment this out. Okay, now let's rerun this and see what happens. Alright, you can clearly see it has called the parameterized constructor and it says the car is driving at 140 km per hour. Now it has used the value with which we have initialized, right? So basically the parameterized constructor you can use to initialize your variables or any other logic also. If you want to provide through this, you can do. As I told you earlier, you can create multiple parameterized constructors. So here, like for example, I created for just one of the parameters. You can create for color as well, or you can also create which combines both of these. So it's totally up to you. So let me create one more parameterized constructor. The name will be car only, but now it will contain both of the variables. String color name is the first parameter that I'm passing. The second one, let me say speed param. Okay, so this is the parameter name. You can write anything which makes sense for you. Okay, so inside this I'm going to print first of all something, system.out.println. Hooray. Okay, so I'm writing anything here. So I'll initialize both of the variables inside this. We have the color and the speed, so I'll do color equal to color name, right? And I'll say speed equal to speed param. Okay, so here we have initialized both of these, but currently this is not getting called. Why? Because here I am calling with one value, so this was getting called. Now let me do something like passing the both parameters, yellow and this. Okay, yellow and 1, let's do 150, right? All right, so we have commented these because we don't need to initialize those like this. Now we have initialized directly in the constructor using the parameterized constructor, right? I've passed for both of the variables here, and then I've simply called the method of this object. So let's try to rerun and see the output now. Okay, you can clearly see this is printing hooray now. So this constructor is getting called, this both of these, this one and this one, so the default one and the parameterized with one parameter, both of these are not getting called. This one is getting called, which has both the parameters. Why? Because we have passed both of the parameters while creating the object. So it depends like how you are creating your object. When I was not passing any of the parameter, the default one was getting called. When I passed one value, this one was getting called, and when I passed both of the values, this is getting called. And one more thing, when you are passing the values, it also checks for the data type. Now instead of this, if I do 150 and yellow, it will cause issue, right? I'll show you, but before that we can see we have passed the values yellow and 150, and then I have called this method drive, which is basically using the speed parameter, and you can see it is picking the value which we passed. Why? Because we have initialized the value like this, right? And the other thing that I was saying, it checks for the data type. So if I do something like 160 yellow and 150, of course this won't work because now you're passing three parameters, and it says it cannot resolve constructor which has three parameters, right? So let me remove the last one. Even this will give you the compile error. Why? We have this one which has two parameters, right? But the data type is different. You're passing integer, it wants string because you have said string here, and then further you are passing string but it wants integer. So it's important that you pass the right data type as well. So let me change it again so that it works properly. First type is string, so I've made string here, and then we have the 160. So if I run this now, it will work. It will say now you're driving at 160 kilometer per hour. Slow down, man, slow down. Okay, all right, so this was example of the parameterized constructor, right? We saw example of the default constructor and the parameterized constructor. Next, let's discuss about the access modifiers in Java. So in the code you might have seen we have written like public is also mentioned before the class, also before the method, also before the constructor, and we can also define it before the variable as well. So what is this? This is basically access modifier. What is an access modifier? They basically control visibility. Now they can be used with classes, variables and methods. So we have seen multiple examples of public modifier. Basically now we will see all the different types of modifiers which are available in Java, and we will see their scope. So when we talk about public access modifier, they are accessible from anywhere. As the name suggests, public, so it is available from anywhere. This is one example where we have used the access modifier with the variable. So we have written public int age. Here age is the variable name, int is the data type, and public is the access modifier. This means this variable can be accessed publicly. Next type of access modifier is private. As the name suggests, it is accessible only within the same class. So say for example you have two classes, class 1 and class 2. If class 1 has a private variable, it cannot be used from class 2, right? Let me show you this with an example. Here we saw we had two classes. First is the class car and the second is the class main, right? You can see here we have used this variable color. We did not define any access modifier for this variable color. We'll talk about that later. But even if I put public here, we can access it because public means it can be used or accessed from anywhere. So that's why this is still valid. Now, but if I make it private, then we cannot use this variable from another class. As the name suggests, private means you can use this variable only within this class. You can't use this from any other class. So here when I'm trying to use color, it is giving me compile time error. It says color has private access in car. So it is very clear, if the access modifier is private, you cannot use it outside the class. It can be used only within the same class. Example is just like we saw, we have made private string name. So this is the variable name, this is the data type, and this is the access modifier. So name can be used only within the class. Next access modifier is protected, which means it can be used within the package or subclasses. Now we haven't discussed about the subclasses yet, so you can ignore it for now, but you know the package concept, right? So it can be used within the same package, that is allowed. Example is protected void show. So we have used here the access modifier with the method. So this is example related to method. These are examples related to variables. So let me show you in code related to protected as well. So here if I make this color instead of private to protected, you can see for private we were not able to access it. So now let's see if we can use it or not. You can clearly see we can use color now. Why? Because it comes in the same package. Both this classes, the class car and the class main, are part of the same package. So because they are part of the same package, protected can be used even in a different class because the package name is same, right? So there is one more condition when we talk about using the protected. Apart from the package, we can also use it when they are subclasses, which means one class extends another class. Don't worry about that part because we have not discussed. That will come when we discuss the concept of inheritance. So even in that case, protected is allowed. Okay, apart from these three, we have one more access modifier in Java, which is default. Now you know, for public, private, protected, you need to write these keywords. Like you have to write public, you need to write private, you need to write protected. You can clearly see in these examples. But when we say default, you don't need to write anything. So simply if you write int marks, where int is the data type, marks is the variable name, then by default it comes into default access modifier in Java. So by default Java assigns default access modifier. You don't need to write keyword default. It automatically assigns default access modifier if you have not written any other. And its scope is that it can be used within the same package. So here if I remove this protected, by default this color comes with the access modifier default, and you can use this from another class. Here you can see we have used it and it works because both of these classes are in the same package. So now the difference between default and protected is that both can be used in the same package, which is same, but protected can also be used in the subclasses concept, which is when we use inheritance. So if a class extend another class, it can use the protected variables or methods of the parent class. So we will cover that when we cover inheritance. But yeah, so these are the various modifiers which are available in Java. Alright, so after this, now let's talk about 4 pillars of object oriented programming. So we discussed that Java is an object oriented programming. Everything revolves around objects and classes in Java. So now let's try to understand the 4 pillars of object oriented programming. These are really important, widely used, and there are a lot of interview questions that are asked on these 4 topics. So first of all, let's see 4 pillars related to object oriented programming, and then we will talk about each of these in detail. So the first one is encapsulation. So in order to explain encapsulation in easy terms, you might have seen a capsule, right? Inside capsule we have a medicine, right? And generally you take the complete capsule directly with water. You don't break it and take out the medicine, right? You take the complete capsule. So this capsule basically acts as a safety unit, the security, you can say, through which the medicine remains safe, because it would be very difficult to take all those small granules of the medicines without that capsule. So with that capsule, everything remains intact and safe and secure, and you don't have to care about various granules, right, of medicine. You can simply see one single unit, which makes things quite easy, right? So now if we talk about the technical terms, these medicine related granules are basically the variables and the methods, okay? And this capsule is basically a class. So as the capsule acting as a single unit, so like the capsule class binds the variables and methods into a single unit. For example, you can clearly see we made a class here named as car. It has variables, it has method. So this is encapsulation because this class car is making these complete, like the variables and the methods as a single unit. So the next pillar is inheritance. Basically, let's assume there is a class which has some variables and methods. Now we want to have another class which will have these variables and methods, and apart from this class will also have some more variables or methods. So instead of writing this same code in a different class, what we can do is like inherit these from this class. So basically this class will extend this class. So say this class name is A and this class name is B. So class B will extend. Okay, we will write the keyword extends and it will write A. So B class is extending A class, and hence B class can reuse the code like the variables and the methods of class A. One example from which you will get more idea is like we have animal class which has like default properties related to animal. Okay, and then there is a class dog which is of type animal, so it will have the properties and methods related to animal, so it will simply extend the animal class. So you can clearly see class dog extends animal. So dog class will by default have the properties and the methods of animal, and apart from that dog class can add more variables or methods which are specific to dog class. So inheritance is a great way of reusing the code by driving a class from another. The next pillar is polymorphism. It means that we are using the same name but it has various multiple different forms. It has two types like method overloading and overriding, which we will discuss in detail later. But one example can be here, you can clearly see there are two methods which are having same name. So the method name is area for both, but you can clearly see both are having different parameters. One is of type int, other is of type double, or you can also say there can be another method which is of type string, right? So their name is same but their form is different. Okay, so polymorphism is you are using same names but doing different work from each of them. And last one is abstraction. Now abstraction simply means that you are hiding the complex details and showing only essential ones. So let's try to understand abstraction in very simple terms. Say we have a car, okay, and there is a brake in that. Now every customer knows when you press the brake, the car will stop. So that kind of information is exposed to the end user that this is a functionality. But we don't know how the brake works internally, right? What all things happen internally, we don't know and we don't need to know, right? We just want the functionality as an end user. Similarly at home, say you have your switch and the tube light. So you know when you press the button on, the tube light will turn on, and when you press the button off, the tube light will go off, right? You know that functionality, but you don't know the internal functionality, how things are working, all the wire setup, how the wire is going, and all that complex detail you don't know, and you don't even need to know as an end user about that, because that is a complex part and you don't care about it, you just care about the end functionality, right? So similarly abstraction is you are providing the end functionality but you are hiding the complex details. Okay, so in technical terms abstraction can be there using abstract class or interface. We'll talk in detail about both of these later in this video, but these are the four core pillars of object oriented programming: encapsulation, inheritance, polymorphism, and abstraction. Now let's first discuss about encapsulation in detail. We talked about the capsule example, right? So it saves and securely keeps granules of the medicine, right? In the similar way, one of the core functionality of encapsulation is data hiding and the access control. So we checked about the access control, the access modifiers, right? For example, if you are using private access modifier, it won't be available from any other class. You can use that only within the class. In similar way, the role of encapsulation is data hiding and access control. So let me show you one example through code through which you will get more clarity. Okay, so here you can see we have a class bank account and it has a variable which has name balance and its type is double, so it can contain decimal values, right? And then we have a deposit method. Okay, and similarly we have another method which is get balance. Now you need to understand a very wonderful thing in this code. What we have done is like we have made this variable which is named as balance. In this example, for this variable name balance, we have kept the access modifier as private. It's not public, not protected, and not even default. It is private. So what it means is that this variable balance cannot be accessed or used outside this class. It can be used only within this class. So now that means if we have another class, say for example main, it cannot directly use this variable balance even after creating object of this class. Say for example we have created an object of bank account class here. We cannot use the balance variable directly. So you cannot do acc dot balance equal to 20.5. You can't do this because you cannot access the balance variable as it is private. So this is how your class is doing data hiding using the access controls, right? So this variable balance is not directly exposed to the external environment. Like a capsule, it is saving this internal medicine, right? So this cannot be accessed outside this class. Now another wonderful thing is, of course you need to make changes in it or get this value, right? So if we are making it private, how can we access it from outside environment or update it? We can do it using the getter and setter. Now what is getter and setter? This is a very standard protocol which you must know. Okay, it's a wonderful concept and I'll explain it to you now. So basically, as you see, we have made this variable as private, so it cannot be accessed directly from outside environment, right? But now we have provided getter and setter methods through which you can access its value and update its value. So from getter you will get the value of this variable. You can clearly see it is returning this variable from the getter method, and the getter method is public, so it can be accessed from outside this class. So here you can clearly see we have used the get balance method from another class because it was publicly accessible. Similarly, in the setter method, you can modify the value of this variable, right? This is also a public method. It takes the parameter in which you can give the input value and it will update the value. Here we have increased the balance with the whatever amount you are giving. So earlier say balance was 10 and if you give the new amount as 20, so we are making the balance as balance plus the new amount which is 20. So 10 plus 20, the balance becomes 30 now. So you are able to update that, and you can clearly see we have used this method, deposit method, which is acting as a setter, right? And we have modified the value of balance. So if I try to run this, you can clearly see what is the output. So earlier the balance had no value, so the default value of balance would be 0, right? And after that what we are doing is like we have used this method deposit, and inside that we have passed the value of 5000. So it means it will do balance equal to balance plus 5000. So balance initial value was 0, so 0 plus 5000 is 5000, so balance become 5000. And next we are trying to print the balance value using the getter method, right? So here you can see we have printed that, so it says balance and it takes the value of the balance variable which is now 5000, so it has printed that. Now one major question will come into your mind: if we can get the value and update the value of this variable, then why make it private? Because we can access it from the outside environment using the getter and setter. So what's the use of making it private and updating the value and getting the value through getter or setter? Now let me tell you the answer. Okay, so if you make this variable public, then you can directly update its value from anywhere from outside the environment, right? Say for example balance cannot be negative. Okay, this is a terminology that we have fixed. Okay, but if you make it public, then from outside environment you can set any value for it. From outside someone can set minus 5000, which according to your logic is completely wrong, but because you have given access to this balance as public, anyone can update it. So this part is completely wrong. We don't want that. And when you give access through the setter, you are allowing from outside to update it. The good part is this method is yours, so you can put the logic here. So you can put if the amount is smaller than 0, then you can do system dot out dot println wrong input, amount cannot be negative. Okay, and in the else case you can do this logic of balance equal to balance plus amount, right? So why we were able to do this? Because this method is ours and we can write any logic inside it. So you can put any kind of condition that you want to put, and you can do the basic validations because you are getting the parameters from outside environment. So you can check, validate things, do the authentication, authorization, and then once you are fine with everything, you can allow for the modification. Okay, so let me show you in this case. Say we have applied this now, and if from outside if I put the value minus 5000, let's see what will be the output. You can clearly see it has said wrong input, amount cannot be negative. Okay, so it went into this if condition and this was never executed. So the final balance value was 0. It did not say minus 5000, right? So we can apply all those checks because this method is R. But in case the balance was public, then from outside you could directly put the value as minus 5000, minus 10,000, or whatever you want to put. But here you can do all the validations. So that's the benefit of using the getter and setter. This logic complete overall provides like data hiding, and that happens because all this is part of the class. And this concept overall is called as encapsulation, where you are providing the data hiding and using the access control, and that is being done in the class which is acting as a capsule. So this concept overall is called as encapsulation, right? So this was about the encapsulation. Now next let's talk about inheritance. So as I told you earlier, this concept is like you are reusing the code by extending some other class, so you will get all the properties and methods which is the behavior of that class, and then you can add some more properties or behaviors which are specific to the class, right? So let me again show you an example through which you'll get more clarity through code. Okay, so here is the example. So first you can see we have a class animal. Okay, and it has a method eat, right? So the return type is void, which means this method does not return anything. So eat is the method, which makes sense because every animal eats, right? So this is a standard behavior. So in that we have written a statement like animal is eating. Okay, now we have a class dog. So dog is a specific animal. We first talked about animal, now we are talking about specific animal. Now dog also eats because it's a type of animal, right? So instead of writing this logic again in this class of dog, as we know dog is the type of animal, so dog class can simply extend this class animal, right? So you can clearly see we have written first of all the keyword class, then the class name which is dog, then we have used the keyword extends which is used for inheritance, which means you want to use the properties and behavior of this class. Okay, so dog class is extending animal class. So dog class will have this method by default now because it is extending the animal class. But apart from that, the dog class can add its own properties and behaviors which can be specific to dog. Like we have added a behavior which is bark because dog barks. Not every animal barks, right? Cat doesn't bark, and similarly many other animals don't bark. So barking is a behavior which is specific to the dog, so we have kept it specific to dog. But eating is a generic behavior of animals, right? So we have extended that in dog, right? So now we don't need to copy and paste this all logic in the dog because we have extended the animal class, and this would be part of the dog class by default now. So both eat and bark methods are part of now dog class. Okay, so now here you can see in the main class what we have done is like we have created an object of dog class. How? We have written dog as create object name equal to new. This is a constructor of dog class, right? Default constructor. So this has created an object of dog class. Next we have used the method of dog class. So we have written here dog.eat. Here you can clearly see we have not written any method eat in the dog class, but we are able to use it because it is inherited from the animal class. Why? Because we have written this keyword extends. So dog class is extending the animal class, which means all the properties and behaviors which are part of animal class are now also part of the dog class, and that is why we can do this, right? And next we have written dog object dot bark, because bark is a method of dog class, right? So this is the method which is specific to the dog class, and we have written that method. This is the method which is inherited from the animal class. We have not written this logic in the dog class, but we can use it because we have used inheritance here using the keyword extends. Now let me run this and try to show you how things are working. Okay, so it clearly says animal is eating, dog is barking, so it is properly working. So both the methods. Now just in case if you create object of animal class, okay, let me do that. Animal a equal to new animal, right? So we have created an object of animal class. If you do a dot eat, that is totally fine because eat is a method of animal class. But if you try to use this method bark, it won't work. If you write a dot bark, it won't work, right? It is giving you compile time error because bark is not a method of animal class. So here you can clearly see it says cannot resolve method bark in animal because it's not a method in animal class. Dog class has extended animal. Animal class has not extended dog class. So this method is part of this class. It is not related to animal class. Eat method is part of dog class as well, just because we have used this extends animal. Okay, so in case if I remove this part of extends animal, right, I'll remove that using the comment. I told you about this comment, right? So we are using this, and now basically we have commented out this part. Now if we comment out this part, dog object dot bark is fine because that is the method of dog class, but dog object dot eat doesn't work now because eat is the method of animal class and it is not related to dog class now because the dog class is not extending the animal class right now, right? So it is giving you the compile error. And if I remove this part, now dog class is extending the animal class, which means the properties and methods of animal class will be now part of dog class as well, right? In that case it works. So this is inheritance. So in case there are some of the properties and behaviors which are similar, you can simply extend that using the inheritance. Now that we are talking about inheritance, let's see different types of inheritance which is supported in Java. So first type is single inheritance. Say there is a class A, there is a class B. So we can say A extends B, right? So I have not written the complete keyword here, but just imagine it says class A extends B. So this is single inheritance, which means you are extending one class. So this is completely fine and it is supported in Java. And we saw an example here like class dog extends animal. So this is a example of single inheritance and it is completely fine in Java. It works fine. Okay. Next is multi-level inheritance. So there is class A. Now B class extends A class. Okay, so B class will have all the properties and methods which are part of A class, and apart from that B class can have specific methods and behaviors which would be related to B class. Okay, till now it is single inheritance because one class is extending another class, but now we will have multi-level of inheritance. Now class C will inherit class B. Okay, so now what will happen is, say A had property A, okay, and B had property B. So because B class was extending A class, B class will have B and A as well. Okay. But now C class, which had the property C, it is extending B. So now C class will have C, B and A. Why? Because B class had B and A. Why A? Because it was extending A. Now, because C is extending B, it will have C which is specific to B, but it will also have properties and behaviors which are present in B. B had both B and A. So C will have C, B and A. Okay, so this is an example of multi-level inheritance. So let me show you example of this in code through which you will get more clarity. Okay, so here you can see I have created three classes. First class is like class A and it has one method A. Okay, and inside that we are printing A. After that we have class B which extends class A. Okay, and it has a method B which prints something. Right now, because B class is extending A class, so this method A will also be part of B class because we are using the keyword extends. Right now, after this we have a class C which extends B, and this C class has a specific method C in which we are printing something. But because it is inheriting class B, so it also has this method B, and because B had method A, so that would be also part of C now. So when I am creating an object of class C, you can clearly see I can call method C, method B, method A, all of these. Now you are able to call object.c because that is the method of C class which is specific to C, right? So that works. This is the, you can say, own method. Right now the object of C is able to call method B. Why? Because C class extends B class. Right, so let me write here because C extends B. Right, and B is the method of class B which is specific to B. Because you are now extending the B class, so this method is also part of C class, and that's why you can do this. But now you can also do object of C dot A. Why you are able to do this? Because B extends A. Now because B extended A and A is part of A class, so this will also become part of B class, right? And now because C class extends B class, so A will also be part of C class now. So this is acting as like multi-level inheritance, right? So B class extends A class and C class extends B class. Now because of this multi-level, C has all the properties and behaviors of B class as well as A class. So there is multi-level, and this is allowed in Java, this work, like I displayed you this example. So let me also run it for you so that you get more clarity. You can clearly see this runs properly, no issues, no compile time errors, and it works perfectly fine, right? So after this we can also have some scenario where there is class A and B class extends to A class, and then there is class C. C class also extends A class, so that is totally fine. So if I show you example of this, it would be something like we have this class A which has its method, we have class B which extends class A and it has its own method. So now class B will have this method, also apart from it, it will also have this method because it extends A. Now there is one more class C which also extends A. Okay, this is fine. Now C has a method and C will also have this method because it is extending A. So both class B and C are extending class A. This is totally fine in Java, right? So a class can be inherited from multiple different classes. That is totally fine. Like B is extending A, C is extending A. There can be one more class like D which extends A. So there is no limit like that. Many classes can extend a class. Okay. So this is totally fine. Now next is multiple inheritance. So say there are three classes A, B and C. Now if class C tries to extend both of these classes A and B, which means C is trying to extend more than one class. It can be 2, 3, 4, 5, or any count, right? If that is the case, that is not allowed in Java. You cannot extend more than one class at one time. Okay, so let me show you an example through which we'll get more clarity of the same. So here you can see we have first of all class A. This has some behavior and attributes. Then we have class B, which has its own set of behavior. Then we have class C, which is trying to extend two classes here, both A and B, right? And you can clearly see we are getting a compile time error here. What's the error? It says class cannot extend multiple classes. So inheritance of type multiple is not allowed in Java. It is allowed in few other programming languages. It is not a generic concept. It is allowed, say, in Python, okay? But it is not allowed in Java. You cannot extend more than one class, okay? Here, if I remove B, then it is totally fine. Instead of A, if I write B, it is totally fine in that way also, because you are extending only one class. But if you try to extend multiple classes, then it is an issue in Java. You cannot do that. It will give you compile time error. So that is why when I said like multiple inheritance, this is not allowed in Java. But say if you want to reuse the code of multiple files, then what to do? There is a way for that. We can use interfaces, which we will cover later in this video. But for now, you need to remember multiple inheritance is not allowed in Java. So you cannot extend more than one class in Java, right? So this was about inheritance. All right. So next, let's discuss about polymorphism. So polymorphism means many forms. So this lets you perform one action in many different ways. Now polymorphism has two types. First is the compile time polymorphism, which is also called as method overloading, and the second type is runtime polymorphism, which is also called as method overriding. Now let's discuss about each of these in detail. Let's start with method overloading. It means that you have multiple methods which have same method name, but they have different parameter types or counts. Now let me show you an example in IntelliJ code so that you get more clarity about it, right? So here is the code. You can see we have this class which has name mathUtil. It has two methods. Both of these methods have same method name. But if you see the parameters, the data type is different. In first method, we are passing the parameter with data type int and int. Whereas in other method, we are passing the data type double for both the parameters. So this is an example of method overloading, where we have the same method names, but there is a variation. Variation can be in the number of arguments or the data type of the arguments. Like for example, if I make one more method here, int add int a int b. Now till now both of these methods are exactly same because the method name is same. At the same time the parameters count and their data type is also same, right? So this will give you compile error. But after this, if I add one more parameter, now this method is a different method as compared to the first one because the number of parameters are different. This method although has the same method name as the above one, but this has three input parameters, whereas the first method has two input parameters. So in method overloading, although the name is same, the variation can happen in terms of number one, the count of input parameters. For example, here there were two parameters, here there are three parameters. So this is a valid example. Number two, the data type. For example, in this and this method, the method name is same, number of parameters are also same, both have two, but the data type is different. First one is taking int, whereas this method is taking double, right? So let me complete this method. In the body I am saying return a plus b plus c. Okay, so I can call this method from here. We have created the object of this class using the new keyword and then calling the constructor, right? And then using this object name we can call the method. So let me also call our second method system.out.println, and let me do m.add, and let me pass in it the parameters 1, 2 and 3, right? Now based on the parameters that you pass, it can identify which method should be called. For example, the first case, you are calling the method add. Now all three of these methods have same name add, but based on the parameters it can identify which method to call, right? For example, now here we are doing 5 6, so number of parameters are 2, so this method is out of the league because here there are 3 parameters and we are calling 2 parameters. So now it's between this one and this one, but in the parameters we are passing integer, so it will call this method, right? And it will return integer value. So the answer of this should be 11 because 5 plus 6 is 11. Now going to the next case, we are again calling the add method. All three of these have the same name add, but here you can see we are passing 3 parameters. So first one is out of the league because it has 2 parameters and we are passing 3. So this is out. Then the second method, it has 3 parameters. So this is valid case. Going to the third one, it also has 2 parameters, so this is also out when we call this, right? So this will make call to this method and hence the result will be a plus b plus c and return as integer. So 1 plus 2 plus 3 is 6, right? Going to the third case, we are again calling add. All three of these have the same method name, but the parameters are 2, so this method is out because it has 3 parameters, and now it's between the first and the third one, but we are passing double values, right? So that's why this method will be called, and the answer will be 2.5 plus 3.5, which is 6.0. I'm saying 6.0 because it is returning double, right? So let's try to run and see what's the answer of this. Okay, you can clearly see the answer matches. First is 11, then it's 6, and then 6.0. So this is an example of method overloading. So multiple methods in a class can have the same method name, but they can be differentiated based on number of input parameters and the type of the input parameters, right? So this is compile time polymorphism where the name is same but different functionality can be provided. So this was the first type of polymorphism, which was compile time polymorphism, or you can say method overloading. Now let's see the second category, which is runtime polymorphism or method overriding. So here is a second type, method overriding. It means a subclass redefines a method from its parent class. Now what is subclass parent class? We just discussed about inheritance, right? So if a class A extends class B, so class B is the parent class and class A is the child class. So the child class will inherit the variables and methods of the parent class, right? Because it is extending the parent class. So the child class can also be said as subclass. Okay, and when we talk about method overriding, basically the child class can redefine a method of the parent class. So let me show you an example in code through which you will get more clarity. Okay, so here we are. You can first of all see we have defined a class which has the name animal. Now this animal class has a method named as sound. The return type is void, which means it is not returning anything, but the method name is sound. Okay, so inside the method implementation we have written system.out.println animal makes sound, right? So up next we have created another class which is the dog class, and this class extends animal class. So this is an example of inheritance, right? We discussed about inheritance where you can reuse the code. So now dog class has by default this method sound because it is extending the animal class, and animal class has this method sound, right? Now we will see a case of method overriding, which is runtime polymorphism, which means the child class will override a method of the parent class. So parent class has this method void sound. Now the child class will redefine this method. So first of all, the child class got this method due to inheritance, right? Because it is extending the parent class. Now it has access to this method, but now the child class is redefining the method for its own specifications, right? So you can clearly see we have written the same method name, the same return type, but inside that the implementation has changed. Animal was saying animal makes sound, but we have now made the implementation by overriding this method specific to dog class because dog barks. right? So we have changed the implementation of the same method which we extended from the animal class. So that term is called override. So you can see we have used an annotation which says @override. So this symbol signifies the annotation. Okay, so let me show you the magic now. Now in the main class you are creating an object, right? So here if I do animal object equal to new animal, right? If we do this, it will basically create an object of animal class, right? Now if I do object dot sound, so what will happen? It will call the sound method of animal class and this should get printed, right? Now after this, let's create an object of dog class. So let's do dog object equal to new dog. This makes sense. We have simply created an object of dog class here, right? This is the new keyword that we use to allocate the memory in heap, and this is the constructor of dog class. And then we'll say dog object dot sound. We can do this because first of all dog class extends the animal class, but at the same time dog class also overrided this method. It provided its own implementation, right? So this should print this thing, dog barks, right? So let me comment this out for now and let's see what it prints. So first one should print this thing. Let me write in the comment, they should print, right? And the second one should print this thing, right? So let's see what the answer is. Let's try to run this. Okay, you can clearly see it matches our expectations. It says animal makes sounds for first one and dog barks for the second one. Okay, now let's see something new. Okay, so we have created an object. We have used the class name animal. Okay, this one, which is the parent class. And then we have defined the object name. Say we have said A. Okay, and then we have done new. Instead of new animal, we are doing new dog. Now this is something new, right? Generally we do the class name object name equal to new constructor of that class, which matches, right? If we are talking about the class animal, then the constructor would also be like animal. If we are talking about the dog class, then the constructor name is also related to dog. But here we have done something unusual. Here we have written animal object name equal to new dog. How come this is not giving any compile time error? Because this is something called as runtime polymorphism. So it assigns the value to the object at the runtime. It is not happening at the compile time. But still, how is it allowed that we are writing the class name as animal, but then in the constructor we are passing dog? This is possible only because the dog class extends the animal class. So dog class is a subtype of animal class. Dog class is an instance of animal class because this is the parent, this is the child. So the child class is an instance of, is a type of, is a subtype of, specific type of the parent class. So this is allowed. You can do parent class name object name equal to new child class constructor. This is allowed because child class is a subtype of the parent class, right? So that's why this is allowed. Now when you do object name dot sound, now the main part comes, which method should get called, the sound of parent class or the sound of child class? And the answer is method of child class, because we have used the constructor of the child class, and the child class is a subtype instance of the parent class. So this thing is called runtime polymorphism, and when you call this method, it will call the overridden method of the child class, right? So this will also give you output dog barks. Let's try to see what's the output. All right, you can clearly see first says animal makes sounds, which makes sense because we use the class name of animal, and while creating the object we use the constructor of animal class as well. So it simply will call the method of animal class. Then we created object of dog class. The class name was dog. The constructor also we use dog. So this will call the method of dog class. That is simple. But here when we use the class name of the parent class, but during the constructor we use the child name, right? So this will call the method of child class, and you can clearly see it says dog barks, right? Now one more thing we did here, something like parent class object name equal to new child class, right? We did something like this. Now this is allowed in runtime polymorphism because the child class is extending the parent class. It is an instance of, or it's a subtype of the parent class, but the opposite is not allowed. Like this way it's correct, okay, but the opposite way where you might try to do child class object name equal to new parent class, this is not allowed, okay, this is not allowed. So if I give you an example, we are doing something like dog obj equal to new animal, okay, so this is not allowed because dog is a child class and animal is a parent class. So if you do something like this, you can clearly see we are getting compile time error. This is not allowed. Why? It says required type is dog but provided is animal, right? Because we took the class name as dog, but then constructor we used animal. So this is not allowed, but this was allowed. Why? Because dog class is an instance of animal class. Dog class extends the animal class, whereas animal class is not a subtype or instance of the dog class. Animal is parent, child is subtype. So child can use the name of parent, but parent is not the subtype of child, okay? So this is the thing that you need to keep in mind. This is not allowed, right? So I've commented this out. So the important part is this is an example of runtime polymorphism, right? Basically the child class can override the method of the base class or the parent class. You can clearly see everything is same. The method name, number of parameters, data type, everything is same, but we have provided a different implementation. So this is called method overriding, right? I displayed you all the ways you can create the object of parent class, you can create the object directly of the child class, and you can do something like this as well, because the child class is an instance of or the subtype of the parent class. So this is also allowed, right? So this was about polymorphism. We discussed both the types, like compile time polymorphism, which is method overloading, where in a class you will have multiple methods with same method name, but those methods will be differentiated either by the number of input variables in the method or by the data types of the parameter. And the next is runtime polymorphism or method overriding, which means a subclass redefines a method from its parent class, which is called method overriding, right? So this was about polymorphism. Next, let's talk about the pillar 4 of object oriented programming, and that is abstraction. Now, as I told you earlier, abstraction means hiding the complex details and exposing only the essentials. Just like if you are riding a car, if you press the brake, you know on pressing the brake the car will stop, right? But you don't know how internally the brake works. Similarly, when you switch on a button, the tube light turns on, and when you switch off, it turns off. The functionality part we know, right, as an end user, but we don't know how the internal working is happening, how the complete wiring system has happened. So we don't need to know that. So that is abstraction. Now technically you can achieve abstraction in Java using two ways. First is using the abstract classes, and the second is using the interfaces. Now this is a very important topic even for the interviews. So let's see the code through which we will get more idea. First, let's see the code for abstract classes. So here we are. You can see we have created a class with name animal. Okay, so this is totally fine, right? But we see a different thing here. We can see abstract keyword here. Now what does this mean? It basically means that you cannot create object of this class. Like we used to do animal object equal to new animal, right? Now you cannot do because you have mentioned the keyword abstract. Abstract means that the complete functionality or the implementation of this class has not yet been defined, right? So you cannot create object of this class because some of the implementation is missing. So let me show you. Say for example, in the main we created object of dog class, right? If we try to create an object of animal class, it will give you error. So let me write animal object equal to new animal. Okay, let's do this. And clearly you can see it is giving you compile time error, and it says animal is abstract, cannot be instantiated, which means you cannot create object of an abstract class, right? So that's why this is not allowed. So let me remove this. Why it is not allowed? Because as I said, abstract keyword represents that some implementation of the class is missing. Okay, so an abstract class may or may not have abstract methods. Abstract method is a method of which we don't provide an implementation, right? So abstract class can have the methods with implementation. For example, here you can see we have mentioned void eat. This is a method and it has the implementation, right? In the we have the opening bracket, closing bracket, and inside that we have mentioned the implementation. So this is a normal method with the implementation. So abstract class can have this kind of method, but at the same time abstract class can have a abstract method as well. Now what is an abstract method? Abstract method means which has no body or it has no current implementation. You can see there is no opening bracket here, no closing bracket, and no implementation. We just defined the method abstract void sound and then we put the semicolon, which means this statement is over. So there is no implementation of this method, and that's why we have mentioned the keyword abstract. This method is abstract, which means there is no current implementation of this method. So the main point is abstract class is a class which can contain normal methods as well as it can contain abstract methods. Now how many abstract methods can a abstract class contain? The answer is 0 or more. So for example, if I comment out this abstract method here, it is totally fine. I mean, there is no compile time error. So an abstract class can have 0 abstract method as well. Okay. And at the same time, abstract class can have 0 normal methods as well, right? Now this class has no method, not even abstract, not even normal method. It is totally fine. Okay. And then if I uncomment it, now this abstract class has 0 abstract method but 1 normal method. That is also fine. Now if I uncomment this but put this in comment, this is also fine. The abstract class here is having 1 abstract method but 0 any other method which has already provided the implementation. This is totally fine, right? And when I uncomment this, now this abstract class has both abstract methods as well as non-abstract methods. That is also fine. So the important part is abstract class can have 0 or more abstract methods. Similarly, abstract class can have 0 or more non-abstract methods where implementation can be provided, right? But when we define abstract keyword in front of the method, it means no implementation or no body has been provided, and that can be part only of the abstract class. And when we write abstract in front of the class, it means we cannot create object of this class. Now abstract method can be only part of an abstract class. For example, here this is a normal class. You cannot see any abstract keyword here, right? That's why you were able to create the object of this dog class, right? Now if I try to create an abstract method inside this, there will be error. Let me write method, right? So this will give you compile time error because abstract method cannot be part of a normal class. Abstract method needs to be part only of abstract class because you cannot create object of abstract class, which means there is some missing implementation. But if you try to create abstract method in a normal class, it will give you a compile error. It says abstract method in non-abstract class, so this is not allowed. Okay, so let me remove this. So what we have learned, if you write abstract keyword in front of a class, you cannot create object of that class. Number 2, abstract method can be only part of an abstract class. Number 3, abstract class can have 0 or more abstract methods. Number 4, abstract class may or may not contain normal methods where we have provided the implementation like this one. And number 5, you can extend an abstract class. For example, you can clearly see we have created a normal class here, class dog, and it extends abstract class. So you can extend an abstract class, that's totally fine. And then because this class is not abstract, although it is extending abstract class, but still this class is not abstract, you can create object of this class which is not abstract but it is extending the abstract class. So we mentioned we can extend the abstract class, but here comes an important part to remember. When you are extending an abstract class, your class must implement all the abstract methods. For example, this animal class had only one abstract method which was sound. If the class dog is extending abstract class animal, then class dog must provide the implementation of all the abstract methods. Here it was only one, so it needs to provide implementation of sound method. If it doesn't provide that, say I comment this out, then you get the compile time error. So there are two options now: either you provide the implementation of abstract method, or you need to make dog class abstract as well, because there is a missing implementation. So if I show you this error, it says class dog must either be declared abstract or implement abstract method sound in animal, right? So if your class is extending abstract class, either it needs to provide implementation of all the abstract methods of the base class, or it needs to be abstract. If I write abstract here, you can see the compile time error has gone, because this is also abstract class, it can have abstract method. Now this extends animal has this abstract method, so this will be part of dog, but dog itself is abstract class, so it can have abstract methods, right? This is totally fine. But now because dog class is abstract, you cannot create object of dog class, right? Because you cannot create object of an abstract class. So let me remove this abstract. Okay, but now again you will find this error because you are not implementing the abstract method. So let me uncomment this where we have provided the implementation of the abstract method. Now there is no compile time error because this class has provided the implementation of all the abstract methods of the base class. So basically dog class has this method sound as well as this method eat, because it is extending the animal class. And you can clearly see we have created object of dog class and then called both of the methods, sound and eat, right? So this was first type of abstraction, which was using the abstract class. So one important part is, as the abstract class may or may not have abstract methods, similarly abstract class may or may not have the normal methods with the implementation, right? So that's why abstract class provides 0 to 100% of abstraction. Now what does this mean? We said like abstraction is like you are just providing the end functionality, but you are not providing the internal implementation. So here you can see we have also provided the internal implementation, but in this case we have just provided the method name to the end user, but there is no internal implementation. So if we give this class to the end user, they never know what is inside the sound method, but we can simply tell them if you call this method there will be sound, but we are not telling how sound is coming because we have not provided the internal implementation to them. So this is abstraction. This is not abstraction because you have provided implementation as well. Everyone can see what's inside, right? It is like you have provided like how the wires are going through the wall and how the connection is made, and that's how when you click the button the tube light turns on. But here we are just giving the end functionality, we are not giving the implementation. So this is abstraction, this is not abstraction. So as abstract class can have both abstract methods as well and normal methods as well, that's why abstract class provides 0 to 100% of abstraction. In case there is no abstract method, then there is 0% of abstraction. But in case all the methods in the abstract class are abstract, then it provides 100% of abstraction, right? So that's why abstract class can provide 0 to 100% of abstraction. So this was about our first one, which was abstract classes. Now after abstract classes, let's look at interfaces. So we saw in abstract class we may or may not have abstract methods, which means the methods without any implementation. But in interfaces we have all the methods with zero implementation. So we just define the methods, there is no implementation, and hence the interfaces provide 100% of abstraction because there is no method with any implementation. So let me show you an example in code through which you'll get more clarity about interfaces. So here we go. This is the code. First of all, you may see a new keyword here, which is interface. We used to use the keyword like class, right? But now we have a new keyword, which is interface. Now interface keyword is used to define interfaces, right? So for interfaces, you need to write the keyword interface instead of class because interface is a special category in which there is no implementation of method, only defining the method, no implementation, right? Let's go back to the code. So first of all, you will write the keyword interface and then the interface name. I mean, similar to the class, you write class keyword and then the class name. Similarly, you write the interface keyword and then the interface name. And then you have this starting bracket, ending bracket. Inside the starting and ending bracket, you will have methods, but you know, as I said, in interface there is no implementation of the method. We have just defined the method. So void draw is one of the method. It can have many more methods, like for example I can create one more void sound, right? So similar to this, you can have multiple methods here, but no implementation of any of the methods. So let me remove this for now. So currently this interface has this one method where there is no implementation. In abstract class, you saw there can be methods with some implementation, but in interface there is no method with any implementation. So the interface provides you 100% of abstraction. Right now, with new versions of Java, there have been some changes in interface, like you can provide the default implementation, but let's ignore that for now. If we talk about the base old concepts, interface is something where there is no implementation. We just define the methods and hence it provides 100% of abstraction. And there is one more thing: by default all the methods of interface are public and abstract. So they are publicly accessible and they are abstract. Abstract means no implementation. And as I told you earlier, there is 100% abstraction in interface, which means there is no method with the implementation, and hence by default every method in interface is abstract, right? So we saw in abstract class you cannot create object of the abstract class, but you can extend the abstract class, and then the class which extends the abstract class needs to provide implementation of the abstract methods, right? And then you can create object of that child class, right? That was allowed. But now what about interface? Just like you can extend the classes, you can implement the interface. So now I am introducing a new keyword here, implements. Like for class, we used to write class circle extends, but for interface, you will write implement. So you will implement the interface. Okay, so here we are writing class name, which is circle. It implements this interface shape. Now when you implement an interface, you need to provide implementation of all the methods of the interface. For example, here we had only one method in the interface. So when we implement the interface, we need to provide implementation of this method. So clearly you can see we have provided implementation of this draw method. We have written public void draw, which was the name of the method which was present in interface, and then we have provided the implementation. In case we don't provide implementation of the method, we will get compile time error. It will say the class circle must either be declared abstract or implement abstract methods draw in shape. Just like we saw the example of abstract class, right? Very similar. The difference being in interface, you don't have any method where you can provide the implementation, right? But in abstract class, you may or may not provide few other methods in which you can provide the implementation. That's why abstract class was 0 to 100% of abstraction, whereas interface is 100% abstraction. Like all the methods are just declared, there is no implementation. So when you implement interface, you need to provide implementation of that. If you're not doing that, you need to make this class abstract. But if you make this class abstract, then you cannot create object of this class, right? So that's why I am uncommenting the code and we are providing the implementation of the method of the interface. So then you can clearly see we can create object of this class now because this is not abstract. So we can create the object like circle object name equal to new circle, or you can also do something like this. We saw this example in the runtime polymorphism, right? you took the base class name, then object name, then new, and then the constructor of child class. Similarly, you can do something like interface name object name equal to new child class name. Just like abstract class, you cannot create object of the interface. So if I write something like shape s shape object equal to new shape, this is not allowed. You cannot create an object of the interface. I can show you the error. Shape is abstract, cannot be instantiated. So you can also see it is saying abstract, right? So interface is also abstract, so you cannot create the object like this, but this is allowed because it is something which we discussed in the runtime polymorphism, that here is the base or the parent class or the interface, and then the object name, and then new keyword, and then the child class name, because this class circle is implementing the shape interface, right? So one question may come into your mind, like if there is so much similarity, why we have two different things like abstract class and interface? Why not use simply one of the concept? So there are two major points in this that you need to remember, because this is a very famous interview question as well, when to use abstract class versus when to use interface. So the first thing is like abstract class provides 0 to 100% of abstraction, right? So there can be methods in abstract class where you can provide the functionality, whereas in the interface, if we talk about the older versions of Java, all the methods are just defined. There is no implementation of any of the methods in the interface. Okay, so interface provides 100% abstraction, whereas abstract class provides 0 to 100% of abstraction. Number two, I told you earlier that multiple inheritance is not allowed in Java. So you cannot extend more than one class. So you cannot extend two classes in one go, right? Just imagine if you are extending an abstract class, like for example, here we are implementing the interface. If instead of this you were extending the abstract class, then you cannot extend any other class, because you can extend only one class in Java. You cannot extend two classes, right? But in case of interface, you can implement multiple interfaces. So here if I create one more interface, so let's give the name of interface hello, although you should give better naming through which you will get an idea what this interface is doing, but just for example I'm taking hello, and let's make a method inside this which is speak. Okay, and because it's an interface, we do not provide any implementation, right? So now I am showing you your class can implement multiple interfaces, like it says implements, then the interface name shape, and then let's put comma and then hello. So basically this class is implementing two interfaces now. That is allowed in Java. You can implement multiple interfaces, that is allowed, but you cannot extend two classes. Okay, you can extend one class and implement multiple interfaces as well, that is allowed, but you cannot extend two classes in Java. You can implement multiple interface, that is fine. Now you might see that it is showing some compiler error. Why is that? Because we have now written that we are implementing hello interface as well, so we need to implement its method as well. So you can clearly see the error. Class circle must either be declared abstract or implement abstract method speak, because now we are implementing hello as well, so we need to implement its method. Okay, so let's implement that. Let's put public void speak, right? And inside that let's provide the implementation. Let's write system dot out dot println speaking. Okay, so now you can clearly see there is no compile time error. So this is totally allowed. You can implement multiple interfaces, not only two, you can implement many more interfaces. Okay, so that's one of the major benefit of using the interface versus abstract class, because in Java you cannot extend two classes. So if your class is extending abstract class, it cannot extend any other class, whereas for interfaces you can implement multiple interfaces. So interface makes it easier, right? Apart from this, there is one more difference, because abstract class is a class, so it can have constructor, right? And in that you can provide some implementation, you can do some initialization and all that stuff, whereas interface has no constructor. So when you start doing development, you will see a lot of usage of interface. Okay, and you might also see some of the usage of abstract class, not that highly, but it will be used. It can be used in some of the cases, like you have one base class and then you have multiple other classes, and these all classes basically want to have some basic implementation, the default implementation of some of the things. Say for example, you have multiple screens, and each of the screens you need to show some common part. So that common implementation, common part can be part of the abstract class, and then all of these classes can simply extend to this class. Okay, that can be one of the use case of abstract class. But you will see a lot of usage of interface. Okay, interface provides 100% abstraction, and then it makes things easier because you can implement multiple interfaces, so it provides more flexibility, right? Alright, so this was about the interfaces, and through this we have covered abstraction as well. Now let's go back and see summary of all the 4 pillars that we have covered in object oriented programming. So here we go. You can clearly see we discussed about multiple things here. First, of course, we said like Java is object oriented programming, which means everything revolves around the objects and the classes. So the class is basically the blueprint or the template for objects, right? Whereas object is the actual thing, it is an instance of the class. So this is how you create an object. You first give the class name, then object name, then assignment operator, then you use the new keyword which will basically allocate the memory in heap, and then you basically call the constructor of the class. This is how you create the object. Now when we talked about object oriented programming, we mentioned 4 major pillars of object oriented programming. These are encapsulation, inheritance, polymorphism, and abstraction. So encapsulation is used for data hiding, and that can be done by the access control, setting the access modifiers of the variables as private so that they cannot be accessed outside the class, and then further creating getters and setters. The use of setting getters and setters is that when you are setting the value, you can do some basic validations before setting the value. Next is the inheritance, which is used to reuse the code. Here is an example. You can see class B extends A. So A is the parent class, B is the child class. So B class will get the variables and methods which were present in the A class. But an important part of inheritance is you cannot extend 2 or more classes in Java. You can only extend one class, right? After that we have polymorphism, which means many forms. Now it has 2 major types. First is overloading and then overriding. Overloading means in a class you have multiple methods which have same method name, but they are still different based on number of parameters present in the method or the data type of the parameters. Method overloading is also known as compile time polymorphism. Next we have overriding, which is runtime polymorphism, which means in the child class you are overriding the method of the parent class and providing a new implementation in the child class. And the 4th pillar is abstraction, which means you are hiding the internal implementation or details. Now this can be achieved by 2 ways. First is using abstract class, and the second way is using interface. Abstract class provides 0 to 100% of abstraction because it may or may not contain abstract methods. It may or may not contain methods with the implementation. Whereas interface provides 100% of abstraction because all of the methods you just define, you don't provide the implementation. Another important part is, like as we discussed, in Java you can extend only one class, but you can implement multiple interfaces at a time. So using interface provides you more flexibility. So this was about object oriented programming. Next, let's discuss about 2 keywords which are super and this. So this keyword is used to refer to the current object, whereas super, it refers to the parent class. It is used to access the methods and constructors. So now let's see an example in code for this. Okay, so you can see here we have created a class animal. It has a variable value here of type int. Now in the constructor, you can see this is a parameterized constructor because there is a parameter, right? How this is a constructor? Because the name is same as the class, right? So public animal, it has this parameterized constructor, and what we have used is this keyword. Now this is useful when basically the parameter name is same as the variable name. You can see both have the same variable name, value and value. So that's why using this dot value removes the ambiguity. This means when you say this dot, it means you're talking about the current object. So it refers to this one. So using the this keyword, it means that you are referring to the current object. So this value, correct? And then normal value is representing the value which is present in the parameter. So this keyword will be useful when you want to tell refer to the current object. So you might see some of the use cases like this for this keyword, but mostly it will be helpful when you have the same parameter name. If I change the parameter name here, like for example val, then it is, I think, totally fine even if you don't write this dot, because both have different names. So even now if you write value.val, it makes sense, but say both have the same name, value, then it becomes like ambiguity, like which value. You can see here value equal to value, it doesn't make any sense, right? Because this is also value, this is also value. Then in order to identify which value, then you have to do this dot value. So you are assigning the value in this one, which is the variable in the current object. Okay, so this is how this keyword will be used. Next, let's see the example of super. So we have created a dog class which extends the animal class, and you can clearly see in the constructor of the dog we have called super. So super is used to call the parent. So we are present in the constructor, so super will call the constructor of the parent. That means this constructor. Okay, similarly dog is basically overriding this method, because sound method was present in the animal class as well, and now we are providing the implementation in the dog class. So this is method overriding, right? And in this you can clearly see before writing something we have mentioned super dot sound. So the super keyword helps here to basically call the parent. Okay, so here because we have written super dot sound, so it will call the parent method of sound. Okay, so this method will be called, and then after that we have also provided some of our implementation. So if I create an object of dog class, right, and then I call this method sound, so what it will do is like first it will call the parent method because we have used the super keyword, and then this. So the output should be first animal sound should be printed and then dog barks. Let me print this and you'll get more clarity on that part. So you can clearly see it says animal sound and then dog barks. Okay, so this keyword will be used when basically your variable name and the parameters have the same name. So this will be used to identify or tell that we are talking about the current objects thing. So like here current objects value, this one, and normal value is representing the parameter. Okay, super will be used to call the parent. So here we call like super dot sound, it will call first the sound method of the parent class. So if you got a bit confused here, like you didn't get complete understanding, it's totally okay. I don't see a huge usage of these both of these, this keyword and the super, but I just told you so that if you see it somewhere it shouldn't look like, oh what is this. So but not that crucial, so it's okay if you didn't get too much understanding of it. Like once you start doing proper coding and so you'll automatically get some of the keywords, because we are covering so many topics, so some of the topics might skip from your mind. So it's totally okay because these are not that crucial. Okay, I just told you for your basic understanding here. Right, now let's understand what is the meaning and use of static keyword in Java. So as we discussed earlier, Java is object oriented programming which revolves around class and objects. So class is the blueprint or the template which contains the variables and the methods. Object is an actual unit which is instance of the class. So if you want to use any variables or methods of the class, you first create object of the class, and then from the object name you can access the variables and the methods, right? We saw multiple examples of doing the same, but here comes the twist with the static keyword. So the static keyword allows a member, here member can be variable, method, or a block. So static keyword allows any of these to belong to a class itself and not to individual objects. So basically if you use the static keyword, this variable will belong to this class specifically and not to the object. Similar is the case for methods. Now I know there might be confusion in the mind listening to this, so let's check the code through which we will get more understanding. Alright, so here you can see we have created the class with class name student. It has variables. First one is roll number, which is of type integer. Next is name, which is of type string, and then there is another variable college which is of type string, right? So next we have this parameterized constructor where we are initializing some of our variables, and then we also have a method of this class in which we have printed some of the stuff. So as we saw earlier, we generally create the object of this class to use the method and the variables, correct? So here I have created two objects. First name is s1 and second object's name is s2. So we have written class name, object name, and then assignment operator, then new keyword, and then the constructor. This is the parameterized constructor, so we have passed the values in it. So this was the first object s1, and then we created a new object s2. Okay, so as we understood earlier, right, so object is the actual thing, class is just the template. So say if there are two variables, the name can be A and B, both are say of integer type. And if I create two objects, right, this can be O1 and this can be O2. So two objects. So both of these will have like separate these variables. So both of these can have like independent values of these variables because all the variables and methods belong to the object. So if we create a new object, it can have independent values of the variables and it can independently call the methods. So for example, O1 may have A set to 3 and B set to 5. Okay. Whereas in case of O2, A can be set as like 10 and B can be set as like 15, right? So both objects have different values set to the variables, and there can be case O1 is calling the method whereas O2 is not calling the method. So anything can be done because all of these are respective to the objects, right? So even when we are passing the values in the constructor, so you can clearly see we are passing different values for both of the objects. And what will happen is like for s1 object we will set the values 1 and Alice, whereas for s2 object we will set the values 2 and Bob. So both have different values because the variables are belonging to the object and we have created two separate objects. Okay, so they have their separate variables. Similarly, you can see both are calling the methods of the class, right? So here we are passing 1 Alice, 2 Bob. So in the constructor you can see we have set the value of roll number and name. So object 1 will have the roll number 1 and name Alice, whereas object 2 will have roll number set to 2 and name Bob, right? So this is fine. But what about the third variable? You can see here we have marked it as static. When we say static, it means that it belongs to the class and not the individual objects. So if I make any variable static here, that belongs to this class and not to the objects. So even if you create multiple objects like O1, O2 here, you don't get this separately for these objects because we have mentioned keyword static, and this variable now will belong to this class, not to the objects. So if you see this example again, this is static and we have assigned some value to it. So it will be same for all the objects. So if you create multiple objects, like here we created 2, you can create like 10, 20 objects, but this variable will have same value across all objects. You can imagine it as it is a shared kind of variable because we have used the static keyword here. So let me print the answer for this one. So clearly you can see it says 1 Alice because we passed 1 Alice, and then ABC University because this is static and we have given it a value which will be same for both of the objects, right? So you can remember it something like if you don't use the static keyword, then each of the object that you create will have a separate variable. Okay, so when we talk about normal variables here, roll number and name, whenever you create a new object, each of the object will have its own variables and method. Okay, but when you mark a variable as static, that will be shared across all the objects of that class, because this is now specific to the class, it is not specific to the object. So all the objects are sharing this specific variable now because we have marked it as static. So let's go to the visual representation and see it in more detail. Okay, so I told you when you create object you use the new keyword and it allocates the memory in the heap. So basically say this is the object memory. Okay, this is O1 and this is O2. So basically we have created two objects. And what was the class? Say it had like variable, first of all a, okay, and then there was one more int b, right? And then we can also have like static. So I'm creating a new variable with static keyword and I'm writing int c. Okay, so when you create a new object, both of these a and b will be part of the object memory. So it will have a, it will also have a, because you have created two objects here. Now O1 will have b because that is part of the class, and when you create the object you'll get the things from the blueprint, right? But when you create O2 it will also have b. So both of these have like these variables, so these are independent. Okay, they are not sharing this. But when we talk about C, right, because it is marked as static, it will not be part of the object memory. Okay, variable C will be shared by both the objects. So O1 and O2 both are sharing this variable C. C is not part of the object memory. Okay, so if there are any changes in C, it will be reflected in all the objects, which is not same for A and B, right? Because in O1 if you update A as 3 and in O2 you update A as 5, so O1 will still have A's value as 3. It won't change to 5 because in O2 you change the value of A to 5. Okay, because these are present in the object memory and we have created multiple objects. So these are independent. These are not getting shared. But when we update the value of C to say 6, right, so that will be reflected in both of the objects, because all of the objects in this class are sharing this variable because we have marked it as static. So static belongs to the class itself. This was an example of variable, and in case of variable basically the variable is shared among all the objects. Okay, so if you change value of the static variable it will be reflected in all the objects because it is getting shared. So this was an example of using static keyword with the variable. Next let's see how to use static with the method. So when we talk about methods, right, say for example this is the class and here we have two methods. Okay, now how to use this method? You first create object of the class, right, and then from the object name, say it is O1 and the method name is M1 and M2, right? So how do you call M1? You first create object. So say the name of object is O1, then you will do O1 dot M1, right? This is the way you call the method. First, like you create the object. So say the class name is C, you will write class name, then object name which was O1, and you will write new keyword, and then after that you write the constructor. So say for example I'm using the default constructor here. So using this you have created the object, right? Now you can call the method using this O1 dot method name, right? So this is the way you call the methods. But again, static keyword is the game changer. So if you use static keyword with a method, you don't need to create object to call this. You can call it directly using the class name. But an important part is static method can only access static members only. So now let me take you to the code through which you'll get more clarity. Okay, here you can see we have created a class named as mathUtil. You can name class whatever you want to, but generally the naming convention should be like this, that you get more understanding through the class name. Okay, so inside this you can see there is a method. Return type of the method is int, which means it returns an integer. The method name is square. And how do we know this is a method? Because of these brackets, right? Every time you write the method you have to keep these brackets, and inside the brackets you can see we have passed the parameter. So what is it returning? It is returning x into x because we are calculating square of a number. So if the number is x, we would return x into x. right? So for example, when we talk about 3 square is 9, which is 3 into 3. So same way we have written that logic here. Okay, and then we have this main class. Inside that, how do we generally call the method? We first create object of this class, and then we'll do object name dot calling this method, right? But here comes a twist. We have used static keyword here, right? So this method is static now. What it means is that you do not need to create object of this class for calling this method. You can simply call it using class name dot method name, just like this. For example, if you see here, we have done class name dot method name. Okay, through this we can directly call this method. There is no need of creating object just because this is static. So let me explain you even better by creating a non-static method here. So I'll just do the same thing whatever we did here, but I'll just make it non-static. So I am not using the static keyword here. I'll name it as square 2, and it will have the same parameter, and it will return the same thing, x into x. Okay, so clearly you can see we have the same to same exact method, just like above. Just I have changed the name because you cannot have two methods with same name and same arguments, everything, right? Only difference here is the first method is static, and the second method there is no static keyword, so this is non-static, right? So let me try to call this method in the same way like this. So what I'll do is, like, I'll copy this, I'll write here square 2. Let's see what happens. So you can clearly see it is giving compile time error, and it says non-static method square 2 cannot be referenced from a static context. Okay, so if you want to call this method, you have to first create object of the class. So I'll do class name, which is mathUtil, and then object name, I'm writing it object only, and then you have assignment operator, which is equal to, and then you use the new keyword, and then the constructor of the class, right? So this is how you create the object. Now if I want to call this non-static method, I'll do object name dot method name. So I'll write here object. So you can clearly see now the compile error has removed. Basically, to call any non-static method, you have to create the object. But for the static method, you don't need an object. You can simply do class name dot method name, right? So this is the beauty of the static keyword. Let me change the input here, and now let me try to run and show you if both of these work. Clearly you can see it says 25 and 9. 5 into 5 is 25, 3 into 3 is 9. So it works. But the main part is, if you use static keyword with the method, you don't need to create an object of that class to call this method. You can directly call it. But when we talk about static methods, there is one more thing. Say there is non-static variable, say we are talking about int y, and its value is say 10. Okay, you cannot use this variable inside this method because this method is static, whereas this variable is non-static. So if I do x into y, it will give you error because it says non-static field y cannot be referenced from a static context, whereas if I try to use y here, that is totally fine because this method is non-static, right? There is no static keyword here. So here you can use any variable, right? But when we talk about a static method, you can only use the static members inside this. So you cannot use any non-static member. Okay, same is the case here. If you see the main method which we are using from the beginning, this is a static method, right? So inside this you cannot use non-static members directly. For example, I was calling this square 2 directly, right, like this. So it gives the same error. If you see, it says non-static method cannot be referenced, right? So this is the same thing because this is static, so you cannot refer any non-static member inside it. So in case you want to call a non-static method from the static method, you have to create the object, right? So if you do object dot method name, then it works, right? So this is the thing, when you are making a static method, you cannot basically use the non-static members in it. Okay, now I mentioned you cannot use non-static members in the static method. So what if I make this static, right? So you can clearly see the compile error has gone away because now this member is also static. So you can use static members inside the static method. That's totally fine. right? So we checked like using static keyword with the variables and also with the method. Now static can also be used with the block. So let's see more about that. So the third category of using static is static block, and it is used to initialize static data. So the special things about static blocks is that it runs once when the class is loaded. Okay, I know the theory is always confusing, so let me show you an example through code to get more clarity. Okay, so you can see here we have the class main, and inside that we have of course this method public static void main, and inside that we have printed something. But there is one more special thing here. We have used the static block here, right? So we have used the static keyword, and then we have the opening and closing brackets. So inside these brackets we can provide any implementation, and this is called a static block. So this is the third category of using static. We checked like using static with the variables, then using the static with the methods, and then this is the third type, which is using the static blocks. Okay, we talked about main method is a must, and whenever you run, this method automatically gets called. But the beauty of static block is that, so even before executing the main method, this static block will be executed. Let me run this for you and we'll see the output. Here you can see first it says static block executed, which is part of the static block right here, right? This one, okay? And then it says main method executed, which is part of the main method. So even before the main method, static block is automatically called. So in case you want to perform something, initialize something when the class loads, you can do that in the static block, which runs automatically even before the main method. So we talked about static variables, static method, static block. Now the question comes, can a class be static? So the fourth category is nested static class. Now what does nested static class mean? It basically means only inner class can be static. Outer class cannot be static. Now what is this inner class and outer class? We discussed about nested in the loops, right? Loop inside loop, we call it nested loop. Similarly, class inside a class is a nested class. So the outer class and inner class. So a class which is inside another class will be called inner class. So this is outer class, this is inner class. Same as like we did for loop. This is the outer loop, and inside this you have one more loop, right? So this is inner loop, this is outer loop. Similarly, this is outer class, this is inner class. Now the part is only inner class can be static. Outer class cannot be static. Let me show you an example through the code. Alright, here you can see, first of all, we have the outer class, and I have named it outer only to make it easier for you guys. Okay, so outer class, inside this we have inner class. So class inside class, we have named it inner, right? So inside this we have the method display, and we have written some implementation for the same. But an important part to note here is we have made this inner class static. We have used the keyword static with the class, right? So now say if you have to create object of this class outer, how do you do that? You first write the class name, which is outer, then object name, let me write object, then equal to, then new, and then outer. Okay, so class name, object name, equal to, new keyword, and then constructor. This is how you create the object, and this works perfectly fine. But now what if you have to create object of this static inner class? Then you can do something like outer class dot inner class name. Okay, and then you do object name equal to outer class name dot inner class constructor, right? So this is how you can create object of the static inner class, and then you can simply call the method of this static inner class using this object. So you'll do object name dot method name, right? Now the inner class may or may not be static, so you can use the static keyword, or you can skip that also, but you have to use the static keyword with a class. It has to be inner class. You cannot use static keyword with the outer class. Then what is the difference between inner class and static inner class? So for example, if I create a new class here, class inner 2, okay, and it also has a method, say for example method, right? And inside this you write something like system dot out dot println non-static inner class, right? So what is the difference between these two? So when we talk about non-static inner class, it basically holds the reference to object of the outer class. Whereas if I talk about static inner class, it doesn't need object of outer class. It doesn't hold reference of object of the outer class. That you can understand when we create the object. Here you saw, like if we are creating inner class object, we are simply doing outer class name dot inner class name and then object name equal to new outer class dot inner class constructor, right? We did not create object of the outer class. That was not required to create object of the inner class. Why? Because we have used the static keyword. This is quite similar to the static method as well. You did not create object of the class to call the static method, right? You directly called it using class name dot method name, correct? Similarly, when you have to create object of the inner class, you don't need object of the outer class. We simply did this. We did not create object of the outer class. But what if I have to create object of the non-static inner class? Let's try the same thing here. I'll do outer dot inner 2 and then object name equal to new outer dot inner 2. Okay, I've used the same thing that we did for the nested inner class. You can clearly see this is giving compile time error. Why? This is because inner 2 is non-static inner class, and for that you first need object of the outer class. So for this you have to do something like outer equal to new outer. So this is how I created object of outer class, right? So let me name it as outer object, right? So this is the object of outer class. Now in order to create object of the non-static inner class, you have to use this object. Instead of doing this, you will do outer object dot new inner 2. Okay, so now it works. So clearly you can see, in order to create object of non-static inner class, you have to first create object of outer class, whereas outer class object is not required when you are creating object of the static inner class. Now I understand this might be confusing for you in the first go. It's okay, you can ignore it for now. When you are working on the inner classes, which is not that highly used, you'll get more clarity about it. It's okay if you ignore it for now as well. But just to tell you, like when I say the non-static inner class holds the reference to the object of outer class, this comes into picture when we talk about memory leaks. Okay, when you do your development, your code is in production, then of course you need to write efficient code. So sometimes you might see there are memory leaks, which means memory is not getting released even after your class object is not getting used. Okay, so if you are using non-static inner class, as I told you, it holds the reference to the object of outer class. So even if the outer class is not being used, its memory cannot be released. It cannot be garbage collected because the non-static inner class is holding the reference of that object. So till the time this non-static inner class will not be removed from memory, the outer class also cannot be removed. Again, I know too much information. If it's looking like, oh, what is happening? Don't worry. I just told you things. You don't need to remember it for now. When you are working on the things, you can revisit the stuff, and that's totally okay. Okay. All right. Enough of static keyword. We discussed static with variables. We discussed about methods. We discussed about the static blocks, and then we also discussed static inner classes, right? So enough of that. Let's move to the next topic, which is memory areas in Java. Again, this is something which might appear too much for you in the beginning, but don't worry, I'm just telling you stuff. You don't need to remember everything. Just listen to the things. You will get some of the stuff and some of the things will just go. Don't worry about it. I won't take too much time in this one. I'll just tell you the basic stuffs, and once you are basically doing the coding and you are into the system, with time you'll get more clarity, and with time you can revisit some of the concepts. Okay, so basically when we talk about like memory areas in Java, let's first talk about the heap because it will be easier for you. As I told you, when you have to create an object, you use class name object name equal to new keyword, right? and then constructor of the class. Say I'm writing the default constructor here, right? So new keyword is important here. When we use the new keyword, it allocates the memory in the heap. Okay, so heap is where you will have the objects, and say for example this is the class, it has variable, say the variable is int a. Okay, so because object is an instance of the class, and I told you like if there is variable like int a, if you create multiple objects, each of the object will have a separate variable a, right? So this basically variable is also part of the heap memory, because this is the object storage which is present in heap because we use the new keyword, and each of the object will have its own variable, right, which was part of the class. So if you write like int a, that will be basically part of the object memory which is in heap, right? Now next is the method area. Like here we said like we have variable int a. Let's say we have one more variable which is static, so we are using the static keyword here, the one which we just discussed before this, static int, and then the name of the variable is say b. Okay, so a is non-static variable, b is static variable. Now where will this variable live? It cannot be part of the object memory, because when we say static, this will be shared across all the objects. Now say for example there are two objects, if b was part of this and b was part of this, then it doesn't make sense of using static, because we are saying both of these objects will be sharing this variable. So that's why static variables will not be part of the heap, they will be part of this method area, right? And then the next is stack, which will be used for like method variables, method calls. Okay, and the last one, this one you can ignore it for now. Let's see an example through the code to understand more about these. Okay, let's go to the code. Here you can see we have a class. Okay, inside that you have one non-static variable, and then you have one static variable as well, and then there is one method as well. Okay, so when we talk about normal variables which is non-static, that will be part of heap, because when you create an object using the new keyword, the memory is allocated in the heap, and each of the object will have its own set of variables. So that's why this variable will be also part of the heap, because if you create two objects, this variable would be present in both of the objects independently. So that's why it's part of the heap memory. But when we talk about static variables, where we have used the static keyword, okay, this will not be part of the heap storage, because this will be shared across multiple objects, so it cannot be part of the object's storage, right? So this is part of method area. So as we discussed, heap, you can take example of object here and even the non-static variables. Okay, then method area, which has the static variables. All right, and then next, if you have a variable inside a method, that would be part of the stack storage. Now this is basically in scope of this method only, right? So this is allocated in stack, right? So this was about the basics of memory areas in Java. Earlier we discussed in brief about final. Now let's discuss in detail what is the use of final keyword in Java. Let's understand this from code only. All right, here you can see we have created a demo class. Inside this we have this variable int a equal to 3. Variable name is a, data type is integer, and value assigned is 3. It also has one method in which we have printed something. So the point of variable is that you can reassign any value to it. For example, here we have mentioned int a equal to 3. We can reassign value to it anytime. So here I can write a equal to 6. So now the new value of a is 6 instead of 3, right? So that's why it's called variable, which means like you can assign a new value to it anytime. But what if I add a final keyword to it? If you add a final keyword to it, you cannot reassign value to that variable. For example, here you see final int a equal to 3, but when I try to reassign value to a, it says cannot assign a value to final variable. So this is wrong. So if a variable is final, you cannot reassign value to it, right? So this is the use case of final keyword with the variable. So this is the first use case, you can say. When you write final keyword with any variable, you cannot reassign value to it. Okay, So this is not allowed. Let me remove this. So this was about final with the variable. Now what about if I write final keyword to a method? Here you can see this is a function and I have written final keyword with it. What's the difference? So when you add final keyword with a method or function, you cannot override that method. Okay. We discussed about method overriding in runtime polymorphism, right? So if there is a class, say B, which extends demo class, right? So in runtime polymorphism, you can basically override the method of the parent class. But here, because this method is final, you cannot do it. So if I try to do it like public void method, it gives you error. So if I go here, it says you cannot override because overridden method is final, right? So if a method is final, it cannot be overridden. So if I remove this, you can clearly see the error is gone, right? So the final keyword with the method, basically you cannot override that method, right? So let me remove this. Now we have discussed final keyword with the variable, final keyword with the method. How about final keyword with a class? Is it allowed or not? It is allowed, yes. So let me write here final. Okay, now here you can see we are getting compile time error. Why? Because when you make a class final, you cannot extend it. So if I show you the error here, it says cannot inherit from the final demo class, right? So this is the property of final class. If I remove this, you see the compile time error is over now. So this is the property of final keyword in class. If a class is final, you cannot extend it. So let me remove this, right? So we have used final keyword in all three ways. With variables, if final is written, you cannot reassign value to it. With methods, if final keyword is used, you cannot override it. With class, if final keyword is used, you cannot inherit it. So you cannot extend a class which is final. So let me take you to the visual representation. Here you can clearly see the final keyword is used to restrict modification. Okay. When we use final with variable, its value cannot change. It acts like a constant. When we use the final keyword with the method, it cannot be overridden. When we use the final keyword with class, that class cannot be inherited. So basically the final keyword will restrict the modifications in variables, method and class. Alright, next let's discuss about strings, arrays and collection frameworks in Java. Now this is really important and helpful in solving DSA problems, data structures and algorithms. So most of the tech companies have DSA round for hiring software developers, and DSA questions are generally related to arrays, strings and the collection frameworks. Let's first start with string. What is a string? So string in Java is a sequence of characters. We earlier saw the data type char, right? So if the data type is char, it means the variable will contain one character. It can be something like a, or say for example x, right? So char data type will contain only one character. But when we talk about string, it represents sequence of characters. Say for example, you have to write hello, okay, and after that space also, hello, my name is something like that, right? So this is the text. So for this you need string data type. Now we talked about various primitive data types like int, which will contain integer, then double, float, long, char, boolean, right? All of those were like primitive data types. But when we talk about string, string is an object. Now when I say object, there must be also a class, because object is an instance of the class, and that's correct because string is a class in java.lang package, right? So when we talk about string data type, it is an object of the string class. Int, char, boolean, double, long, all these were primitive data types. These are not objects, but string is an object of string class in Java. So let me show you an example of string. Okay, so here I'll write the data type first, which is string, and then the variable name, which can be say str, and then I assign the value to it. As we said, like string can contain multiple characters, so it can be something like hello, my name is Mohit Chabda, right? And then semicolon. So this is an example of string variable. Now like we said, string can contain multiple characters. It can contain one character as well. So if I write something like this is also fine. If I remove this, there is no character, this is also fine. So string has capability of multiple characters. Now there are two ways to define a string. Okay, one way is like this, you have directly assigned the value, correct? There is one more way, using the new keyword. Why new keyword? Because as I told, string is an object of the string class. So it's not like int, char, boolean, long, double. So those were primitive data types. When we talk about string, string is an object of string class in Java. Let me also show you the string class. If you go here and press the control button and then click on it, it will open this string class. You can clearly see we have this class which has name string. One more important thing here, string class is final. So you cannot extend string class, right? We discussed about final keyword. So you cannot extend, inherit the string class. But here you can clearly see string is a class in Java. Which package? This java.lang package. Okay, so going back, now this was the first way of defining the string. Let's see next way. str2 is the name I'm giving, and then you put the equal, and then you do new keyword. You remember we use the new keyword for creating the objects, right? And after that you give string, right, the constructor, and inside that you pass whatever value you want to pass. For example, hello. Okay, so maybe in the first also let's put hello, right? So these are the two ways of defining a string, whereas this way is called the way of using new keyword, right? You can clearly see we are using new here. So now you may have a question in mind. We have defined string in two ways. This is the first way using string literals, and this is the second way using the new keyword. What is the difference here? Now this is a very famous interview question, and it's very important to understand what's the difference between creating the string using literal and the new keyword. So let's go to the visual representation and try to understand the complete flow. Alright, so this first way is called using the string literals, and the second way is using the new keyword, right? So let's first understand where this gets stored. Okay, so say this is the heap memory. We talked about the heap memory, right, where the object is stored. So here we write heap. So this is the heap storage. Okay, so inside this heap storage we have one more thing, which is the string pool. Okay, so this is, say for example, the string pool. Let me put a arrow here to tell what does it represent. It represents string constant pool. Okay, so this part is string constant pool, which is part of the heap. Okay, so inside heap we have string constant pool. Now when you use this way using the string literals, then it is stored in the string constant pool, this part. Okay, inside this it will be stored. So when you write string str equal to hello, what will happen is hello will be part of string constant pool, and this variable str, right, let me write here str. So this will point to this reference. Okay, so str is pointing to this hello, which is part of the string constant pool, which is inside the heap, right? Now let's say I create one more string. Okay, so here if I put string str3 equal to hey, right, so this is a new string which is also using the string literal way, right, the first way that we discussed. So this is assigning to hey. So what will happen is a new string hey will be part of the string constant pool. Why string constant pool? Because we are doing using the wave one, right? And now what will happen is like str3 will start pointing to this reference of hey. Okay, so str is pointing to hello, which is present in the string constant pool inside the heap, whereas str3 is pointing to hey, which is present in string constant pool in the heap. Now let's say I create one more string str4, and the value is hello, which means the value is same as this one, right? str3 had a different value, but str4 has the same value. So what will now happen? Will we create a new hello text inside the string constant pool? The answer is no. So what will happen is the variable str4, this will point to the same reference. So we are not creating a new text or string called hello inside the string constant pool, because that is already present. Both str4 and str are pointing to the same reference of hello inside the string constant pool. Okay, so whenever you are creating the string using the literal way, that string will be part of string constant pool which is inside the heap, and that variable will have the reference to that string in the string constant pool. If you have a new string, of course it will get added in string constant pool, but if that string is already present, new string will not be added, variable will just start pointing to the existing string, right? So this was about the literal way. Now what about this way? When you do string name equal to new string hello, now you can clearly see both have same text hello hello. So str, str2, str4 all have hello. So will now str2 also point to the string constant pool? The answer is no. When you use the new keyword, what happens is it always creates a new object inside the heap. Now this will not go inside the string constant pool, it will create a new object. Okay, so I've created a new object here, and inside this I'll write hello. Okay, so although hello was present in the string constant pool, we did not use it because we have created the string using the new keyword, and whenever you use the new keyword, it will always create a new object here. Okay, so this is the difference. When you use the literal, it will be part of the string constant pool. If that string is already present in the string constant pool, the variable will simply refer to the existing one, whereas if the string is new, it will get added to the string constant pool. Okay, whereas if we talk about using the new keyword, it will always create a new object inside the heap that will be not inside the string constant pool, just inside the heap. So now for example, if you try to check like if str equal to str3, okay, so what will this condition return? Str has hello, str3 has hey. So of course it will return false, right? But what if we check if str equal to str4? Now str has hello, str4 also has hello. So what will this return? This should return true, right? But what if I check if str equal to str2? What will be the answer? Here str has the string hello, str2 also has the string hello, but str is using string literals, str2 is using the new keyword. What will be the answer? The answer of this will be false. Why? Because when you use equal to operator, that checks the reference, that doesn't check the value, that checks the reference. So if you're checking str with str3, both are pointing to different places. Str is pointing to hello, str3 is pointing to hey, so both are pointing to different places, and that's why it will give you false. If you check str with str4, it will give you true because both are referencing to the same place. str4 is also pointing to this, str is also pointing to this. But when you do str equal to str2, although the value is same, but str is pointing to the string constant pool, whereas str2 is pointing to the object which is present in the heap, and this is not in the string constant pool. That's why this will return you false. Okay, so we said like equal to will check the reference, right? But how do we match the values? Say for example, both of these str and str2 have the same value. How can I check the value? You can use the equals method. Okay, equals method, let me show you that. Okay, in the code you can see first way is using the literals, second way is using the new keyword. Both have the same value. Let's try to print and check if str equal to str2 or not. According to our logic, it should return false because this is pointing to the string constant pool, whereas this is pointing to the object in the heap. Let's try to see what's the answer. All right, you can clearly see it says false, right? So it returns false. Now this was false because it is comparing the reference, right? Here if I show you one more case, if I put string str3 equal to hello, and if I change here to 3, So both of these str and str3 are using the string literal approach and both have same value. So both of these will be pointing to the same reference in the string constant pool. This is what that we discussed here, right? If the value is same, both are pointing to the same reference in the string constant pool because we are using the string literal way, right? So it should return true. So let's see what does it return. You can clearly see it says true, right? But what if we want to check the values of str and str2? Instead, if we do this, it will return false, right? What if we want to check just the values, not the reference? You can use the equals method. So let me do str dot equals and inside that let's put str2. So when we do this, instead of checking the reference, it just checks for the value. So str was pointing to hello and the new variable that we said str2, str is pointing to string constant pool but the value is hello, and for str2 it's pointing to an object in the heap but the value is hello. So when you use the equals method, it will simply match the values and values have matched. So this should return true now. Let's see. You can clearly see it returns true. So when you use the equal to operator with str and str2, it will return false because it is checking for the reference and reference of the str is in the string constant pool inside the heap, whereas for str2 it is pointing to the object created in the heap. So reference is different, so equal to will return false, whereas if you use the equals method it will return true because it checks and matches for the value. Okay, so this is a very famous interview question, equals method versus equal to, and what is the difference when you create the string via literal way and with the new keyword, right? And with this we get one more understanding related to string, which is strings are immutable. Immutable means you cannot change the value of string. Now you would say, how is it immutable? I have done string str equal to hello, I can change the value str equal to no, right? So this doesn't give any error. So what's the problem? How is string immutable? I can change the value. Immutable means you cannot change the value, but I can change the value here. So what happens here is when you first do string str equal to hello, because hello is used first time here, it wasn't present in the string constant pool inside the heap, it will create the string hello in the string constant pool and str as simply reference to that string in the string constant pool. When you do str equal to no, it doesn't change the string. It creates a new string in the string constant pool and str is now pointing to this no string in the string constant pool, but hello hasn't changed. Let me show you in the visual form. Okay, so this was our heap, this was our string constant pool. When you write string str equal to hello, you can clearly see because hello was not present first, so it will create a string hello and str will point there, right? Similarly you did for many other strings. Now you write str equal to no, right? So we did this in the code, right? This thing. So what will happen is because no is not present here, it will create a new string no. Okay, and stl will not point to hello now. Okay, instead of pointing to hello, it will now point to no, right? So let me change the arrow here. Okay, it makes sense now. str is pointing to no now, but this string hello, it hasn't changed, right? Only your reference has changed. Earlier str was pointing to this, now str is pointing to this, but this hasn't changed. Okay, even if str4 is pointing to something else, say you write str4, okay, equal to say hey, right? Something like this. Now it is pointing to hey. So what will happen? Just the reference will change. Now this will also start pointing to this one. Okay, but this string hasn't changed in the string constant pool, and that's the main part. That's why we say string is immutable. That is, you cannot change the value of string. When you are updating the value of the variable, you are just updating the reference in the string constant pool, but you are not changing the actual string. That is still remaining in the string constant pool. So that's why very important thing to remember, they generally asked in the interviews as well, how strings are immutable. This is how strings are immutable, because the value is never changing of the string, just the reference of the variable is getting changed. Okay. Now let's discuss some of the common string methods. As I told you earlier, string is a class in java.lang package, so it has its own built methods. First one is length. Now this method returns the length of the string. For example, if we use the length method on this string java, it will return 4, and that makes sense, right? Because here we can clearly see 4 characters. So length method will return you the length of the string. Second method is char at, and it takes the index as the parameter, so it will return you the character at the particular index. So for example, if the string is java, and if we write java.char at 1, so basically it will return you a. Now you might say, why it is returning a? It should return j, right? But the point is, the indexes start with 0, not with 1. So 0, 1, 2, 3. Hence when you try to find out the character at index 1, it will return you a character. So you need to remember this. The index will always start with 0, not 1. If you have worked on any other programming language like C++, C, so you might be already familiar with this index concept. This is same in C, C++, that index will start with 0 instead of 1. Okay. So the next method is to uppercase. Basically it will convert the string to uppercase. For example, if you write java, here you can see everything is in lowercase, but if you use this method, it will return you java where all the characters are in uppercase. Similarly, you have one more method to lowercase. It will convert the string to lowercase. Then there is a method concat, which will join two strings. So if you do java.concat script, it will make the end result as JavaScript. Then we have a method equals, which we actually discussed, right? Instead of using the equal to, we use equals to compare the values, correct? So basically equals method will be used to compare the content. So here if you do a in lowercase dot equals a in uppercase, it will return false because the value is different. So equals will be used to compare the value of two strings. Similarly, there are few more methods that you can use in Java for string. So what you can do is like try out all these methods in your code so that you get more clarity out of it. You don't need to remember all of the methods. Basically when you will start coding, you'll get to know which all are majorly required, and accordingly you will get the habit of using those. But you can remember method like length, which will help you providing the length of the string, and method like char at is also useful because it will return you the character at particular index, and it can help you in a few cases. All right, these were the common string methods. Now if you remember, we talked about like in Java, string is immutable, which means, for example, if we have written string str3 equal to hey, and then we again write str3 equal to hello, so the string hey will not get changed. That is already present in the string constant pool, and that will not be modified. So that's why in Java string is immutable, which means string doesn't change. You can assign a new value to the variable, it will get a new reference, but the actual string, it will not change. Okay. So because in Java string is immutable, Java provides you other options as well for using the alternative of string. Okay. So this is string, this is immutable, so I have written no for mutable because the value of string cannot be changed. But one more point is string is thread safe. We will cover concepts related to multi-threading and thread safety later in this video, but for now you can just take like string is thread safe. Okay. And if we talk about the speed of the string, it is slow for many modifications, because whenever you do the modification, it will generate a new string, and the new string will be added in the string constant pool because you cannot modify the current string. So for example, if the current string was high and we added this in the string constant pool, now if you do str this plus some new value, say for example you add friend to it, okay, so it will not modify the current string, it will add a new string. Okay. So that's why the speed of string will be slow for the case when you are doing many modifications. So when you are solving like DSA related problems, you can use string if you are not going to do much of modifications on it. But just in case if you have to do many modifications to the string, there are better alternatives to it. First one is like string builder. This is frequently used if you have to do like a lot of modifications. So the good part is this is mutable, which means its value can be changed. It's not like the string where you cannot change the value of string. Whenever you are making the modifications, a new string is getting added in the string constant pool. Nothing like that. String builder, you can update, modify its value. Okay, but the only thing is it is not thread safe. We said like string is thread safe, which means if multiple threads are trying to use the string, it provides that thread safety, whereas in case of string builder it is not thread safe. The speed of string builder is fast because you can modify it, right? But because it is not thread safe, it is used for single threaded apps, because if multiple threads are trying to modify and use the value, there can be issues, right? So the use case is if you have to do many modifications but single threaded apps is fine for you, you can use the string builder. And the other alternative is the string buffer. This is also mutable, which means you can modify, change the value of string buffer. And the good part is it is thread safe as well. Okay, but of course, because now it takes care of the thread safety, it is bit slower as compared to the string builder. And the use cases, it can be used for multi-threaded apps. Now I understand, because we have not talked about like thread safety, multi-threading, all those concepts, so it might sound weird to you for now. But don't worry, we will cover about the multi-threading and thread safety concepts later in this video. So this was about string in Java. Now next, let's talk about another important concept, which is array. Okay, so first question is, what is an array? Now to understand array, let's take a real life example. All right, say for example you have like multiple DVDs at your home, right? And one case can be like all the DVDs are present at different locations, so it is so difficult to manage those. Like everywhere you go you see a DVD and it's so irritating, and when you try to find a particular DVD, it's so difficult because these are like present at different places at your home. Now what you want is like to organize it well. You have purchased something like a DVD keeper. Okay, it is something like this box, right? And it has many placeholders. In each of the placeholder you can keep one DVD, but it is made in such a way that you can only keep DVDs in it, nothing like you are keeping any other stuff in it. So this is a particular kind of DVD keeper, you can say, that you purchase online from some website. Okay, now it makes things easier for you because you can keep all of your DVDs in one place and it is well organized, and you can clearly see you can keep the first DVD here, then the second DVD here, then the third one, and like this you can keep all the DVDs. We have kept each near to the next one, so in that way you can simply go through all the DVDs when you are trying to find out a particular DVD, right? So in this way this is very well organized, and everything is near to each other. When you go to the next, you'll see the next DVD like this. It makes things quite easy, right? And each of this placeholder only contains DVD, right? So this is a kind of real life example of array. How? Because an array is a collection of elements, like we said, like collection of DVDs here. So array is a collection of element. Now element can be anything, like we discussed about the primitive data types. So array can have like integers, multiple integers we can keep in array. We can also keep many doubles in it, which can contain decimal values, or many strings in it, many characters in it. But the main part is all of these elements will be of same data type. So if you are keeping integers, so all will be integers. If you're keeping doubles, all will be doubles. It won't be the case you are keeping integer here, here you want a string. No, this is a DVD keeper. So in this you can just keep the DVDs, nothing else. And that's good also, right? Because when you are searching for a particular DVD, you will only see DVDs here. If you keep all various kind of stuff in this, it will again make things confusing. Like one time you are seeing DVD, then something else. So it is not that organized. So array is like collection of elements of same data type. Data type can be like anything, like integer, character, boolean, string, or even the complex data types, which we will see later. But the main part is collection of elements of same data type, right? So if you are keeping integers, all of the elements will be integers. And another property of array is these elements will be stored in contiguous memory locations. Now what does that mean? You can compare that with this example. Here you can see in this placeholder we have kept a DVD. In the next placeholder we have kept another DVD. So it's kind of like when you go to the next placeholder you will see one more element. So it's kind of contiguous. You can say each placeholder has a DVD. So it is next neighbor element, you can say next. When you go next you'll see another DVD. So it's not like one DVD is here, second is here. It's like neighbors to each other, continuous. So first here, second, third, fourth, fifth, like this. So just like we saw in case of string, right? We were able to calculate the length of the string and we talked about the indexes there, right? So here also, for example, if you see 1 2 3 4 5 6 7, so the length of this array will be 7, right? So it can contain 7 elements. But if we talk about the index, so index here also start with 0. So the first element will have index 0, not 1. 0. Okay, remember this. This is same across multiple programming languages, that index always starts with 0, not 1. Okay, so the first element has index 0 and the second will have 1, then 2, then 3, 4, 5, 6. Now because we started with index 0, the seventh element will have index 6, which clearly means if there are n elements, so the index of last element in the array will be n minus 1, right? Because clearly you can see 7 elements, last index is 7 minus 1, which is 6. Why? Because the first element had index 0. Now let's see through code how can you declare and initialize an array. Okay, so here we go. So here is an example of declaring an array, right? So how do you do that? First of all, you write the data type. We said that array is an collection of elements which are of same data type, right? So first you have to define data type. So here we are saying int, which means the array will contain integer elements, and after the data type you write these brackets, which means we are talking about array. So this is the speciality of array syntax. So this represents that we are talking about array. So it means array is of data type int, which means array will contain many elements, all of are of type int, which means it contains integer elements. Okay, and then you write the name of the array. It can be anything that you want to write. Okay, after that we have this assignment operator, which is equal to, then you write the new keyword. You remember the new keyword, we used it for creating the objects, right? So it will be also used when you are creating the array. So you write the new keyword, then again the data type, and then in this bracket you define the size of the array, and then of course you have the semicolon. So this is how you declare an array. Now why have you defined the size? Because if you see this example, like we defined it like this, DVD keeper is of size 7, right? So like that only you have to tell the size of array. You cannot change it. For example, you purchase this DVD keeper, right, of size 7. Now say you want a DVD keeper which is of smaller size or bigger size, which can contain more DVDs. So you can't change this one. You have to purchase a new one, right? So you cannot modify this one. So in the similar way, you have to define the size of the array in the beginning, and you cannot modify that. So if you want to keep 5 elements, you define that you want an array of size 5, right? So this is how you can declare the array. If the data type is something else, for example, instead of integers you want to keep like decimal values, then you will define here double. Here double will come, also here double will come, right? And after this, say you want to put value inside any of the index of the array. What you can do is you can use the index. You can treat it as like a book. Like in book you have the number, page number, right? Similarly, index is acting like the page number of this complete array. In the book as well, it's sequential, right? You have the page number sequential. Same to that, we have the sequential numbers here. Only the main part to remember is the index will start with 0. Okay, so say for example you have to put some value here. Okay, so how will you put it? You will use this index. How? Let me show you how through code. Say we wanted to put at index 0. So what we will do is like array name, then this brackets. Inside the bracket you put the index number. Okay, So 0 means first element because index start with 0 in Java. So this represents first element. So you put index 0 and then you assign the value. Here we have assigned an integer because we have said like we want the data type integer, which is int. So in the beginning you might feel like it's quite weird as a syntax, but don't worry, when you start using it you will get used to of it. Okay, but this is the way you declare the array. Here you can clearly see you have mentioned the size of the array, and this is how you initialize. You put some value at a index. Okay, there is one more way where you can declare and initialize the array in one go, and that way is like this. You can clearly see this part is exactly same. You first define the data type, then you put these brackets to show that we are talking about array, then you give the array name, then equal to operator, which is the assignment operator. But now instead of writing this, we are directly providing the values. Okay, so how do you provide value? You will use this kind of bracket, and inside that you will provide the value. Here you can see we have provided the value. We have mentioned here 4 numbers, so size of this array will be 4 because we have defined 4 elements only. And then you have the semicolon, which represents end of the statement. So this is how you declare and initialize the array in one go. Here basically you declared the array and then we simply put the value at one index, but here we have defined value at all of the indexes in one go. So when you are initializing alongside declaring, you don't need to write this because automatically it knows like size is 4, so it will do the memory allocation automatically. Now as we have indexes here, right, we use the index to put some value as well. Index will also be used to fetch the value. Say for example, if you want to fetch the value present here, what you will do is like use the index of that location. Okay, and that will help you provide the value. Let me show you how through the code. So you can see we have declared and initialized this array. Now I want to get this value, right? So how can I get it? Use the index. Index starts with 0, so here the index will be 0. Here the index will be 1, so we want the value which is present at index 1. So let's use that index. So what I'll do is like write system dot out dot println, and then I'll write array 2, and then you use these brackets and then put index 1. Okay, so what this will do is like fetch the value at index 1. So this is index 0, this is index 1, index 2, index 3, because there are 4 elements, so the index at last element will be n minus 1. So 4 minus 1, which means 3, and when we said like 1, this is what we should get. So it should print 20. Let's see if it prints 20 or not. All right, you can clearly see it prints 20. Okay, so using the index you can fetch the value. Using the index you can also store the value. So indexes are really important. Okay, now you remember in string we use the length method, right, to calculate the length of the string. But how do we calculate the length of an array? Let me show you how. So what we will do is like use length only, but the only difference will be this time it will not be a method. So you will write array 2 dot length, but I am not adding two brackets after this because length is not a method, because array is not a class. String was a class and that's why it had methods, whereas length is just a attribute or property. Here you can clearly see when I move the cursor here, it will say public final int length. So it's a variable attribute, you can say. For string it was a method, as string was a class, but here we have this simple property. So because there are 4 elements, this should return 4. Okay, so let me comment this out. Let's just print this one. Let's see what does it print. You can clearly see it prints 4, and if I put arr.length, in this case it should print 5 because we declared the size of array was 5. So let's see. All right, you can clearly see it prints 5, right? So length method will give you length of the array, which means what is the capacity of array, maximum number of elements which can be present in the array. Because here if you see, we have put only one value, right? But length represents the maximum capacity of array, which means maximum number of elements which can be present in the array. So here we declared array with size 5, which means maximum 5 elements can be present in the array. So that's why it returns 5. Although we have not initialized all of the elements yet, still it will return 5. And here in this case, because we initialized and declared in one go and there were like 4 elements, so it will return length as 4. Now we can clearly see we are using the index to put the value in the array or also to fetch the value of an element of the array. But here you can see we did for one element. What if we want to get or fetch the value of all the elements of the array? Will you write like 4 print statements here because there are 4 elements? What if there are 10 elements? Will you write 10 print statements? No, we will use loops, right? We discussed about loops earlier in this video, which helps us doing the redundant tasks, right? So here also we are just printing. Instead of printing each and every index using the print statement, what we can do is like use the loop. So let me remove this and let me write the loop. Okay, so what I'll use is a for loop. For int I equal to 0, I is smaller than, either you can directly define 4 here because you know the size of the array, but just in case you want to keep it like generic, you can make it 2 dot length, right? Because we know this will return the length of the array. Okay, and then you will have I plus plus. So basically I is acting as your index. That's why I started it with 0, because index in arrays in Java basically start with 0. Correct? We discussed that here it starts always with 0. So here this I is acting as my index and it is starting from 0, and I said it smaller than the length because the index of last element will be n minus 1, right? So it's like smaller than, or if you want to keep equal to, then you have to write I is smaller equal to arr2 dot length minus 1, but this is also fine. Okay, and then you'll put your brackets like this and you will simply print system dot out dot println and you will simply do arr2I, right? So basically using this you will print all the elements of the array. So instead of print, let's use println so that we get next line for each of the element, right? And let's try to print this. What does it print? All right, here you can see it prints 10 20 30 40, 10 20 30 40. So using the loop you can traverse through the array, you can print the elements, you can put the value, you can do whatever you want to do. The basic funda is using the loop you can traverse through the array. So clearly you can see the role of index in array. Using the index you can reach to any location of the array. It's not like first you have to go to 0, only then you can go to 1, okay, and then 2. If you want to go to 2, you can directly go to 2 using this index. You can simply put arr2 and put the index as 2. You will directly reach here. So that's the great part. In real life example, if you think of, in the book everything is sequential, right? Everything is like neighbor. If you do the next page, you go to the next thing, right? So similar is in array, right? In book also you have the page number. If you have to go to page number 20, it's not like you have to go one by one. You can directly go to page number 20 because you see the page number. You can directly go to page number 20 like that. And same is the case of array, because you know the index number, you can directly go to that element. So that's the benefit of array. You don't have to traverse one by one to reach a location. You can reach to a location directly using the index. That's the biggest quality or the advantage of using the array. Okay, just as compared to the page number, you need to keep in mind that the index starts with 0. So the first element will have index 0. That's the only thing. Rest you can compare it completely with the book and the page number as the index, right? So like we discussed about this array, basically this is 1D array or one dimensional array, because you can see it is only in one dimensional. We are talking about like horizontal, right? In similar way, we can also have a 2D array, which will be in two dimensions, the horizontal and the vertical. Let me take you to the visual representation where we'll get more idea. Here you can clearly see we discussed about like one dimension. We were talking about the horizontal level, right? And then we can also have a two dimension like this and this. Okay, so what we will have is, you can say, a matrix. So something like this, you can say we are keeping three columns. Okay, so 1 2 3, and then we are keeping like four rows, 1 2 3 and 4. Okay, so this is an example of 2D array. So there are few things which will keep same as 1D array. Here also you can see it has like many elements, right, like this. And one more thing is like the data type of all the elements will be same here. Okay, just like we discussed in 1D array. Now this will also have the indexes. Of course horizontally you can imagine the same. It will have like a 0 here, 1 here, 2 here, because index starts with 0. Vertically also it will have indexes. So this will also start with 0, 1, 2, 3, right? So you have rows and columns. So you can just imagine a table, or like you can say the Excel sheet, anything like that you can imagine. This is also called a matrix. So 2D array can also be called as a matrix. So here you remember, if you have go to this element, how do you reach it? Using the index, you will say array name, and in the brackets you will put 3. But how will you reach to a particular element? Say for example here, you will reach using combination of these indexes. So how? Basically this is like 0 0, and this will give you this element. This is 0 1, because this row represents 0, this column represents 1 index. So then this one is 0 2. Okay, then this one 1 0, because row is 1, column is 0. So first you represent the index of row, then the column. This is 1 1, this is 1 2, right? Then this one, this is 2 0. The second index is representing the column, and all of these are 0. This will be 2 1, right? This will be 2 2. Okay, this will be 3 0, 3 1, 3 2. So using this index you can find the value present here. This is not the value, I'm just telling you, using these index like 0 0, you will find the value which is present at this particular location. If you wanted to get value at this particular location, you will use array name, and in the brackets you will put like 2 1. So for example, the array name is ARR here, and if you want to find out value here, it will be ARR, then this bracket you will put first 2, which represents the row index, and then you put one more bracket here and you put 1 here, which is the column index. Okay, so this is how you will find out the value present here. Here you just simply did like, if the name of array was say ARR A, and then in that you simply put 3. Here you were talking about only one index because this was 1D array, but here this is a 2D array, so you are talking about two indexes. First index represents the row, second index represents a column. Okay, so this is how you will use this 2D array. Let me show you an example of 2D array in the code. Here you can see we have done the declaration and initialization of the 2D array in one go. First you write the data type, what is the data type of the array, then you put these brackets. Okay, we used to put only this for 1D array, but because this is the 2D array, so you put two of such brackets now. Then you put the array name, 2D array name, then you put the equal to, which is the assignment operator, then you have this bracket where you define the array, and clearly you can see this is how you define the array. Earlier there was only one bracket, right? Like this you defined it, but because there are multiple entries now, you have to define it multiple times like this. This is representing your first row, second row. Okay, this 1 and 4 represents your first column, second column, third column, and like this you can define multiple more. So this 2D array has like 2 rows and 3 columns. Okay, so there are total like 6 elements, 2 rows, 3 columns. Okay, what will be the index? 0 0, 0 1, 0 2, 1 0, 1 1, 1 2. So if we try to find out value present here, what we will do is like array name, then you put the row index first, then the column index. So 1 2, so this one it should return 6. Let's see what's the output. Clearly you can see it has returned 6. Okay, so if I have to show you in the visual representation, it will be something like this. Okay, you have to create array here because we mentioned like 2 rows and 3 columns. So something like this. This is, yeah, 2 rows, 1 column, 2 column and third column. Okay, so the array name is matrix. We kept it matrix. You can keep anything. Okay, and then the indexes, it will be 0 1 2 0 and 1. Now this cell represents 0 0 0 1 0 2 1 0 1 1 1 2. Okay, so now let's see what all values did we keep. 1 2 3 4 5 6. So let's put that here. So 1 2 3 4 5 6. So basically this thing, okay, actually represents this thing. Okay, so now if you are trying to find out like matrix 1 2, so what does this mean? It basically means you want to go at row index of 1. So row index 1, so this row. Okay, then you want to go at column 2, row 1 column 2, so it should return 6 as the answer, right? So basically this was an example of the 2D array. Now when you start using it, you'll get more clarity about it. So you can write one code on it and just try to traverse through the array. Like how would you traverse here? You will use the nested loop. Earlier we used one loop for int I equal to 0, I is smaller than array dot length I plus plus we did. Now you have to use a nested loop. Inside one for loop you will have one more loop. Okay, because we need two indexes now, one for row, one for column. So this one is for row, this is for column, right? We have already discussed about nested loops in this video, so try doing that and you will have fun actually trying to identify how do you traverse through this 2D array. Now basically you remember in array we mentioned that it will have like a specific size. It will have a predefined size which is fixed. You cannot change it. For example, here we said like this is 1D array of size 7, right? So it means that you cannot change the size of this array. If you want like more elements, like you want the size 10, you have to create a new array. You cannot modify this one. So that's why you lack that kind of flexibility in array. But what if you want like flexible things? You don't want to define the size in the beginning, right? So we want dynamic, resizable and powerful data structures. So for that we have collections. So here are the collections in Java. Okay, first category is list. Now the quality of list is that it is ordered. Like for example, we were talking about array here, like one by one, right? All the elements. But the problem was that size was predefined. So we will have a list which will be ordered, or you can say sequential. And like in array, you could have duplicates. So list will also allow you duplicates. Okay. So in this category of list, you have few types. First is array list. So you talked about array. Now we have array list, which will be more dynamic. You don't need to predefine the size. This is dynamic. This has the qualities of array, but at the same time, this is dynamic as well. Next in the list you have linked list. Then you also have vector or stack. Then the next category apart from list is set. The quality of set is that it allows only unique elements. Okay, so it would be something like, say you put the value 2, you kept the data type as integer, so I'm putting 2 here. So it cannot have another element of value 2. This is not allowed. It will have only unique elements. Okay, so inside set we have hash set, linked hash set, TreeSet. And then the third category in collection is map. The quality of map is it is key value pairs. Like for example, this is a key and corresponding to it the value is this. So key value pairs you will have. Like for example, my name is Mohit Chabda, so I'll write here for example Mohit, and corresponding to it in the value I have kept the URL of my YouTube channel. Okay, so key value pair. So this is the key, this is the value. So inside map you have HashMap, LinkedHashMap, TreeMap. So because these are kind of advanced concepts and you might not be using in the very beginning of your Java. So we will not discuss in too much detail about each of these, but I'll show you some of the examples through which you'll get some clarity, like what is the use case of this. Okay, so first let me show you the code example of Arraylist, because we discussed about arrays. Let's see an example of Arraylist through which you'll see, okay, this is why we require the Arraylist, right? So here is an example. So first of all, you can clearly see we have used Arraylist here. For using the Arraylist, first you need to import, okay, because this is not part of your package. So you'll use the import keyword and then you use the package. So it comes under java.util.arraylist. So basically this is under java.util package. Inside that we have imported Arraylist specifically. We have not imported all the things inside this java.util package, but of course if you want to import a lot of things you can do star here. Okay, it will import all of the classes inside this java.util package, but if you want to use only one, so you can do something like this. So you are importing specific class in this java.util package. Okay, and if I don't write this, you will see there are compile errors, so you need to import it first. So here we have imported it, and then you can use Arraylist. You can clearly see this is the name that you need to use. It is very similar to array actually. Okay, so first you need to write Arraylist and then you need to tell the data type. Okay, so here in these angular brackets, for example, we have mentioned string. So this list, which is Arraylist, will be type of string. Okay, and then you write the name of the array list, whatever name that you want to give, and then you have the assignment operator, which is equal to, again we use the new keyword because there will be memory allocation, and then you again write array list and then these brackets. Okay, so this is how you basically declare an array list. Now clearly you can see it is quite similar to array. There you first define the data type, like we define the data type here, but before that we write array list, and similar to the array name we write the array list name, equal to operator, new operator, then array list we write. There you used to tell the data type, like you used to write int and then brackets, but that is not required here. You will simply write array list here. We have already defined the type here. The good part is when you are declaring the array list, you are not giving the size of the array list, right? Clearly you can see we have not mentioned the size of the array list, which means this is dynamic. You do not need to provide the size at the beginning. That's a quality here, because in array you had to tell the size when you are declaring it, right? It was something like it is not dynamic, but here Arraylist is providing you that dynamic feature. Okay, and then if you have to add an element, you can simply use the add method. Now this is a method because Arraylist is a class. Let me show you. If you click it here, it will show you public class Arraylist, right? So clearly this is a class. It has its methods which we are using. And one more thing that you can clearly see, it implements list. So basically list is an interface. We saw here list, right? List is an interface. Array list is a class. Clearly you can see here array list class, and it implements list, which is an interface. Okay, right? You can clearly see a lot of concept that we have already covered. We talked about extends, which is part of the inheritance. So it extends only one class, because you cannot extend two classes in Java. You can extend only one class, but you can implement many interfaces. So here you can see it is implementing 1, 2, 3, 4 interfaces, right? So you can implement multiple interfaces but extend only one class. So this is array list. So this has the method add, through which you can add element in the array list. How will it add? It will add sequentially. So first element with index 0 will be Java. Then when you are adding, it will be the second element with index 1. The value is Python. Index 2, C++. Index 3, Java again. So here you can clearly see you have added duplicate, that is allowed in list. You can do that. Okay, so now here we have tried to print the list, and we have also tried to remove an particular element, right? So we have just said like remove C++, and it will remove that. Then we have also used one of the methods of this array list, which is contains, which tells whether this complete list contains Java or not. So let's try to print the answer of all these. Okay, so clearly you can see, first of all, when we do system.out.println list, it has printed the list. This is your list. First Java, Python, C++, Java, right? This is how we added it, and that's why it has maintained all that sequence or order. right? The next thing, we removed the C++, so basically it will remove this part, correct? And the next thing, we simply check whether list contains Java. It contains twice actually, Java here, so it will return true, right? So this is how this will work. So this is an example of array list, right? So the good part is you do not have to define the size, but here if you see, we have done like list.remove C++. So what it will do is like go through each of the elements sequentially. First it will go here, it will not see C++ here, it will go to the next element, C++ doesn't match, again go here, C++, then it will remove this because we have found the match. So when you do something like this, the operation will be bit slow, right? Because you are moving through each of the element and then comparing the values, and in case the match is found, you perform the operation. So in that way it can be a bit slow, right? So this was an example of array list. Next, let's see one example of linked list as well. All right, so this is an example of linked list. Okay, so first of all, you can clearly see I have imported linked list class here from the java.util package. Earlier we imported the array list class. Now because we are using linked list, so we'll import the linked list class. Of course, you can do java.util.star. In that way, it will import all of the classes which are present in the java.util package. Okay, so as we saw the array list class, linked list is also a class. Here you can clearly see public class linked list. It also extends one class and it implements list and many other interfaces as well. So as I told you earlier, array list, linked list, stack, vector are subcategories of list. List is an interface, array list, linked list, stack, these are classes. Okay, so in a very similar way to what we did to array, first we'll write linked list, then in the angular brackets we'll define the data type. It can be anything, integer, double, long. Here you can see we have not defined int in small. Okay, so we have defined integer because linked list is a class which takes the data type which is not primitive. We talked about like int, double, long, all of these as the primitive types. So corresponding to those, we also have like the wrapper classes. So a class corresponding to the int data type is integer. So let me show you. You put the control and the click on it, you see integer is a class. Okay, int was not a class, that was primitive data type, but if we want class corresponding to int, we can use integer. This is a wrapper class. Okay, so similar to this, you can also have something like double. Okay, this is also, you can say, a wrapper class corresponding to the double primitive data type. Now why is it showing error? Because double has decimal and we have added the integers here corresponding to integer, but if you write 10.0 it will be fine. Okay, so but the point is, when we talk about collections, they don't take the primitive data type like this. Okay, this is not allowed. You can clearly see it says type argument cannot be of primitive type. Okay, you cannot use primitive type here, you have to provide like class here. So for that you can use the wrapper classes like integer. Similarly, I displayed you can use double here, long here, string here. Also for boolean you will have like boolean like this. Okay, so these are the wrapper classes. So all the places where you cannot use the primitive data types like int, so you can use their wrapper classes like integer, right? So linked list, you provide the data type inside this, then you write the linked list name, then the equal to assignment, then new linked list. Very similar to what we did with the array list, right? Very similar, just instead of array list we have mentioned linked list. Now it has methods similar to array list, like add method we checked. This one also has add, few other methods as well, like add first, add last. You don't need to remember all of these. When you are coding, you can simply do something like list dot and it will provide you all the methods that you can use. Okay, yeah, of course, like some of the important methods you should remember. Say for example, when we want to calculate the length of the list, you remember in the array you had an attribute named as length. Okay, in string there was a method named as length. In these collections you don't have length, you have size. Okay, you can clearly see here. So this size method provides you the length of the collection, or here the linked list. Okay, so this kind of method you should remember, but apart from that it's totally okay. You can simply use the IDE and it will help you. Okay, so here you can see first we added like 10, then we use the method add first. So basically it will add 5 in the beginning instead of like after 10. So generally if you use the add method it will do it sequentially, right? But here we have used the add first, so 5 will come before 10. And then we have this add last method, so it will put this method in the end. So it should print something like 5 10 15. Let's see what does it print. Okay, you can clearly see it says like 5 10 15. In case I remove the first, if I make it simply add, then it will be 10 5 15. Let's see, clearly you can see 10 5 15. So based on whatever method you used, it can do that kind of work. But this was an example of linked list. All right, so we discussed about list. Now if we talk about set, the important part of set is that it will have unique elements. But then you have hash set, linked hash set, tree hash set. What is the difference? So basically set is an interface, just like list which is an interface, set is also an interface. Hash set, linked hash set, tree set, these are classes which implement the set interface. Okay, so talking about the hash set, it is unordered. Okay, and when we talk about linked hash set, it is different from hash set, as this is ordered. And when we talk about the tree set, it has one more property as compared to linked hash set, which is the elements are actually sorted. So tree set will be used if you want to sort the elements. Okay, of course set is used when you don't want any duplicates. So if you want all the elements to be unique, you use set, right? Inside set you have various classes like hash set, linked hash set, tree set. So when we talk about hash set unordered, linked hash set is ordered, tree set is sorted. So all the elements are sorted. When we talk about duplicates, because we said that the set interface will have only the unique elements, no duplicates. So in all of these hash set, linked hash set and tree set, no duplicates are allowed. Okay, and when we talk about sorted, only the tree set will provide this feature of sorted elements. Rest in hash set and linked hash set, it won't be sorted. So basically you need to remember set is there for unique elements, hash set unordered, linked hash set ordered, which means it will maintain the order, tree set will give you sorted elements. Okay, now let's see one of the example through code so that you get more clarity. Here you can see we have used hash set. Now instead of importing each and every class, I have done like import java.util.star, which means it will import all of the classes which are present in java.util package. Okay, so very same structure syntax that we used for list, array list, just here we are using hash set. You can see I've used set here and hash set here. How am I able to do that? Because hash set, if you see the class, it basically implements set. Okay, so hash set is a subtype of set, right? So you can write set and then here hash set. This is what we learned in runtime polymorphism, right? Because set is kind of parent and hash set is child or subtype of set. So this is allowed. You can also write something like hash set here. This is also valid. But if you don't write hash set here, you write the base interface here, that's also fine. Okay, so basically the syntax is quite same as we checked in the linked list and the array list, just that we are using hash set here. And then add method is also quite same, like we use the add method in the array list and the linked list. But the only difference is if you try to add the duplicate, for example here we added java first. Earlier there was no java present in the set, so that was totally fine. But again, if you try to add java which was already part of the hash set, what it will do is like it will simply ignore it. So it will not add one more element named as java. So let me show you how. If you try to print this set, it will simply give you java and python. It will not give you two javas and one python. It will just give you one java, one python. Let me show you. All right, clearly you can see it says java and python. And if you try to add any duplicate in it, it will simply ignore that. No compile errors, no issues. It will simply ignore the duplicates. Okay, all right, so this was an example of set. We have already discussed about the list and set. Now if we talk about the map, quality of map is that there will be key value pairs, and then inside it has classes like HashMap, LinkedHashMap and TreeMap. What is the difference? So basically when we talk about map is an interface, key value pairs, but when we talk about the categories, first when we talk about HashMap, similar to what we discussed about in the set, like HashSet was unordered, LinkedHashSet was ordered, TreeSet was sorted, same to that in map also. HashMap is unordered, LinkedHashMap is ordered, TreeMap is sorted. So very much similar to the things that we covered in set, right? Now one difference is about the null keys. So when we talk about the hash map, it can contain the null keys. When we talk about the linked hash map, it also can contain the null keys. But when we talk about the tree map, there cannot be any null key, which makes sense, right? Because tree map is sorted. So if there is null, on what basis will it sort? So null keys are not allowed in tree map. And of course, if we talk about sorted, only the tree map is sorted, whereas these two are not sorted. So this part very similar to what we checked in set. One more thing was like hash map and linked hash map allow null keys, but TreeMap doesn't allow null keys. Now let's see one example of map through code so that you get more clarity about it. Here you can see we have used hash map. Okay, you can write map here or hash map, it's totally fine. This is an example of runtime polymorphism. If I show you the hash map class, basically you can see this is a class which implements map. Okay, and here you can see it has kv, which means key and value. Okay, because map, the quality is it maintains key and value, right? So because it has key and value, you need to define the data type of both. Earlier we used to had only one data type. Now we need to define two data types. First one for key, second one for value. So this represents a key which is of data type integer. This represents a value which is of data type string. Okay, so here if you want to add a value, you will use this method put. You are putting in the map. You will write the map name dot put, and then this is the key. Say for example we used integer, so 1 here, and then value which is a string. So corresponding to 1 you have Java, corresponding to 2 you have Python, corresponding to 3 you have C++, right? So first we are trying to print the complete map, then we are trying to get the value which is corresponding to the key. So what we will do is like map dot get. So get is the method to get the value, and we provide the key here, right? We provide it to, it will return Python because it is key value pair. So you provide the key, it will provide you the value. So using this get method, then we also did this removing part. So we provide the key there, so corresponding to this entry will be removed, and again we have printed. So first when we print, it should show 1 Java, 2 Python, 3 C++. Then when we do map dot get 2, so corresponding to 2 we have Python, so it should print Python. And when we remove 3, again when we print, it should simply print 1 Java, 2 Python. It should not print 3 C++ in it. So let's see what's the answer. Okay, clearly you can see first it says 1 equal to Java, 2 equal to Python, 3 equal to C++, right? So this is the map which it printed. Then for this one it printed Python because we provided the key as 2, so the value was Python, so that's why it printed Python. And next when we remove with the key 3, this entry will be removed, and then when you print it, it will simply say 1 Java, 2 Python. Now it will not say 3 C++ because that has been removed, right? So this was about the hash map example. So we covered like list, set, map in brief. So if I also show you some of the utility classes, collections is the class which is used for doing things like sorting, searching, reversing. Okay, so for example, if you have to sort the list, you will use this utility class collections. Okay, this is the utility class for collections like Arraylist, LinkedList, set, right? But if you want to do all such kind of things for array, you can use arrays. Okay, because collection is like list, set, maps, right? But array was not a collection. So for that, if you need to perform sorting, you will use arrays utility class. Then we have few more things like comparator, iterable, but I think we can skip all of these for now because these will be required in the advanced stage. As you learn, as you practice more, you can read more about these concepts, but for now you can skip these. So let me briefly show you an example of using the collections class. Okay, so here is an example of using the list. This is one of the ways where you can initialize the list alongside declaring it. You can clearly see it has elements like 5 2 8 1. Okay, and then basically, because this is a collection, we are talking about the array list. How do you sort it? Because this is not sorted. Say you want to sort it in the ascending order, so you can simply use the utility class collections. So you can do collections dot sort. Sort is a method of utility class collections. Okay, and then inside that you can pass the your array list or whatever collection you have, and then if I print it, it will show something like 1 2 5 8. Let's check that out. Clearly you can see it has sorted the collection. So this utility class makes things so easy for you. You don't have to write the complete logic for sorting. Otherwise, you have to write the code for sorting a collection. But here, using the collections class and using this method, you can directly sort it in one line, right? So let's also see one example related to array. If I want to sort it, say for example, this is our array. You can see this is not currently sorted. If I have to sort it, what can I use? For the collection, we use the collections class. For array, we can use arrays class. So we'll use arrays dot sort, and then we'll put the array name inside this. Right now we want to print this, so I can apply a for loop here. Int I equal to 0, I smaller than arr dot length, then I plus plus, and inside this I'll simply do system dot out dot println and arri. Right, so basically we are printing the array now. Commented this out because we don't want to see the output of collection. We are focused only on the array for now. Let's see what the output is. You can clearly see the sort method has sorted the array. Now instead of 94317, it is returning the sorted values like 13794. So you can clearly see this utility class arrays has a method sort which has sorted our array. If I go to this class, you can clearly see this is a class. Okay, and it has this method sort. Right, so this was an example of the utility classes. Yes, we did not cover all of the things in very detail, but I think this is good for now. In the beginning, you can try out some of the examples so that you get more clarity about it, and later once you get more idea about Java, you can go through the advanced concepts, right? And you can also see how much they are being used in your code and everything, and based on that you can learn more concepts or do a deep dive in that. All right, now let's discuss about exception handling in Java. The first thing that comes into our mind is, what is an exception? In Java, an exception is an unexpected event, okay, that occurs during your program execution. Like your code is running and at that time something unexpected happens which will disrupt the normal flow of your program. Say for example, this was your some code and it was going perfectly fine smoothly, and then there was something unexpected that happened and that disrupted your complete normal flow of the program. That is an exception, which means some problem, some issue happened. Now for example, in real life maths example, if you divide 5 by 0, what is the output? This is something unexpected. You can say infinite or anything like that, but this is something unexpected or exceptional, which is quite like different from your other scenarios, because 5 divided by 1 is 5, 5 divided by 2 is 2.5, but 5 divided by 0 is something very unusual. And in Java, if you do something like this, 5 divided by 0, this will give exception, okay, and that will disrupt your normal flow. Let's go to code and see this example what I'm talking about. Say for example, we have int a equal to say 10, okay, and then we write system dot out dot println. Let me print a only here, right? So if you run this, it will simply print 10, correct? Let's see. Okay, you can clearly see it prints 10 here. But say before printing 10, what I write is system dot out dot println, and let me write a divided by 0. So now what will happen? Let's see what happens. Let me run this program. and clearly you can see it did not print this line, right? It did not print 10. It said exception in thread main. You know, main is the main thread of Java, right? And it says there is an exception, okay, and which is arithmetic exception. Why arithmetic? Because it's like maths related operation, so they have given it name related to arithmetic exception, because you are performing the arithmetic operations here, which is like addition, subtraction, multiplication, division. So that is named as arithmetic exception. But the main part is we got an exception, right? And it also gave the reason. It says like division by 0, okay, and it also provides you this line number. If you click here, it takes you here, like when you do a divided by 0 or 10 divided by 0. So you can clearly see there is an exception. Now what exception is? Something unusual, right, which disrupted your normal flow, because the normal flow was after this you run this and then you run this, okay? But when you got this exception, this line or this statement did not actually run, correct? You did not get 10 here, so it disrupted your flow. So this is basically an example of exception. So basically when Java gets an exception, it stops the normal flow, because the normal flow was after this you run this statement, but it stops it here when it gets the exception. And then you can clearly see it has created an exception object, and you can see that exception part here, right? So this is a very basic kind of example of exception. Now let's go back to the visual representation and let's see the types of exceptions. So in Java, we have two types of exceptions. First one is the checked exceptions, which happens at compile time. And the second type is unchecked exceptions, which happens at runtime. Now we mentioned compile time with checked exception. It means that these kind of exceptions can be checked and can be identified at the compile time. Whereas the unchecked exceptions, these happen at the runtime, so they cannot be identified at the compile time. Now because the compiler can identify the checked exceptions at the compile time, it forces you to handle that. Whereas the unchecked exceptions cannot be identified at the compile time. They happen when you are basically running your code. So basically checked exceptions, these are checked at the compile time, and these must be handled. Why? Because these are identified by the compiler at the compile time. So the compiler will force you to handle these exceptions, and you can handle these using the try catch block. We will talk about it, don't worry about it. Or it can be declared with throws. So we'll discuss both of these later in this video. But some of the examples of the checked exceptions can be IO exception, SQL exception, file not found exception. Now when we talk about unchecked exceptions, basically these occur at the runtime, so during the execution. So the compiler won't be able to identify these exceptions during the compile time, and it will not force you to handle these exceptions, because compiler doesn't even know this is an exception. That's why it's an unchecked exception, and that's why the compiler cannot force you to handle it. Some of the examples of the unchecked exceptions are null pointer exception, which means, say for example, you have created an object obj, okay, and you are writing obj dot, says there is some method, okay, obj dot method, and you have called this. But at runtime we got to know that obj was null, okay. So when you are doing null dot calling the method, it will result in null pointer exception, because you are calling a method on a null reference, right, which is not allowed. So it will give you null pointer exception. But the compiler was not able to identify it, because say you got this from some other class or some API, or using some method you got this, and you cannot tell whether it's null or not null. So basically at runtime you got to know this was null, and you are making a call on a null reference that will result in null pointer exception. One more example is arithmetic exception, which we saw in the code, right? Here you can see we did a divided by 0, and the compiler did not force us to handle this, because this is also an unchecked exception. Another example is array index out of bound exception, which means, say for example, you created an array, say I'm creating the array of data type int, and it's like size is, say you can say new int, and you say define the size as like say 3, okay. And then what happens is later you do a and you do 4, Okay, so you are trying to use the index 4 which doesn't even exist because the size was 3, right? So it will result in array index out of bound exception. Now you might get the array from outside from some other class, and then you can try to do this, and at runtime you'll get to know like this array was not even of this size. So all that situations and scenarios can happen, so a compiler won't be able to identify that. That's why they are called unchecked exceptions. Now here we mentioned exceptions, but there is one more thing called as error. So error is even more serious as compared to exception, because generally you can handle the exception, like for example using the try catch block or other things which we'll discuss in few minutes, but you can basically handle the exceptions. Okay, but when we talk about error, it is something which becomes like out of control kind of situation. Like for example, you handle the exception in try catch, but again you are doing something wrong. Okay, and later that can act as error. One example can be stack overflow. For example, very simple example can be in while loop. Say you are running the loop, but you have not incremented your counter through which you had applied some condition, because say for example you wrote like while I is smaller than say 5. Okay, and in the beginning I was 3. Okay, and then you inside the loop you wrote some functionality, but you forgot to increment I, so I always remains 3, right? So this loop will never end. It will keep on going and going and going on. That will result in something like stack overflow error. Let me show you an example what I was talking about. So let me first define a variable int I equal to 3, and then while I is smaller than 5. Okay, and inside that you write system dot out dot println hello, right? So we are doing this, but say for example we forgot to add this line where we are incrementing or doing something, because if I do this then it will run like twice only, because first time I is 3 which is smaller than 5, then we do I plus plus, then it becomes 4, then again we check 4 is smaller than 5, which makes sense, then we'll do plus plus, then it will become 5. Now this condition becomes false because 5 is equal to 5, it's not smaller than 5, right? So this will stop. So let me run this first, then I'll show you the error case. So here you can clearly see it prints hello twice, right? Because of what we just discussed. Now let me remove this or comment this out. So you forgot to do this. Now what will happen is like this loop will keep on running. You can see hello 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 hello, and it will keep on running, keep on running. There is no stopping here, and finally it will result in kind of stack overflow error. So you have to avoid such kind of situations because it can become out of control. You cannot handle this even by like try catch or anything which we will discuss for exceptions, right? So let me stop this because otherwise it will keep on running. Okay, so this kind of situation can give you stack overflow error, which is error, which means like we are doing something very wrong in the code. Okay, and that cannot be handled by something like try catch or anything which we will handle for exceptions. So error is something wrong in the code which needs to be changed. Okay, and in similar way when we use recursion, like if you know the concept of recursion where we repeat the things, right? And in recursion we generally have the base condition. If you don't know about recursion, don't worry about it, you focus on this example, but just in case you know about recursion, we generally have the base condition in recursion, right? But just in case we forgot to add some logic for the base condition or we missed out on that part, so that recursive call will keep on happening just like this while loop, and that will also result in stack overflow error, which represents something very wrong in the code, right? So in order to understand more, let's see the hierarchy, and through which we'll see more about exceptions and error. Okay, so let's see the hierarchy. So first basically we have this throwable, and then both exception and error are part of basically throwable. So throwable you can say as the parent, and these are like child or the subcategories you can say. Now exception is something which can be recovered, whereas error is something which cannot be recovered. It means something wrong in the code which needs to be modified, whereas for exception it can be like you can handle that part. Now in exception we saw there are two categories, checked and unchecked. Checked is basically which can be checked at the compile time, so the compiler will force you to handle it in a specific way, whereas unchecked means that these exceptions will happen at the runtime, so compiler won't be able to force you to handle it. Okay, so this was basically the hierarchy. Now we mentioned that exception can be handled, but how can we handle the exception? Let's see now. So basically we will see some of the keywords which will be used for the exception handling. First keyword is try. Okay, just like in English you try, right? So basically what you will do using try is like the code which you feel might cause the exceptions. Say you have these lines of code in which you feel an exception can happen, so you will surround this inside the try. Okay, because there is a probability that you feel this can cause an exception, so you will put this part inside the try block. And then we have the catch. Now after try we have the catch, and catch means that it will handle the exception, like what to do when exception happens. So inside try you will write the code which can cause the exception, but inside catch you will write the logic in case exception happens, which was inside the try block. So when exception happens, it will go to the catch, and inside catch you can write your logic in case the exception happened. And then we have the finally block. Now finally block is very interesting because we know when there is exception it will disrupt the flow. Say for example you wrote like these 5 lines in the try block. Okay, so say we ran this and we got an exception on this third line. So whenever there is an exception it disrupts the flow. So after this, these 2 lines which are inside the try block, this will not be called. It will disrupt the flow at the line number 3. And then after that, the logic inside the catch block will run. Okay. So some of the code might not run when an exception happens. So we use finally because it executes the code irrespective of exception happened or not. So even if we got an exception, whatever written inside finally that will run for sure. So that's why finally is used, and you can imagine it like with the English keywords as well, like finally, so which happens at last and that happens for sure. So this is something like irrespective of exception happens or not happens, this code will be executed, which is part of finally block. Then there is throw keyword. Throw is basically to manually throw an exception. Now you will say why would you manually throw an exception? We'll see the case later, but throw you can clearly imagine like it says throw, so you are throwing an exception. And then we have a keyword throws, which basically declares an exception in a method signature, which basically warns you or tells you that this method basically can give you exception. Don't worry about it, we'll discuss all of these in detail, but I just wanted to give you the keywords: try, catch, finally, throw, throws, right? Like you can imagine these in English scenario as well, like you are trying something and then you are catching, you have caught the exception, and then you basically write logic to that. Finally is like even in case the exception happens, this should run. Throw is something like you are throwing by yourself. Throws is giving you warning that it throws an exception. Okay, so something like that you can remember in your mind. I know throw and throws are quite similar and these can confuse you a lot, but remember that in English terms so you'll get more idea. Throw is like you are throwing. Throws is like that person throws, right? Or that method throws. So it is giving you warning. So in that way you can remember. But let's talk about each of these in detail so that we get more clarity. So first let's talk about try and catch. So what we'll do is like see the code, because enough of theory. Let's directly dive into the code and we'll get more understanding. So here you can see we have used try catch keyword. So before this we tried this one, right? Like we did like 10 divided by 0 or 5 divided by 0, and that gave you an exception and that disrupted the flow. So now what we are trying to do is like we know this can give you exception, so we are putting this inside the try block because we put all that stuff inside try which can cause an exception. Okay, and that's how we can handle that in the catch block. So you write all those things inside try in which you feel that can cause an exception. Okay, and earlier we saw 10 divided by 0 gave you an exception and it disrupted the flow. But now let's see what happens. Earlier it did not print the statements after 10 divided by 0. Let's see what happens now. Let's run it. All right, you can clearly see it has not given you any exception this time. It says cannot divide by 0 and it says program continues. So what actually happened? So basically your flow went inside this. It checked like 10 divided by 0 and this caused an exception. Now whenever an exception happens, it disrupts the flow. Okay, it stops there. Then Java will create an exception object, because here we can clearly see this was arithmetic exception, so there will be an object related to arithmetic exception. Then there is one more step, which is the step 3, where Java checks for try catch block. Okay, now basically Java will see this exception was part of try block, and then it checks for the catch part, whether we have handled this particular exception or not. And we have handled this particular exception. We have mentioned arithmetic exception, which is the exception we got here, correct? And once Java sees that we have handled this exception, so it will go inside the catch block. So whatever logic we have written inside the catch block, here we just printed something can't divide by 0, and Java executed that, so we printed this. And once the catch block is over, the normal flow will continue. You see this line also got executed. Whereas if we don't put this inside the try block, what will happen is like the program flow will just disrupt. It will just stop here and you will see the exception. But now using the try catch, you have handled this exception, right? Let me show you what I'm talking about. Say you write this same thing, int result equal to 10 divided by 0, and this is not now inside the try block, right? So of course you can't have two variables with same name, so let me name it like result1. Okay, so what will happen now? Now this will get executed. There will be an arithmetic exception. Java will check for try catch, but this statement is not inside the try catch block. So what will happen is it will cause an exception. Clearly you can see there is an exception and it has disrupted the complete flow. So we did not even reach to this statement because here exception happened and Java stopped it completely. Okay, so in order to handle all such exceptions, you have try catch block, right? And there is one more important thing. In the catch, you have to tell the exception type, right? Here we wrote arithmetic exception, which was correct because we got the arithmetic exception here only. So if you run this, you can clearly see it has been caught and this is working perfectly fine. But just in case you write the wrong exception here, or you did not handle the correct exception, say for example I put the null pointer exception here, now what will happen is this will give you exception, but this will give you arithmetic exception, which is a particular exception. And Java will check for try catch. It is inside try, which is wonderful. Java will check for catch. There is catch, but not specific to this exception. We had arithmetic exception and we are handling null pointer exception. So the flow will not go inside this. Again, there will be an exception and the flow will get disrupted. Let me show you. Clearly you can see this did not run. Even this did not run because we kept the code inside try, which caused the exception, but we have not caught it. We have written catch, but we have not caught the particular exception. Okay, so that's why it has given you exception again. So one way to handle it is like you simply write exception, because exception is the base class of all other exceptions. If you have like arithmetic exception or any other exception, that is a subcategory of exception. So if I run this, it should be fine because exception handles everything, right? And other way is like you write the particular exception, so arithmetic exception e, and this will also run totally fine. Correct. If I show you arithmetic exception, you can clearly see arithmetic exception class extends the runtime exception, and if we go to the runtime exception class extends the exception. So in short, basically exception is the base class, right? So if you write exception here, it works, and if you write specific exception which happened, that also works. Now you will say, why would you write the particular exception? Why won't I write the generic base exception every time? There is a reason for that. Basically you can catch multiple type of exceptions because you are writing your code inside try, right? So there can be many statements, and you know there can be multiple type of exceptions that can happen in that code flow. So what you can also do is like you can write multiple catch blocks here corresponding to a try. So I can also write one more catch here, which will be null pointer exception, and I can give it even, say for example, and inside that I can write system dot out dot println, and I can say null pointer exception, right? So like this you can write multiple catch blocks for a try. So what will happen is, like, in case you get a null pointer exception out of this try block, so this will get executed because we are handling the null pointer exception. And in case you get the arithmetic exception, so this part will get executed. So in this way you can do different handling of different exception. And lastly you can also write something like catch exception, okay, e2 or whatever. What this is doing is, like, you can handle specific exceptions what you want to, and this would act as a default case. Just in case if something got missed in these and you got a new kind of exception which you did not handle, that will be handled in this generic exception, because all the exceptions are subcategory of exception. So this is similar to, you can say, if else blocks or the switch cases, right? In if else also it used to go like sequentially. So similarly here, if you get the arithmetic exception, although exception is a base class, but because we wrote arithmetic exception before the exception, so this particular thing will get executed and this will not get executed, right? So this is like the, you can say, if else kind of things where you need to think about the order, because if you write exception at the top and later if you point out null pointer and arithmetic, it won't make any sense. Let me show you an example. So let me write here system dot out dot println generic exception. So what I was trying to say was, here, because you got arithmetic exception and arithmetic exception is on top, like before generic exception, so this will get executed. Let me show. You can clearly see it says can't divide by 0, which is part of the arithmetic exception. But in case by mistake you write here exception and here you write arithmetic exception, then you see you are getting compile time error by default, because exception is the base class. So all of the case will directly go to this scenario, even if you get the null pointer or arithmetic, because exception you have written at top, so everything will go here. So these statements are actually not reachable. You will never be able to reach here, even in case you don't get a compile time error here. Every time you have an exception, this will get executed, so there is no point of writing all these. So that's why I was saying you need to make sure that you write the order correctly. So first you write the specific exception, and then as a default case you can write the generic exception here, okay? So the main point, any code, it can be one line, many lines, that you feel can cause the exception, you put that in try. Then you have catch, which will basically catch the exception and do the handling. If you handle the exception which came, then there will be smooth handling. So catch will run, and then after that whatever code was written after catch, that will run, okay? But there is one more point that you need to remember. So say for example there were multiple lines in try block. I am writing here inside try block, right? So here you will get the exception, correct? So other lines which are part of try block will not run, okay? Whenever you get an exception, the flow will stop there. So this will not get run. Let me show you. Clearly you can see we don't see this statement inside try block because we got an exception here. And after this, nothing will run inside try. It will just check for catch. And in case there is no exception in try, so if I comment this out, now you can clearly see there is no exception. So nothing from catch will run. Okay. So now if I run this, you can see the output is inside try block. Okay, so it ran the try block normally because there was no exception. So nothing from this gets executed because there was no exception. Catch code will run only if you caught the exception which came, but currently there was no exception, so nothing from this will run, and after that simple flow after try catch will run. Okay, so all these scenarios I want you to try, okay, so that you get good clarity. Oh, what happens in this case? Oh, what happens in that case? All that kind of stuff. Okay, now just like if else statements, try can also be nested. Okay, so inside one try you can put one more try, so it is totally fine. So you can do all that kind of stuff. Although I am giving you reference of if else here, don't take it in that way. I'm just saying as a reference, because if else is completely different from try catch. One more thing is like try cannot exist without catch, because try means you are writing the code inside try which can cause the exception. But what's the use of it if you're not catching the exception? So here if you see, I have not mentioned the catch block, so it will say there is no catch or finally. Okay, so whenever you write try, either you write catch or finally. What is finally, we'll talk about it, don't worry. But here if I write catch, it should be fine, right? Here you can clearly see now there is no compile time error. So here we learned like try can be nested, right? Inside one try you can have one more try, so that is totally fine. Okay, so one thing that I was telling you, if we get the exception in the try block, whenever or wherever we get the exception, after that nothing will run inside the try block, right? We saw this example, this doesn't get run because we got an exception here. So it means that whatever you write inside try is not sure that all of that will run, because whenever you get an exception, the flow get disrupted in try, right? So you're not sure this will get run or not, but there are a few statements that you surely want to run irrespective of the case you got the exception or not. Say for example, you wanted to print something irrespective of the case that you got an exception or not. For that you have finally. Okay, so after try you can either have catch or finally, but you can also have both try, catch, finally. I'll add a finally block here, finally, and inside that you will write the logic that you want to run. So let me print something inside it, system.out.println, and let me say finally, right? So now here what will happen is that exception comes here, this is part of try. Java will check for the catch handling for the arithmetic exception, we found it. So this will not run because we got an exception here, so this gets skipped and then we execute this part, and after that we'll run finally, because finally will run irrespective of the exception. So in case you don't get any exception, you remember catch will not get executed because there is no exception, but even in that case finally will get run. Okay, so in this case let me show you what is the output. It says can't divide by 0, which is part of here. You see this got skipped, right? Then it says finally, so this will run and then the program continues. Okay, so this happens. Now say I remove the exception. Now in this case it says inside try block, so this runs because there was no exception. Now everything inside the catch will get skipped because no exception. Why will catch run? But still finally will run. So you see the finally, and then you see this program continues. Now there might be a confusion in your mind, like why write something in the finally, right? Because this is also running after the try catch, correct? So basically finally is used if you want something to run for sure, even if there is exception happened or not. Now you will say like, okay, finally will run for sure if there is exception in try or not, right? But this line outside the try catch finally block is also running, right? In case there is exception that is handled by catch, finally will run, that's fine, but this block is also running. In case there is no exception, finally will run, but this case is also running. Then what is the use of finally? You can simply put the things outside the try catch directly like this, right? This is outside the try catch finally block and this is running fine. So what is the difference between keeping something inside finally or outside the try catch block? Here is the difference. Say for example, in the catch itself you threw some exception, you did something wrong. Say for example, inside the catch I did 10 divided by 0. Okay, now this catch was handling an exception which happened in the try block. So arithmetic exception happened here, so this was caught here, so we are executing this part normally. But inside this you made an exception, 10 divided by 0 you wrote here. Now what will happen? Let's see. Okay, clearly you can see here, first you got the exception here, right? So this will not run because whenever you get an exception in the try, the other things which are present in try will get skipped. So you got an arithmetic exception here. Java will see whether it's part of try. Yes, it was part of the try. So it will see whether you have handled arithmetic exception. Yes, we have handled the arithmetic exception. So everything should go smooth now, and Java is basically running your catch part. So this was running, but here we got another exception and this is not handled anywhere, right? Because this was part of the catch. Now what will happen is this will not get printed because we got an exception, the flow got disrupted. But the good part is finally will get executed even in this case. Now if you see the output, it says finally, so finally got executed, and this was not executed because we got an exception inside the catch. So that's why finally block is very important, which makes sure if you are writing something inside try catch, the finally part will for sure run in case you get an exception or not. So generally you use the finally block to release the resources or even to close the files. So all that kind of stuff that must be done, that is done in the finally block, right? So you can see so many cases, so much fun. I mean, just try it out, you will love it. Like do all such kind of things, put something random in, like exception in try part, in catch part, what happens in this case, in that case, try it out. You have this IntelliJ. Otherwise you can also try on the online compilers in Java in case you don't have the proper laptop setup. That case you can simply check on the online compiler and try out various scenarios, and through that you'll get a great amount of understanding. Okay, so this was about try catch finally. Now let's talk about throw keyword. Now throw basically means that you will manually throw an exception. But why will you manually throw an exception? It can be a case like, for example, you are writing a method and inside that something specific condition happened which you know is wrong. So in that case what you can do is like throw an exception. It can be very simple, like in your method you found something was null or empty. Say username was a must thing, but you got the username as empty or null. In that case you can throw an exception to tell that this is a mandatory thing, you need to fill this, something like that. So you can throw exception manually using this throw keyword. Let's see an example in code for the throw keyword as well. Here you can see we have created a method which is check age. So we have written condition if age is smaller than 18, which means you are not adult, right? So in that case we have specifically manually thrown an exception. So we have written throw keyword and then we have written new keyword and then the exception name. So this is how you can throw an exception manually. Okay, you will use the throw keyword, then new, and whatever exception is there you can provide the description in that part. Okay, so say for example we created this method if you're allowed to vote. Say someone went for voting and in that we identified the person is less than 18 years of age. So in that case we want to throw an exception because that is not allowed. So in that specific case you want exception, so you can throw the exception using the throw keyword. So you are throwing, so throw, right? So if I call this method say check age and if I pass the age as 20, let's see what the output is. In this case it says eligible to vote because the age was 20 and this condition became false, and so it went to the else case and this statement got printed eligible to work. Now let's say I put 10 here, let's see what happens. So when you put 10 here you can clearly see there is an exception, and why? Because this condition became true and here we are manually throwing an exception. Okay, and you can clearly see it says arithmetic exception, the one which we mentioned, and it also mentions the error message that also we mentioned here. So basically using throw you can manually throw an exception. So this was about throw. Now next let's discuss about throws keyword. So throws keyword basically tells you that a method can throw an exception, that the method you are trying to use it can throw an exception. So you should be aware of that, you should be cautious about that part. And if you are using a method throws an exception, so either you handle that using the try catch block because now you know that this can throw an exception, so you need to handle it in try catch. Either you do that, or if you are not handling it via try catch, you make from your method also you say throws, because your method now can also throw an exception, right? Now for throws as well, let's see an example through code. Okay, here you can see we have created a method read file which throws an exception. It throws IO exception, which means this method can give you an IO exception. So whenever you use this method you need to be cautious. So let's try to use it. Okay, in the main let me call this method read file, right? you can clearly see we are getting the compile time error, right? It would say unhandled exception. Why? Because this method throws an exception. So we already know that this method can give you an exception. So when you know there can be exception, so you need to handle it either using the try catch. So you can put this inside the try catch. Let me do that, putting it inside the try, and inside the catch let's put IO exception, because we know it is throwing the IO exception, right? So inside that we can do the handling. Now you see there is no exception here. So if you are not handling it via try catch, then the other scenario is the method in which you are using this should also use throws, okay, and it should also throws that particular exception. So let me remove it from the main, let me call it from some other method, void method, and let's do read file. Okay, so either you use try catch that we used earlier, or this method also should say throws IO exception, because inside this method we are calling a method which throws IO exception. So if this method throws and we are not handling it, then this method also throws. So you write here throws IO exception, right? So then you can see there is no compile error. So when you are calling a method which throws some exception, either you put that inside the try catch because you know this method can throw an exception, or if you're not doing the handling, you make your method itself throws that exception, because if this method is getting used from somewhere else, then they should know that this method can throw exception, because whatever you are doing inside in it can throw the exception, right? It is quite similar to the thing that we discussed for abstract class, right? Either you implement the things of the abstract class. If you're not doing it, you have to make the class which is extending the abstract class as abstract as well, right? Because you're not handling it. Similarly here, if you are not handling the method which is throwing exception, then you also make your method say that it can throw that exception, right? So throw is basically giving you warning that this method can throw an exception, okay, right? So this was about throws. Now let's go back to the visual representation. Here we discussed about all of these try, catch, finally, throw, throws. We actually saw some of the examples like null pointer exceptions, arithmetic exceptions, and those were like subclasses of exception, right? But those are predefined. But in Java, you can also make your custom exceptions, which means you can create your own class which can extend exception or runtime exception. Runtime exception basically means that it is unchecked exception which happens at runtime, whereas exception is for like checked exception, which means which can be checked at the compile time. So basically by extending exception or runtime exception class, you can create your custom exception class and then use that. So let's see an example of that in code. Okay, so here you can see we have created a class invalid age exception, and basically this class extends exception class. Okay, so by doing this we are creating our own custom exception because we want to give some customization related to exceptions, right? So here you can see we can give the message to it, and in the main we have basically created a method which throws invalid age exception that we created. Okay, instead of using the ones which are provided by Java, we have created our own exception to give some customizations. And here you can see we have passed the message here, and in the main method. So basically now we are calling this method. So if a method throws an exception, you either handle it in try catch or you make your method throws exception, and but we are using the main method, so we won't do that. So we are surrounding it with try catch, and you can see we have handled it. So the main point here was that you can create your custom exceptions as well by simply extending the exception class or runtime exception class, and you can do customization in that, what type of message you want, any other fields that you want in that part. By doing that, whenever you get an exception, you can handle it in your custom way, like this should happen when you get the exception, all that thing can be done. Okay, so next let's see some of the best practices related to exception handling, right? So the first thing is like you should catch the specific exceptions instead of the generic exception. We saw an example that for a try block you can have multiple catch blocks, because in a try code you can have different kind of exceptions that can happen. So it's a good practice that you specific exception, right? And in that way you can handle multiple different exceptions in a better way. And there are many other use cases as well, but the main part is you need to catch the specific exception. Next thing is like, don't ignore the exceptions. In case you are handling it via the try and catch, it's not like in catch you are not doing anything. At least you should log that or handle them properly. Even with the logging, you will get an idea like how many times you are getting this kind of exceptions. So basically you should handle it properly in the catch section. Okay, and then the next best practice is that you should always release the resources in the finally block, right? Because we saw that finally block will always run in case you get the exception in the try catch block or not, finally will always run. So just to be on the safe side, you can basically use the finally to release any resource or close the file, all that kind of scenarios. You can ignore this part for now, try with resources, because this is something in the new versions of Java and we haven't discussed about it. So in normal terms, you can use like finally basically to release any resources or to perform something which must be done irrespective of any exception or not. And then as we discussed, you can also have like custom exceptions where you can basically show meaningful error messages, and you can have even more things which can be part of your custom exceptions, right? So basically this was about the exception handling. If I give you a very brief kind of summary, so basically any code in which you feel there is a probability that it can throw an exception, you put that in the try block, and corresponding to try you can have multiple catch blocks where you can catch specific exceptions. So whenever there is an exception in the try block, and if you are handling that in the catch, that particular catch block will run. Okay, and then we also have a finally block which ensures that it will run irrespective of the case that you got an exception or not in the try catch. Apart from try catch finally, we also have throw keyword, which is used to manually throw an exception in case there is a scenario that you want an exception to happen. Like we saw an example, like if your age is less than 18 and you are going for voting, so basically you can throw an exception if the person is smaller than 18 years of age, and there can be many other scenarios. So basically throw is something you can throw the exception. And then you have throws keyword, which basically warns you that this method can throw an exception, so you need to be cautious while using it. So if you are using a method which throws an exception, either you need to surround it by try catch, or if you are not handling that properly, your method also should use throws, because it should now warn other methods that this method can throw an exception because it is using some method which can throw the exception, right? So this was about the exception handling. Now let's discuss a very important concept in Java, which is multi-threading. So let's understand what is multi-threading in Java. Basically, as the word suggests, it means executing multiple threads simultaneously. So you can clearly see multi, which means many, and then thread, so multiple threads will be executing together. But before that, we need to understand what is a thread. So basically, to perform any task, you would need a thread. So thread is the smallest unit of the process. So let's say this is your program, so you can assume it as the process. Okay, but within a process there can be multiple threads. Okay, now thread is the smallest unit of a process, and to perform any task you would require a thread. So in Java, every program runs with at least one thread, and that one thread is the main thread. Now apart from main thread, there can be other threads as well, but there will be at least one thread which is the main thread. You might have already observed that, but let me show you again. So when there was a case of exception, right? For example, I am writing system.out.println 10 divided by 0. It's in the main method, right? So if I run this, you will see an exception, but observe more than that. It says exception in thread main. So the exception is coming in main thread. That is what I am talking about. There will be at least one thread in Java for every program that you have. That will be the main thread. And apart from that, you can create more threads, but the main thread is mandatory. Now, as I said earlier, to perform any task, a thread would be required. So the use of multi-threading is you can perform multiple tasks using multiple threads, right? For example, one of the thread can be used to download a file, whereas another thread can be used to update the UI. So you are performing multiple tasks at the same time using multiple threads. So using multi-threading, where you are executing multiple threads in parallel, there is better CPU utilization. At the same time, there is faster execution. Also, your feature becomes more responsive. For example, in the same case, if we take, if there is only one thread, then if it is downloading some file, it cannot update the UI, right? Because it can perform only one task at a time. So the user will keep on waiting. There will be no update on the UI because your thread is blocked on downloading the file. It is already consumed to perform some task. It cannot perform one more task at the same time, right? But if you are using multiple threads, then you can give much better experience to the user. One thread is downloading, other thread is updating the UI. It is showing the progress to the user so that user can see there is some progress. Okay, 50% file downloaded, 95% file downloaded. This is how you can make your feature much better, right? Like this, there are many use cases of multi-threading. So as I mentioned, two terms, like one is the process, other is the thread. So let's see what is the difference between the process and the thread. Okay, so basically process is an independent program. So say for example, you created a program, it will act as a process. Okay, whereas thread is the sub part of the process. There can be multiple threads inside a process. Now if we talk about the memory, the process has its own memory because it's an independent program, whereas thread shares the memory of the parent process. Okay, so process has its own memory and thread basically shares the memory of the process. A real life example you can imagine is, like for example, you open the browser. Okay, so any browser you have, that acts as a process, and any tab that you open in the browser, that acts as a thread. So you know, in the browser you can open multiple tabs, right? In the similar way, in the process there can be multiple threads, but thread would be required to perform any task, right? In the tab only you perform some task, like you search something, right? And there will be at least one thread present in the Java program. Like that is also same for the browser. When you open the browser, one tab is by default open and you use that. So in technical terms, that thread is the main thread. Okay, you can create more threads, but by default there is main thread that is available. Now let's discuss how can we create threads in Java. So basically we have two ways to create threads in Java. First way is by extending the thread class. Okay, we talked about inheritance earlier in this video. So you can extend the thread class. Thread is a class in Java, and by extending the thread class you can create a new thread. Let's see an example for this in code. Okay, so here you can see we have created a new class. The name of the class is myThread and it extends thread class. So if I show you here, thread is a class, right? So thread is a class in Java. So what we are doing here is we are extending the thread class. Now thread class has this method run, inside which we write our implementation, because whenever the thread starts, this method gets called. So this method gets executed. So whatever task you want your thread to perform, you write that part inside the run method. Okay, so basically in the execution of thread, this method will run. So whatever you have written inside this thread will be executed. So here you can see we have created a class and that extends thread class. So we are using inheritance here. Okay, and in the main class you can clearly see we have created object of this class, my thread, which is the name of the class, then object name, then equal to new keyword, and then the constructor of the class. So this is how you are creating the object of the thread class, and then basically you call the start method of the thread class to start the thread. We do not call the run method, we call the start method. And once you call the start method, automatically run method will get called when the execution of the thread will start. So when the thread starts running, this method will be automatically called, but you never call the run method by yourself. We'll discuss more about it, but for now we were discussing like how can you create the thread. So this is the first way, by extending the thread class. And we understood one more thing. In order to create a new thread, we will call the start method of thread. Okay, and it will automatically execute the run method. So whenever the thread starts running, whatever you have written inside the run method, that will get executed. So this was the first method to create the thread by extending the thread class. After this, we have one more way, which is the second way to create the thread, and that is by implementing Runnable interface. Now let's see code for this as well so that we can understand it more. Okay. Here you can see we have created a class. The name of the class is myRunnable, and this class implements Runnable interface. So in the first way, we extended the thread class, but here we are implementing the Runnable interface. Runnable is an interface. Let me show you. You can clearly see it says public interface Runnable, whereas for thread it was a class. So that's why we extended thread class, whereas we are implementing the Runnable interface. So this is the second way of doing this, and inside this also you will write the implementation of run method. That will remain the same. We did the same when we were extending the thread class, and we did the same. You need to provide the implementation of the run method even when implementing the Runnable interface. Now in the first case, we were extending the thread class, so we directly created the object of our class and we called the start method, which is part of the thread class. But here you can see we are not extending the thread class, so we cannot call the start method using the object of myRunnable class. So how do we create the thread? We will say thread, because thread is the class name. We saw earlier as well, thread is a class, right? So we'll write thread object name equal to new thread, and inside the thread we will pass the object of this class, because this is implementing the Runnable interface. And then we have the object name of thread, and using that we will call the start method of the thread class. So basically start method is the method of thread class. You can clearly see this start method is method of thread class, so we cannot call it directly using the object of myRunnable. We need an object of thread class to call the start method, and we are not extending the thread class here, so we created object like this and we passed the myRunnable, which implements the Runnable in the thread. Now you may ask, like in the first way also we implemented this method run, and in the second way also we implemented this method run. So how is this possible, and where does this method run exist? Because we saw that start method is part of the thread class, but how about the run method? Where does it exist? So basically run method is part of the Runnable interface. Clearly you can see public interface Runnable, and it has this method public abstract void run. Abstract, you remember abstract? We discussed about abstract earlier in this video, which means that we have not provided any implementation of this method in this, because it's part of the interface, and by default in interface there is 100% abstraction, which means all of the methods are just defined, there is no implementation, right? So that's why when we implement the Runnable interface, we are providing the implementation of run method. But how come we are providing the implementation of run method when we are extending the thread class? We are doing that because the thread class implements Runnable. Okay, so in both of the cases, this was the first case where you are extending the thread class, and this is the second case where you are implementing the Runnable interface. In both of the cases, you are actually using the Runnable interface, because in the second way, of course, you are implementing the Runnable interface, but in the first way also you are extending the thread class, which further implements the Runnable interface. So this implements the Runnable interface, so thread class will also have the run method. Let me show you run method. Let's go down, and you can clearly see it overrides the run method, which was part of the Runnable interface, but there is nothing much inside it, right? So that's why you provide your own implementation when you extend the thread class or when you implement the Runnable. When you implement the Runnable, you don't have any choice, because Runnable is an interface. So this method you need to provide the implementation, because now you are implementing this interface, so you provide the implementation. But when you extend the thread class, you can also ignore this, but if you don't provide this, nothing will happen when your thread runs, because when you see the default implementation of the run method inside the thread class, there is nothing much, right? So whatever work that we want our thread to perform, we put that in the run method, right? So in both of the ways, you are basically implementing the Runnable. In the second way, you are directly implementing the Runnable. In first way, basically you are extending the thread class, which implements the Runnable interface, right? Now which one should we prefer, like the first one where we extend the thread class, or the second one where we implement the runnable? The answer to this question is the second way, where we implement the runnable, is more preferred. Why? Because in Java you cannot extend two classes at the same time, right? You can only extend one class. Now you cannot extend any other class, and that can cause issues for you, because you may want some more functionality from some other class, but because you have extended the thread class, now you cannot extend any more class. Whereas, in Java you can implement multiple interfaces at the same time. So even if you are implementing runnable interface, you can implement even more interfaces, right? And you can even extend a class, because you are not extending any class here, correct? So this way of implementing the runnable is the preferred way for creating the threads, because you can implement many more interfaces and you can extend a class as well, right? So these are two ways using which you can create the threads in Java. So by extending the thread class and by implementing the runnable interface, and this way where we implement the runnable interface is more preferred for creating threads in Java. Next, let's discuss about the life cycle of the thread. We discussed about what is a thread and how can we create a thread. Now let's discuss what happens when you create the thread and what is the life cycle of the thread. So basically, first of all, the thread is in the new state. Okay, new state means you have created but not started the thread. So basically you have, say for example, created the object of the thread. Like for example, here you created this thread but you have not started it yet. You will start, the thread will get started when you call the start method, but at this point the thread is just created and it's not started, so it is in the new state, right? So new is the state when the thread is created but not started. Then we have the runnable state, which means the thread is ready to run but the execution has not yet started. Okay, then we have the running state, which means the thread execution is currently in process, or you can say the code inside the run method, whatever we have written, that is getting executed now. So the thread is currently in running state. Okay, and after that we have a blocked or waiting state, and that is basically case like it is not currently executing, it is just waiting, or it is just blocked for something. Once it gets a signal or resource, it can start its execution again. And the last state of the life cycle is terminated, which means that thread has finished its execution and now it will be terminated. So this is the life cycle of a thread. You can clearly see new, runnable, then running, and it can go to blocked waiting state, not necessarily, but it can go there, and finally we have the terminated state. Now because thread is a class, let's discuss some of the famous or commonly used methods of the thread class. The first method is start, right? We use this method in the code. You can clearly see we call this method start, and this is required for creating the thread, and if you don't call this method, your thread will never start. So it is very important method. Let's go back to the visual form. It basically starts your thread, right? When you create this object, you have just created the object but your thread hasn't started yet. When you call the start method, after this only your thread will start. Okay, and after that we have the another method which is very important, which is the run method. Inside the run method you basically write the code which you wants to be executed. Now as we said, thread will execute your task, so whatever work that you want to happen, that will be part of the run method. So whatever code that you want to be executed, you should put that inside the run method. You can see here we provided the implementation inside the run method, so whatever you write here, that will get executed. Next we have the sleep method. So as the name suggests, it will pause the thread temporarily. So it takes a parameter which is time in milliseconds. So say for example you say sleep 10. So basically your thread will sleep for 10 milliseconds. Then we have another method which is join, which means that wait for thread to finish. So methods like this basically can put the thread into the waiting or the blocked state which we discussed, right? For example, you put the thread to sleep, or it has to wait for another thread, so it will be kind of in the blocked or waiting state where it will wait for something to happen or something to complete. Only after that it will again start its execution, right? And similar to this, there are multiple other methods which are part of the thread class, but I think you will get to know more about it once you start coding, and you will see which all methods are more frequently used or not. But here we talked about two methods, sleep and join, and I can understand it can be a bit confusing. So let's do one thing. Let's go to the code and see one of the example where we will use both of these methods, sleep and join, so that we'll get more clarity about it. Okay, so here you can see we have created a class which has name demo, and it extends the thread class. So we have used first way to create the thread by extending the thread class, right? So inside this, we will provide the implementation of the run method, which means what we want our thread to do, that will be part of this method. Okay, so you can clearly see inside this, we have written a for loop, I equal to 1, I smaller equal to 3, and I plus plus. So how many times will the loop run? When I equal to 1 first time, then I equal to 2, then I equal to 3. So 3 times this loop will work. Inside that, we have printed the current thread name because we will be using multiple threads here, and then we have used the sleep method of thread class. What it will do is, like, it will make the thread go to sleep for 1000 milliseconds, which means 1 second. So your thread will go to sleep for 1 second. Now, why sleep method is surrounded by try catch? Let's go to the sleep method and you will understand that. Here you can clearly see this is the sleep method, and it throws interrupted exception. So it throws, you remember we talked about throws keyword earlier in this video. So basically throws keyword gives you a warning that this method can throw an exception. So an exception can occur if you are using this method. So basically it is giving you a warning or a signal or a caution, right? So that's why when you call this method, the compiler identifies this at the compile time. So you have to surround it by try catch, right? Okay, so this was the run method, and let's see what we have done in the main method. So we have created two threads here. First, like demo t1 equal to new demo, this will create a new thread because demo class extends the thread class. Then we created another object, this is the t2 thread, right? Now we have written t1 dot start, so it will start the first thread. After that we have written t1 dot join, which means that the main thread will wait until the t1 thread finishes. Okay, till the time the execution of the t1 thread completes, the main thread will wait. Okay, and after that we have written t2 dot start. So once the t1 has finished its work, then we are starting the t2 thread. So here we have used both sleep method and the join method. Let me run this code through which you will see the output and will get more clarity. Okay, so clearly you can see it took like 1 second delay. Let me show you again so that you can see it clearly. There will be gap of 1 second. See it again. See thread 0, it takes 1 second delay, 1 second delay, 1 second delay, 1 second delay, 1 second delay. Okay, so basically why 1 second delay? Because we have put like thread dot sleep, and 1000 milliseconds means 1 second. So because this loop will run 3 times, right? So it will print this 1 second delay, then it will print it, then 1 second delay, then print it, then again 1 second delay, right? If I increase the delay here, say for example 5000, which means 5 second delay, let me show you, it will take that delay. Okay, clearly see 1, it is in the delayed state right now. Now it shows you 2, now it is currently in delay. We will count it, 1 2 3 4 5, right? Here it comes, 1 2 3 4 5. Okay, it comes 1 2 3 4 5, it comes, right? So every time it is taking kind of 5 second delay because we have put the sleep as 5000, right? But here is one more thing, you can clearly see first the thread 0 executes completely. After that the thread 1 has started its execution. Why is that happening? Because we have used this t1.join, which means the main thread will wait for t1 to finish first. And if the main thread is waiting, this line will not get executed, right? Because the main thread is waiting at this stage, it will not go to the next line. And once it is done, after that the main thread will start this. In case if I remove this, okay, I've commented the join part here, and let's keep the delay as 2000, like 2 seconds delay. Let's see what's the output now. Okay, clearly you can see thread 1 thread 0 both are coming, because now thread 1 is not waiting for thread 0. Earlier it was waiting because we have applied t1.join. When you use something like this, the main thread will wait for the completion of this thread. Okay, and if the main thread waits here, it cannot execute next line. But if you remove this kind of line, then you have basically started both of the threads, and it is kind of multi-threading. Both threads will perform their task, they will do their execution, and you can clearly see both threads are running in parallel, right? So this is the use case of sleep method. You can put the thread to sleep, and the use case of join method, where the main thread will wait for this thread, where on whatever thread you have applied the join, the main thread will wait till the execution of this thread finishes. Now in this example we checked about like sleep method, join method, but we also saw an example of multi-threading. We used multiple threads, and you can clearly see both are running. Like you can see thread 1, thread 0, both are running at the same time. So this is multi-threading. But now because both are running together, it can also cause issues. How? Basically, if more than one thread, here in case two threads were there can be multiple threads. If more than one threads are sharing some data, then issues can come, because say there are two threads, okay, and both have like shared data, and now both of the threads try to modify the data. So in that case issue can come, and that is also called race condition. Okay, when multiple threads are trying to modify the data, and due to that you get issues, that is called the race condition. Now I know you will say, what is this kind of theory? Let's go to the code, and I'll show you a wonderful example where you will see if multiple threads are sharing some data and they are trying to modify it, you will see the problem happening, and then we'll see how to fix it, right? All right, so let's see an example in the code. Here first of all you can see I have created a basic class named as counter, and it has a variable named as count. Okay, and we have initialized it with 0, right? And after that we have created a method in this class which is increment method. Inside this we are doing a very simple operation which is count plus plus, which simply means count equal to count plus 1, right? So this means this thing. So we are simply incrementing, or we are increasing the count of count variable by 1. So every time you call this method, the value of count should increase by 1, right? Then we have created myThread class which extends the thread class. So we are using the first approach to create the threads by extending the thread class. Okay, inside that we have basically passed the counter object reference. Okay, so how we are initializing this? We are initializing through the constructor. This is parameterized constructor, so we are basically passing the counter object reference in it, and we are assigning the value of this counter to what we got in the parameterized constructor. Okay, so simply you can understand like my thread is using the counter object, right? And then in the run method what we have done is like from 0 to less than 1000, so which means it will run for 1000 times, correct? Because we have done I plus plus here, and inside that we have simply called the method increment. So increment method simply means if you are calling it 1000 times, the value should go from 0 to 1000, right? Now in the main method what we are doing is we have created object of the counter class, counter object name equal to new and the constructor. Okay, so using this we have created object of the counter class. Now we have created two threads by creating two objects of myThread class, because myThread class extends the thread class. So we have created myThread t1 equal to new myThread, and we have passed the counter object in it, and similarly we have created one more thread myThread t2 equal to new myThread, and we have passed the counter object in it. Then we have done t1 dot start, t2 dot start, and t1 dot join, t2 dot join. So basically both will run, right? But here one thing to remember is that we are passing the shared object. So we are simply passing one object in both of the thread classes. We are not creating a separate object for both of the thread objects. We are passing the same object to both the thread objects. So both are basically sharing the data. So we are taking an example where multiple threads are running in parallel and they are using the same data. So in that case, what happens? So basically you can see we have created two threads here. So both will run in parallel, and because in the run method we have written like for 1000 times we will do the increment operation. So for first thread we will increment the counter by 1000 times, and for the second time we'll increment for 1000 times. So the final value of count should come as 2000, right? 1000 due to first thread, another 1000 for another thread, so total count should be 2000. Now let's print what is the value coming as. Here you can see it is saying 1738. What? It is not giving us 2000. But why? Let's try to rerun. Now it is giving some another value 1997, but again this is not 2000. It should give 2000, right? Because we have run this method from two threads thousand times. Let's try again. Some another weird value 1707. So not a single time we got 2000. So this is the problem which happens basically when multiple threads are running in parallel and they are sharing some data. Here both of the threads were sharing the object of counter class and it had the variable count. So this was the shared data, and you can clearly see we are getting issues out there. We are not getting the expected result. But why does this happen? Let's go to the visual form and we'll try to understand this. Okay. So basically when you do I++, it appears to be a single operation, but there are multiple operations involved in it, right? We said like I++ is same as I equal to I plus 1, right? So basically this is not one step, it is mixed of three steps. First step is it will fetch the value of I from the memory. Okay. So say for example, one thread did this operation. So first of all, it has to pick the value of I from the memory, right? So this is the first operation. Then the second operation comes in whatever value came from memory, it will add 1 to it. So say for example, the value was say 5. Okay. So 5 was a value. This was a step 1. And the step 2 will be it will add 1 to this value. So it will say 5 plus 1, which becomes 6. And the third step is it will assign the value to I. So we made 6 here. So it will make I equal to 6, which means it will put this value of I to 6. So it will update it to 6 here. Instead of 5, it will become 6, right? So basically these are three steps. Now let's say there were two threads, okay, T1 and T2, right? And both were running basically in parallel, right? Now when they are performing this I++, which means I equal to I plus 1, right? The first step was they will pick the value of I from the memory. So say for example, this is your memory and both of these perform their task parallelly. Okay, at a time, both of these basically read the value from the memory. So say for example, value in memory was 5. So both of these read like 5 and 5, right? So this was the step 1. Now step 2 will be both of these will add 1 to the value. So now 5 plus 1 becomes 6, right? So here it becomes 6, here it becomes 6. Now the third step is they will basically assign this value to I. So basically they will update this value in memory. So for example, for T1, it updates 6 to memory, right? So T1 has updated I to 6 in memory. So instead of 5, now we have 6. But T2 will also update the value to 6. It should have updated to 7, but it will also update to 6. Why 6? Because both of these read the value as 5, right? Because both of these are trying to modify the same data. And this is basically not one step. These are like three steps. And this operation overall is not atomic. Okay. So I++ operation is not atomic. So as I told you, these are like three steps. And first step is it will fetch the data from memory, then add 1 to it, and then modify that data in memory. So both of the threads may read the current value, which was 5. And both of these added 1 to it, which became 6. So both of these made in memory 6. It also put it 6 here. It will also assign the value 6 here. Earlier also it was 6 because T1 already updated it to 6. And this also updated it to 6. But in actual scenario, what we wanted was, because there were two threads, it should have been 7. One by this, one by this, right? But this is not happening because this operation is not atomic. So that's why whenever multiple threads try to access the shared data, it causes issue, and that is called race condition. So basically, if you see the code, this method where we are doing count plus plus, both of the threads can go inside this method in one go. Like both are going here, both are fetching the value of count variable from the memory at the same time, and they are getting the same value. And that's why when both have performed the increment operation on it, and they have just incremented on the old value, and hence the count which should have increased by 2, one by thread 1 and one by thread 2, it's just getting increased sometimes by only 1 because both of the threads read the same old value. So what we can use here is we can use synchronized keyword. Okay, synchronized, what does this mean? This means that when you use synchronized keyword, only one thread can enter this method at a time. Okay, which means if both T1 and T2 are running in parallel, only one thread at a time can enter this method, which means if T1 enters, T2 cannot enter at the same time. T2 can only enter when T1 has come out of this method. Okay, now when we try to run the code, let's see the answer. Now it says 2000, and not once. Every time you will run, it will give you 2000. Okay, because we have fixed the root issue. The issue was both of the threads were going inside this method parallelly, and they could read the same value from the memory, both the threads. But now once we have applied the synchronize keyword, only one thread can enter the method at a time, and that's why the answer will be 2000 every time. Earlier there were some scenarios when both of the threads read the same value, and that is not predictable. That's why we were getting different answers every time, but that was not 2000 because they will go in some time when both of the threads read the same value from memory. But now when we applied synchronized keyword, both of the threads cannot enter this method at the same time, hence the answer is 2000. Now of course there are other ways as well, like instead of synchronized you can do some other ways as well to fix this root cause, but for now let's stick to a synchronized keyword, which means that when you apply the synchronized keyword with the method, only one thread can enter this method at a time. So using the synchronized keyword, we were able to avoid the race condition, which was happening when multiple threads were trying to modify the shared data. And using synchronized keyword, that problem was solved because only one thread was able to go inside the method. Now of course, apart from this as well, there are a lot of things that can be covered inside the multi-threading, like there is volatile keyword, and then there are concepts like how do you interact with two threads, wait, notify all, execute a service, and much more. But I think because we are just starting and it's a crash course, so having this much idea gives you good information about multi-threading. Once you have understood the fundamentals and you are comfortable with Java, then of course you can do a deep dive in multi-threading, because there are many other concepts which can be covered in multi-threading. So in case you want more detailed videos specific to multi-threading, put that in the comment section and I'll create a separate video on that part. But for now, we have covered good amount of multi-threading. All right, with this we have reached end of our Java crash course. We have covered a lot of topics in this video. Of course, there are many more topics that you can deep dive into. Like we can also talk about the Java 8 features and even the features which are introduced in the new versions. And there is much more in each of the topic you can go deep dive into. But I feel for the beginning, this video is sufficient so that you get good understanding of Java. And then with practice, of course, you can get comfortable with Java, and then you can deep dive in any of the topic related to Java. For example, you can start backend development using Java programming language, right? So all that stuff can be done. If you want me to make a deep dive video on a specific topic related to Java, put that in the comment section and I'll create that for you. If you found this video helpful, press the like button, subscribe to the channel and share it with your family and friends so that all of us can learn and grow together. Alright then, this is Mohit Chabda signing off. Subscribe to the channel and thanks for watching.